Okay, so we have more to do. We need to do at least 70 more push-ups. Ideally, if you look at our push-ups here, um, we gotta get, we really need to get to 170 to make up for Tuesday. But what we're gonna do is we're gonna take a break to create like a bitmap, not a bitmap inspector, a U16 inspector, and it's going to just tell us when we have when two U16 values are not identical. I want to know if that is possibly because of bit packing in the improper order. So let's make a folder. I don't know what we're going to call it. There you go. Bitmap or bitpack asserter, or do you want bitpack asserter or a bit value asserter? I guess we'll call it bitpack asserter because we're looking at bitpacked values. We're comparing them, and then if they're not equal to each other, we're going to throw an error or something, or return like maybe like a certain value, like return 1 for failure, and also print out a message or something like that. So over here, let's just make a new thing here and call it like BPA U16.C11. And also every 10 minutes we are going to do we're gonna do some push-ups every 10 minutes. So we just need to get everything done before midnight. Otherwise we will not have done all of our exercise that we wanted for the given day. So let's make a build script for this as well. We'll call it bpau16.sh, and then let's just paste in a default build script here. So open with Notepad++, and we'll just put this over here, and we'll call it HKMF. I'm just going to paste a default build script here. And we're going to get rid of this macro. We don't care about this macro. We're not going to use it. These are just macros for some strict compilation. We're going to compile as C11. We're going to target 64-bit. And for removing the executable, we're not going to do that. So we're going to keep the executable after it's compiled. Because we're going to run this as a command line utility, right? We're going to write this as a command line utility. So then in here, we will put this, we could put this over on this side, sure, why not? And then, I don't know, the build script we're probably not going to look at too much, so we might as well put this code on this side. Okay. And now we need an int main void, or actually we need, I forgot how it goes with an argument list. Is it the number of arguments and then they'll argue, well, if I were to do it, I would have like char pointer, and it would be the arg array. And then I would have int 32, which would be the number of args. Number of arguments. Let's just call it AA argument array and number of arguments, because I just don't care about naming this too much. And this is, I may have this in the wrong order, but I think this is the correct order. So this right here is argument array, and this right here is the number of arguments. Number of arguments. Okay. So, I'm a little bit tired, but we're going to try to keep on rolling through this. We're really not doing bitpacked sampler number 5. That's going to be for later. Right now, we're just kind of in an intermission session, so I'm going to cover that up. And just say intermission code. Right now, we're doing kind of intermission code, is what's going on here. So I just want to cover all that other stuff up. Okay. So we want some type of function we're going to compare. So we'll call it U32. Oh, hey, how's it going? Have you seen this stream before? Because if you haven't, I'll show you some stuff. Right now I'm taking a break to create like a little utility that's going to check unsigned integers, and if they are not equal to each other, it's going to return a 1 for failure, and then it's also going to kind of inspect it. Okay, cool. So the first thing I'll take a little break to kind of show you what I've been up to since you're new. So first of all, I have a demos page of all of the tech I've been working on, and I'm taking all these technical demos and I'm putting them into a cohesive engine design. So if we go to my demos page, wait for this to load. Yeah, I mean, right now, half the time the code I write is really boring because it's like testing code, right? So I'm like always testing code, and it just sucks sometimes. So like when people drop by, I like to just take a break and kind of show them kind of what I'm up to. So I'm working on a fractal auto tiling engine to remake a game I made many, many years ago. And this is like a little screenshot of the game. It's like a bomb game where it's kind of like Bomberman, except the bombs explode in different directions. So there's a 4-way explosion, a 2-way explosion. There's 2-way verticals and 2-way horizontals. Also, when bombs explode, they can take out parts of the level, and you can see that the floor is kind of falling out from underneath you here. And there's these little pistons you can press that emit sparks, and when a spark hits a bomb, the bomb immediately explodes. Are you familiar with... Hold on. Auto tiling? Do you know like what auto tiling is in terms of like a 2D game? Because I can give you like a quick explanation of what auto tiling is. Well, actually, I mean, this will explain it pretty well here. So usually in like a 2D... Okay, yeah. So in a 2D like RPG kind of game, Tetris, auto tiling. I don't know, I'd have to think about that. I don't think so, but I could stretch the analogy, maybe, to if I wanted to apply it to the Tetris blocks. Okay, so in an RPG game, a lot of times you lay different tiles, and the different tiles represent different materials. Auto tiling is a method where you can lay down a certain tile type, and the tile type is kind of naturally aware of its edges. Like an automazer. You know what? I don't actually know what automazer is. Let me go look that up. Automazer. Let me see some pictures here. Well, that did not get me what I thought it was gonna give me. It gave me a whole bunch. Is that weed? That looks like weed. Here, let me find something in my shortcuts here. So, there's a good video on explaining auto tiling that I saved, and I can find it really quick. I don't think you should watch the whole thing. It's like the first 30 seconds will really explain it. Oh, this is auto tiling, but this is in 3 dimensions, which makes it a little bit more complicated. But this little demo here, somebody made this like 3D auto tiling where the tiles are 3D and they naturally are self-aware of each other, and so they all latch together nicely. But let me see if I can find a 2D auto tiling example, because that's a little bit crazy. I can actually give this to you so you can check that out if you want to check that out. And I think the URL, yeah, the URL for the demo is down here. So if you want to take a look, this is not my stuff, but it's also really cool stuff. So I would definitely check that out. But that is like, that is three-dimensional auto tiling. Let me see if I can, I'm going to keep on looking through my shortcuts here, see if I can find what I'm looking for here. Auto tiling. You know, you think that with all my shortcuts, you think I would be able to find this. Auto tiling explained. Auto. Okay, I'm gonna find something on YouTube really quick. So we're gonna go to YouTube. I'm gonna put this over here because I don't know what my YouTube suggestions are, and I try to keep this channel unpolitical, so I don't know what's gonna pop up in my suggestions, but auto tiling explained. So there was a good explanation of auto tiling that I really liked. Okay, so I think it was this one, and
if this is not what you're looking for, then you can click away
oh,
from
nice,
the video
nice.
right now.
So yeah, like I guess auto tiling is also referred to as a rule tile. So the tile itself knows what's around it, right? So as you can see here, as this person's laying down this tile, you can see that there's this black border around it, and the tile set is just kind of naturally self-aware of okay, they're just going into how to make one of them. So it's really just this that I'm talking about right here, right? So there's actually 16 different subtiles that they're laying down, but the engine that they're using is going to select the correct subtile out of those 16 to make sure that everything latches together very nicely, right? So there's no everything latches together very smoothly, if that makes sense. So usually auto tiling is something people do in like a 2D game, like a 2D sprite-based game. And what you're seeing over here is me trying to take auto tiling, but I'm doing it with like fancy shader code. Picks the correct bitmap according to context. Yep, exactly, yes. So this is basically the same concept, except it's using shader code, right? So there's not actually a bitmap, but it's the same concept of like always having those kind of smooth edges, right? And the reason for this is I want to make a game, I want to remake the old game I made, but instead of using sprite graphics, we're going to use kind of like graphics like this. Not quite like this, but this, because this is a proof of concept. And the nice thing is if we zoom in here, right, so if I make every single tile 256 by 256, so we're going to zoom in, right, we still get some nice details here, right? Nothing gets pixelated, right? We just get more and more details, right? And then we could zoom out. We could zoom out to like 16 by 16, right? And then we can, you know, zoom really far out, right? So the idea is to like make it so, I'm eventually going to make a like 2.5D engine based on this kind of stuff. So just because something is 2D doesn't mean that we have to, doesn't mean the graphics don't have to be awesome, right? So 2D graphics and 3D graphics can keep on evolving independently of one another. Like they're like kind of parallel paths of evolution. An analogy I use is like human beings and dolphins and cows, they're actually all equally evolved. But they're just on separate evolutionary paths. So that's kind of how I see 3D graphics and 2D graphics. A lot of times people think that 3D graphics is just what comes after 2D graphics. But they're actually these two parallel technologies that can both get better and better and better over time. So over here, I have a tile map engine that I did in Flash. And this right here, and this right here are the exact same tile map, but I've used 3 different rendering settings on the exact same tile map data, right? So this setting I call foggy morning, this one I call sunset, and this one I call starry night, right? And The idea is when an artist makes a tile map. Yeah, rip Flash. Yeah, I wish I could show you. I could show you some of the old game gifs, but yeah, I'm bummed about that because I took 2 years to make a game with some friends, and it was almost finished. And then Steve Jobs was all like, "We hate Flash. We're not going to support it." And then I realized Flash was dying. And then I'm like, "We should probably abandon this, and I should probably work on something else." And it sucked. Yeah. But yeah, so when you're, when your artist, yeah, it sucks, man. So when your artist makes stuff, it'd be nice to have a lot of leverage with what they can do with that, right? So we get, like, these 3 drastically different pieces of art with the exact same, inputs, right? So the artist only had to draw one of these, but then we can render it in these drastically different ways. So we get, like, more bang for our buck in terms of what the artist can do, and their output, if that makes sense. Tile maps can make it, if you make a really good tile map engine, you can make it really easy for people to make, like, really awesome art very quickly. So this is an old prototype of the game with some crazy lighting. I wrote the lighting engine. It was a little bit overblown, so we toned it down for the final game. But I think that overblown like this actually gets a lot of attention because it brings to light, no pun intended, that, can you just transpile Flash? Yeah, so there's a thing called, hacks can, I think. So a lot of people, when Flash was first kind of like being abandoned, a lot of people moved to hacks because everybody was using, so no serious Flash developer, that I know of at least, or like no professional Flash developer I know of who like coded Flash games, actually used Macromedia's or Adobe's Flash software because it was like horrible. So we used a thing called Flash Develop. Develop. I think it was called Flash Develop, and then from there, there was a thing called, they took the same source code that created Flash Develop, and they created a thing called Hacks Develop, I believe. And I believe a lot of people went from Flash Develop to Hacks Develop, and that's how they did it. I experimented with a lot of things, and I experimented with Golang, C++, JavaScript, WebGL, OpenCL, a little bit of Vulkan, OpenGL, and eventually I ended up deciding on C code for the next engine, which is kind of crazy, but the idea is that I realize it's going to take me a very long time to get where I want to be. And because it's going to take me a really long time to get where I want to be, I decided, let's use a language that's just going to be around forever, right? So basically, if it's going to take me forever to code, I might as well, just a C system, generic stuff. Okay. Yeah, I mean, so, you know what, so I've watched a few programming streams, and the thing is, you know, anytime you're looking at somebody code in their, like, own code base, like, for me, it doesn't even matter how well you know C or how well you know game dev. You just, chances are you won't understand what people are writing, right? Because, right, a lot of the complexities are within the mental models and the frameworks that the people kind of like create from the ground up when they're creating their own engine. Yeah, so C, I'm hoping that C is a good choice. C has a very simple ABI, right? So if I want to create bindings for this engine, then I can basically target any other language, right? So the trade-off with C is it's going to be much more difficult to develop in, but once I make something with it, everybody else can use it. And I want to think about so game dev has kind of proliferated in the past 10 years where the tools are accessible to anyone. So I am thinking in terms of how do I survive the oversaturation of the market when all these tools are widely available to everyone? Well, the first thing is we need to do something that cannot be done in Unreal. We need to do something that cannot be done in Unity, right? In one of those pre-made game engines. So this engine, the thing we're going to do that can't be done in those engines is fractal auto-tiling. So it's pretty much the de facto. Anyone comes to use CABI. Yeah, got ya. Yeah, and I believe one of the things that makes the ABI so... I'm not, like, super good at C, but from my understanding, the thing that makes the CABI pretty easy or pretty simplistic is that since C does not have any function overloading, you don't have to do any of that, like, weird name mangling thing that other compilers have to do. But I'm not a complete expert. But the other thing is I chose C because it's a very small language, and I'm already very good at making code way too complicated, right? So if I'm already good enough at making code way too complicated, I don't want to have to use a language that's also complicated, because that's just going to exacerbate the problem of having code that is too complicated, if that makes sense. Also, I have a different priority than most people when it comes to code. I actually don't want flexible code. What I want is... cool. So I don't want flexible code. I want code that is dead simple and where I can find my way around very easily. Which is easier said than done, but I think of code more of as a house. So a lot of people think of code as this amorphous, vague idea that can just be like refactored to your heart's content like really easily, and I kind of disagree with that. I think that code is more like so people kind of sometimes think that because something is a digital asset, it's somehow ethereal and just and it can just be like shaped any way you want to shape it, and it'll just be frictionless to do it. And I disagree with that. And a good analogy for that is take like a ZBrush sculpture. Like when somebody's doing like a really high poly art asset and they have to sculpt, let's say somebody's sculpting a Greek statue in ZBrush. Well, that's still a lot of work, and if they wanted to change something about it, like let's exaggerate and say, okay, well, this statue is like a ripped statue of like David, and now we want to change the gender from male to female, right? And we want to get rid of the six-pack, and we want to like put some boobs on it and make the hair long, like. That kind of refactoring would be very difficult. It doesn't matter that it's a digital asset. Making those kind of big changes would still be very difficult. Just because the sculpture exists in ones and zeros doesn't make it really any more. It's still difficult. Like it's probably the same level of difficulty as if the sculpture was physically clay in your studio or whatnot. Now, obviously, there are some things that you have leverage with code, right? Like if we wanted to change the color of the sculpture, right? One variable, just like that. Big maintenance and designs is indeed needed, otherwise you're going to cut you badly. Yeah. So I'm doing, speaking of design, I'm using, like, I think Scrum has a place, and I use kind of like a little bit of a Scrumish design philosophy with trying to do things in sprints, but I'm also like waterfalling everything like crazy. So like I have had this engine design for 8 years now, and I've done these little prototypes, and so I know exactly what needs to be done. Well, I shouldn't say exactly, but I have a very clear idea of what needs to be done, and planning stuff out in a lot of detail ahead of time will definitely prevent you from digging yourself into a hole. So right here, this thing over here is like the preloader for the game we made. Just like a tile map where there's these entities that exist within the tiles themselves. So the entities don't actually have any graphics for themselves. They render themselves using the actual tile map. It was just an interesting concept to mess around with. I basically made like this virtual class, but it was just a whole bunch of function pointers that you had to load into the class. It was fun stuff. Here is a little demo for a tile set editor. So usually an auto tile set needs 16 tiles. And so here we have 16 tiles that I'm kind of like filling out. And this is kind of the precursor where I got the idea of having like a fractal auto tiling engine. Because I made this editor to have like these different pixel sizes, you could say. And here's some other stuff. This is not related to the engine. This is just some cool stuff. Like, this is my demo reel. So there's other kind of like cool stuff in here that isn't necessarily for the engine stuff. So this right here is just a like a snowflake maker, and it subdivides the triangles using like a little quad tree structure, and then it mirrors the pattern, but it doesn't mirror the pattern by just cutting and pasting the pixels. The subsystem is actually cloned, I believe, 6 times, and rotated. So there's actually 6 systems here that are rotated radially around the center point. And then to get the pattern to mirror, I just have a command pattern where I take the command that's used in one of the subsystems and then I broadcast it to all the other subsystems, and that's how we're getting this pattern to be completely radially symmetrical. I'm not actually just cutting and pasting pixels and rotating them. I'm actually just running 6 different subsystems and echoing the commands to all of the subsystems, right? So if I do something over in this corner, in one subsystem, it gets broadcasted to all the other subsystems, and that's how you're getting this radial pattern here. What else? So I have a big shortcut script with over, it has over 30,000 shortcuts, and the way it works is I type something, and then I press comma twice, and then it will invoke some type of shortcut. That shortcut could do anything like run a program, open Internet Explorer. It could paste a snippet to the console or to the text editor I'm working in. It could open documentation. It could open a PDF file. It could open up a piece of source code in a text editor. All sorts of things. And I found it very useful to help me. Sometimes, like, you hear a certain fact somewhere and you can't remember where you heard it. Or you wrote a piece of code, and you wrote that piece of code, like, years ago, right? And you can't find it anymore, and you're like, where is that code? So this kind of script stuff kind of helps me with that. And there's also, like, little tools in it as well. So I made a clipboard stack for it as well, and then I have, like, a clone text script. Here's another thing. So when I was talking about auto-tiling, here's, like, another auto-tiling demo I did. In like this was JavaScript and 3.js. So it was just a fun little proof of concept to say, oh yeah, 3D auto tiling, yeah, we could make that happen. That's a thing. Which is kind of stupid now that I think of it. It's like, of course, if you have 2D auto tiling, why not 3D auto tiling? But the thing is when you're coding something, there's always all these unforeseen things, right? So you might think that something's obvious, but it's still good to do a little proof of concept, even if you think it's obvious, because there might be a whole bunch of things you just didn't think were going to happen, right? And I also used to do 3D rigging. So this is just some really old technical demo stuff where I like wrote the rig for this model. I actually modeled this, and I did the rig for it as well. And it was for like a little student game we were working on. This is my retract. So all this kind of stuff. Just little scripts to help you like automate creating rigs in 3D Studio Max. Some motion graphics kind of stuff. This was in Unreal. I took some shader code and painstakingly figured out how to get it into Unreal Engine. And it might be easier now that Unreal, because this was a few years ago, but I had to take a whole bunch of code that had multiple functions, and I had to turn it into like one single function. Because for some reason, calling subfunctions in Unreal shaders was not a thing at the time I wrote this, and I just had to do some really weird hackish things. Wrote this in an Unreal Engine as well, just like a little fireworks kind of system. But yeah, so a lot of cool stuff. But let me show you what I mean about being able to find things. So, let's say, I was actually looking for this, so I'm actually going to take the, I'm going to find that auto tiling video that I just showed you. I'm going to put it in my shortcuts if I can find it again. Auto tiling explained, because I thought that video was a pretty good video for explaining it. And you already get the idea, but I want it for like my personal reference again, just in case somebody asks me about it or I want to explain it to someone. It's easy to have a video. I guess we're gonna have to go to YouTube to find it. So they're also called rule tiles. Oh, thank you. Yeah. So let's say auto tiling explain. I'm just gonna find that video, put it in my shortcuts really quick. This guy right here. So I'm gonna take this and I'm gonna paste that into my shortcuts here. So here, I'm gonna show you what I'm talking about. So let's say I have like a color palette and that I made like a few years ago. And if I do like, I'm gonna try Atomic Alice color palette. I'm gonna try that and see if I can find the information, right? So, boom, I found it. Now, now, let's say that my first guess was not correct, right? Let's say, let's make up something kind of contrived. Let's say that one color palette I made a few years ago, right? So let's like make up a contrived thing and say that guess doesn't work, right? And then we'll be like, let's try another guess. So we try another guess and we're like, let's just call it that one color palette, right? And we're like, oh no, that guess isn't correct either, right? And so then we make another guess and we're like, some color palette, right? And let's say that guess isn't right either, right? And then eventually we stumble upon the correct shortcut. We stumble upon the correct shortcut. But what we do before we continue is we take all of our guesses. GPT-3. Are you talking about the like, what do you call it? AI, that gigantic AI. Oh, mate, that gigantic, like, AI thing with, like, all those strings and it, like, parses. I've read about it on, Lex Friedman. Yeah, Lex Friedman, like that. Yeah, so Lex Friedman, like, did a little thing on, GPT-3, where it's like it has so much text, right? GPT has absorbed so much textual data that it appears to have intelligence, but it's really just super smart auto prediction, right? It's like your phone's autocorrect on like steroids, but it's just such a good autocorrect that it actually can do things like multiplication and addition, and it's like, what the heck? It's crazy. But speaking of that, so speaking of GPT-3, that's another point I want to come to. We live in a deterministic universe, and the whole point of these shortcuts is that I'm going to leverage, we're going to get philosophical here, and we're going to get really opinionated. But I'm going to leverage and take advantage of the fact that the universe is deterministic and that free will doesn't really exist. So that now free will, it depends on how you define free will. Because it's like you don't, right? But let's just stick with the universe is deterministic, right? Since the universe is deterministic, if I forget what these shortcuts are, it doesn't matter. Because what I can do in 3 years from now is I can go, if I were John Mark, what would these shortcuts be, right? And since I am John Mark, I don't have to remember these. I'll just reinvent them or recreate them because I am me, right? Now, there's a little bit of variation, though, right? So that's why we have these other guesses that might be incorrect. But the more times that I try to look for this piece of data, this color palette, the more wrong guesses I get. I put those wrong guesses into my shortcuts, and now it's even more ingrained into here. It's even harder to not find because I have made I've made more entries, right? So every time I try to guess for something, if I don't find it, all of those guesses become new shortcuts, right? And then you can also do things where sometimes what's good to do is the search space kind of explodes the more words you put together, right? The entropy, I think it's the entropy, right? There's more entropy when you make longer and longer phrases, right? And so it's very unlikely that I'm going to ever guess this big, long string correctly, right? The longer it gets, the harder it is to find it again, right? So one of the ways we're going to reduce the mental search space is we're going to try to stick to all lowercase and dashes between words. So when we do our phrases, we don't want to have something like that one color palette, right? We don't want this, right? Because if we start typing things in whatever case we feel like, then the number of permutations, right, for all the different combinations of cases, that just like explodes, right? It gets completely ridiculous, right? So we want to avoid this, and we want to intentionally reduce the amount of mental search space by saying, for the most part, we're going to keep everything to lower cases and dashes. Another thing we can do is we can create like a graph for ourselves. So let's say, did you came up with this tag system? It's very big brain stuff. Yeah, so this is something I've been using for 3 years, and I came up with it because I was, I started using AutoHotkey, right? And AutoHotkey, this is a script written in AutoHotkey. And originally what I was doing is I made a one-handed keyboard in AutoHotkey, like a chorded keyboard. I don't know if you've heard of a chorded keyboard. I think it's chorded keyboard. So a chorded keyboard is something where when you press certain keys at the same time, you get a different letter. And so for 4 keys, you have 4 bits, right? So if you have A, S, D, and F, you can press all of those keys in different combinations to get 16 possible outputs, right? So I made this chorded keyboard where it was only for my left hand, so I could keep one hand on the mouse and then one hand on the keyboard, because I thought that would like make me faster at programming. Turns out no. So from my experience after learning my chorded keyboard is that I think I tried to script something in AutoHotkey like 10 years ago. So AutoHotkey, so the language for AutoHotkey itself sucks. It sucks. I absolutely hate writing AutoHotkey. You know, it's like it was the tool available to me at the time to do what I wanted to do. But holy crap, I wrote a to optimize this file here. I had to write first I wrote a bubble sort in AutoHotkey to sort all of the data, right? Because I wanted to lexigraphically sort all of the shortcuts so that when you type a shortcut, it can do a binary search through all of the sorted shortcut phrases to find what you've typed, right? Because I have over 30,000 shortcuts, so how do we look through a gigantic list like that to find what you typed really quickly? Well, the answer is you gotta pre-sort all of the data so you can do a binary search through the lexigraphically sorted data. So first I wrote a bubble sort, right, because it's the simplest thing, but then after I got thousands of shortcuts, I had to do a tree sort. And the thing is that I couldn't just do a tree sort because AutoHotkey, data structures that are kind of like exist on the heap aren't really good for AutoHotkey in the sense of like having like a node graph or whatever. So I had to do a tree sort, but I did it with arrays. So I did a tree sort, but I did it on array data. So I encoded a tree structure into an array, and I believe that is called a heap sort. But it might not be a true heap sort from what I did. So, but heap sort is the best. Like if we wanted to identify the algorithm I wrote, a heap sort would probably be the best fit. But really, it's a tree sort on an array. But we're splitting hairs there. But anyways, so I had to write one of these crazy sorting algorithms because I just had to write the most efficient algorithm I could. And yeah, it was a pain to do it in AutoHotkey. It was. I never want to have to look at that again. Eventually, I would like to re-implement this in like Golang or something. But it's just like AutoHotkey was there. It's a tool to rewrite all this in a different language. It'd be a big undertaking. However, the good thing is that the most important thing is not actually the code. The most important thing is all these shortcuts. Yeah, you got the same experience? Yeah, like technical debt, man. So the most important thing is all these shortcuts. And the shortcuts have a very specific format, and if I had to rewrite the code that ran these shortcuts, I wouldn't have to, like, remake all the data, right? So, I think that, putting a lot of emphasis on, the data here, the data in all of here, like, woo, all this stuff, all this data is much more important than the actual code that I wrote that runs it at this point in time, because this is over 3 years worth of shortcuts. Anyways, let's put this over on the other screen. So that's just what I use for helping me remember things. Like if I don't know what a variable is supposed to be called, I'll use that. But yeah, just like a lot of crazy stuff. So right now I'm taking a break from writing test code because, so let's take a look at this system here, and let's go Control F and look for the unit test section for a second. So the unit test section, so the way I write my code is I like to, hold on, I think I searched in the wrong direction, hold on. Let me go back up to the top and do that again. Okay. So, section, unit test, yeah. So this is where my unit tests start. So I like to put my unit tests in the same file as the code that's being tested. And if you see my little scroll bar, my scroll bar is like, it's less than halfway through this file. So everything above is the actual code, and then everything beneath here is all of my unit test code. So all my unit test code, and this is just one single subsystem. And it's like a whole bunch of ridiculous unit test code, and this is like getting way out of hand, and I am so sick of this stuff right now. I don't want to write any more of this, but the thing is I want a very solid foundation, right? Like I'm writing the code in C because I know it's going to take me forever, and I don't want the language to like go away by the time I get all this stuff done. Another cool thing I'm kind of doing, which I don't know if you've seen before, but to get like your unit tests packed really terse, you can make like a little table, right? And so each one of these, so I have like a little array here, tab UTC, that stands for table of unit test data. Let me see if I can zoom in here for you. So table of unit test data, right? Or unit test code, sorry, my bad, UTC unit test code. And we initialize it, and every single one of these entries here is one test case, right? So now I'm not sure if which ones are the inputs and which ones are the outputs for this table. Oh, yeah, so I get a little bit, oh, so I have yeah, it's my art degree. It's my art degree. That's probably why I do things kind of crazy. So So because I format everything on a very case-by-case basis, I don't auto-format any kind of code, and I'm very much a spaces over tabs kind of person, because there's no way that you could customize a tab to be 2 or 4 or 8 spaces and view the code as I intended it. So also this code is written for a vertical monitor. So I think that code should be very linear. So this code has a 64 column limit. So this line right here that you're seeing on the right, that line is 64 columns. And so a lot of how I write my code is I try to write my code very tersely so that I never exceed the column limit. You see this, how I'm never exceeding that column limit? Like, I'm pretty militant about that. Now, sometimes things will exceed. Usually those things that exceed the column limit are going to be to-do messages. This is commented out, so I'm probably going to just delete that later. But anything that goes past the column limit needs to get my attention. Now, this is just... this just sucks because, right, sometimes your tokens get really long and you can't help but go past the column limit. For this, I might actually break my formatting, right? Like, I would rather break my formatting and do this than go over my column limit. And the reason is that I don't want to ever have to, like, scroll left and right. I want to only be able to scroll on one axis and just linearly scroll through everything and kind of see what's going on. I do know kink shaming. All right, yeah. So, so the other thing is sometimes defines get really out of hand. So the way I use defines is defines are usually local to a section. So let me explain that for a second. So for example, this section is called info status message. Let me explain sections in the code for a second. So if I highlight this, we can see that it's highlighted down here. When I was first starting to code professionally, one of the things that really annoyed me was I would read a comment and I wouldn't know where the comment ended, right? Like a comment for like a block of code. Sometimes it wouldn't be obvious to me where that comment's jurisdiction ended, right? So in order for me to always know where a comment's jurisdiction ends, a lot of times I will left justify where the jurisdiction of the comment begins, right? And then I will right justify where the jurisdiction of this comment ends, right? And then everything in here is under the jurisdiction of this section here. So it says info status message. So we got a info message helper function. We got a info message that's overloaded to take decimal. We got an info message that's overloaded to take any type of data, right? So like a void pointer, so a void pointer of any kind of data. We're also pretty crazy with our parameters, right? So our parameter list is usually one at a time. So here's our parameter list. Now, some people would say this is kind of crazy, and I do agree it is a bit crazy, but it's kind of just, it works very well with the fact that I kind of make everything very vertical. Now, I believe, I don't know what Jonathan Blow said about doing stuff like this, but it was not a positive thing, whatever he said. And I think that, you know, he is somebody who, you know, if he says something, I think that, you know, you should definitely take it into consideration when he says something, but also be your own person, right? So, you know, listen to someone's advice and then disregard it if you must. What else? So, let's talk about the namespacing here for a second. So, what I really hate about a lot of C code is with these standard library functions, and I understand why they do it, right? So, like with printf and flush, like you, yeah, he would not, yeah. So with like printf and flush, right? You need to know you need to know what libraries they come from, right? Like, there's nothing in these tokens that's going to tell you where that came from, right? And that's a aspect that kind of always annoyed me, and I get why they do it, right? Because if it's a very common function, you don't want to have to type a lot of characters to get access to it, right? So I was like, you know what, if I'm going to write my library, I want to make it absolutely obvious to anyone who's new to this code base that it's where the code is coming from, right? So AAC 2020 is the project namespace. So AAC 2020 stands for Atomic Alice 2020. So 2020 stands for year 2020. So this is the established date. So year 2020 was when I started working on this code, right? AA, Atomic Alice, and then the C is for C as in like C99 or C11. I'm actually compiling as C11 because I like the fact that C11 has a proper memory model, though after doing a little bit of multi-threading and seeing all of the pitfalls of multi-threading, I think I'm going to stay away from multi-threading. For example, one pitfall of multi-threading, which is not very obvious until you do it to yourself, scoping nomenclature. Yes, there we go. Yes, that's exactly what this is. Yeah. So one of the downfalls of... Hold on. Let me rewind here. Namespaces... And I totally forget. I'm all over the place, man. Let me take a drink of water. Let me collect my thoughts here. Where was I? So, namespaces, people knowing where you are. I didn't explain this other namespace, did I? So, with the scoping nomenclature, project namespace, this is the subsystem called PAINT5D, and this is going to be the tile editor for my artist. So this is going to be the thing that's going to create the graphics, or the base graphics of the game. And you have to think that the best rendering engine is absolutely nothing without artist input, right? Like, all graphics engines are actually equivalent with no artist input, right? They're all black screens, right? If there's no lighting and there's no 3D models, right, and nobody worked on any effects or put any effects in it, then all you got is a blank screen. You got a black screen, right? Or, well, I guess some people might have a different clear color, so maybe some people have a black screen, some people have a green screen, some people have a white screen, but the basic idea is it doesn't matter how awesome your rendering technology is, if you don't have good inputs, garbage in, garbage out, right? So let's kind of explain how this first editor is going to work since you're here. Also, I'm going to have to take a break for like a few minutes to do some push-ups because I need to do more push-ups, but I'll show you this, and then it's going to be like a 20-minute break just because I have to get my exercise in. Like, I've been put on a whole bunch of like so yeah, I'm going to show you this for a second, but then I have to take a break to get push-ups done just because the lockdown and whatnot has been making me pretty pudgy. Lockdown and then like some other drugs that my doctor put me on that like increase weight gain. So it's like I'm just gotta get that exercise. Sounds good. Okay, so I'm gonna show you this first, and then I'm gonna show you a little preview of... Yeah, I'll show you this first. Let's take this. It's the data file. So I am doing data-oriented design, but I'm not an expert at data-oriented design. So I'm taking basically, I'm just going to base all of my code on one quote, which is, show me your code and I'll have no idea what you're doing. Show me your tables and I won't need to see your code. So that's kind of the one of the big philosophies of what I'm working on here. And so I'm separating all of my code into two files, a data file, so paint5d.d._, and a function file, paint5d.f._. The reason I'm separating into data and functions is because when people do object-oriented programming and they tightly couple their data with their functions, they sometimes end up with what I call an artificial dependency loop, right? So let's say that like A A calls B, and B calls A, or something like that, right? Like class A calls something in B, and class B calls something in A, right? And oh, awesome, awesome. Yeah, so let's say class A references B and class B references A, right? So now you got a problem. You got a cyclic dependency. Like, how do you resolve that? Well, actually, what is happening most of the time is that function A is using data B, and function B is using data A, right? So really, if you include all of your data first, right? You include data A and B first, and then you include functions A and B, all of a sudden, your dependency loop magically goes away because you've sharply delineated between where your data is and where your functions are, right? And so most of the time, when you see my code, I'm going to keep the data is always going to be on the left, and the functions is going to be on the right, because data comes before functions, because functions depend on data, but data does not depend on functions, right? So I'm trying to kind of keep that separation. And the other thing is I'm trying to keep the project very coarse. So this is, in this function file, right, it's gigantic, right? Like, it's gigantic. But the thing is I'm thinking in terms of, yes, it's big, but it's all the stuff for this one subsystem, and I would never want two people working in the same subsystem at the same time. So even though you could break it into... Yes, exactly, yes. Decoupling logic from data can remove code dependencies. Yes, exactly. Yeah. Yeah, so I'm thinking about, like, I don't want to ever break down things too coarsely, so sometimes there ends up being a lot of things in one file. However, even though it may seem that, oh god, there's a whole bunch of stuff in this file, this is out of control, I am trying to stick to a Linux philosophy of do one thing and do it well. I'm also trying to stick to a Linux philosophy of flat is better than nested. I'm also trying to make sure that I obey Yagni. You aren't gonna need it. So I don't... unless I need something, I'm not going to code it. If I think I'm going to need something, I won't code it. Also, I won't ever break something out into a subfunction unless it has more than one call site. So I'm never going to try to... I know, like, clean code says, like, oh, break everything into small functions. I really disagree with that. I actually find code a lot harder to follow when you break things into a whole bunch of... maybe. Yeah, I don't know. That's a good question. Does it naturally put you into functional? So, when I think of do one thing and do one thing well, I think of it as, before I start coding a subsystem, I want to know exactly what its job is, and I don't ever want it to do anything outside of that. Now, I'm not sure if that means I have to write things in a functional style. I do like the appeal of a functional style where it's, like, very hard to make mistakes with functional, right? Because the, right, like, you just pipe things from one function to another function to another function, and because all your functions are chained together, there's no room to like, screw something in between, right? Like, how do you explain? I don't know. If you've done functional before, you kind of know what I'm talking about, where it's just very hard to, like, make stupid mistakes that you would make in other styles of coding. But then functional isn't as efficient as imperative, because you have... Functional tends to, like, do a lot of recalculation, and that kind of sucks. But I do like some of the, like, if you were writing code that did not have to be super performant, which sometimes that may be the case. If you're writing code that doesn't have to be super performant, then writing functional is a great idea, which generally generates to very refactored functions with close to no state, becoming pure functions, I think. Yeah, so, yeah, I wish, I think the idea of having, like, a pure keyword, I think John Carmack kind of said something about that, where, like, he kind of wished there was a language that had, like, a pure keyword, where you could say, if we put the pure keyword on this function, then we can guarantee that it has no side effects. And I think that's a great idea. I think it's a great idea to, know which of your functions are pure and which of your functions aren't. I think that's a great distinction. I think knowing that distinction can really help you, right? So you see this diagram here? So this diagram is 512 by 512 pixels. And these pixels encode graphical data for a tile map. And the way the tile map works is there are different tiles of different sizes. So there's 128 by 128 of the smallest tiles, and there's 3 layers of them. So this is the second layer, and this is the third layer. And then the next partition of tiles, these tiles are twice as big, and because they're twice as big, there's less of them, right? So they get a smaller partition. And then we keep on going down and down and down, and then eventually we get to, say, 1 pixel down here. And that 1 pixel is a gigantic tile that covers the entire tile map. So this is how I'm partitioning data for my auto tile sets. And then right here in this diagram, this is the user view. So my auto tile set, rather than having 16 subtiles per auto tile set, is only going to have 4 tiles for auto tile set. So we got this corner tile, this corner tile, this corner tile, and this corner tile. Create 1 auto tile set in my engine. And then from these 4 tiles, I actually am going to create the other tiles, the 12 remaining tiles, to create a 16 tile auto tile set. So a lot of times, so for example, the tile that's touching everything is going to be generated from these pieces of data here. A tile that's an edge tile on the left will be generated by taking this data here. We'll take the data in between here for the top edge. For the left edge, we'll take the data over here, right? For the corner, we'll just take the original tile, but we're going to procedurally generate a lot of tiles rather than have the artist have to come up with all 16 tiles. So since the artist only has to come up with 4 tiles to create a 16 tile auto tile set, that means the artist will be 4 times faster in this engine than if they were creating art assets for another engine. The other thing is because there's a lot of redundancy in 16 tile auto tile sets, it makes a lot of sense to do this kind of auto generation, because if you hard code 16 graphics for an auto tile set, what you're doing is you're wasting memory. You're wasting memory in your game engine to store all that redundancy for those 16 tiles. And you're also wasting artist's time, because now the artist has to make 16 tiles rather than 4 tiles, and the artist is doing a lot of grunt work where they're just kind of like, right, a lot of the creative work is mostly in like these 4 tiles or in a few tiles, and then everything else is just grunt work to repeat the pattern for the other tiles. So if we can, we want to leverage our data. We want to leverage our data and get the most bang for our buck out of the data. Suddenly, group theory. I don't know much about group theory, but I will take your word for it. So we want to leverage our data as much as possible. So if they only need 4 graphics, if the artist only has to create 4 graphics rather than 16, we've leveraged our artist's productivity. We've leveraged our artist's brain cycles, right? So they can make 4 times the artwork with the same amount of brain cycles. And a math field about topological symmetries. Okay. And then Also, since it's only these 4 graphics rather than 16 graphics, then the engine only needs to store this in memory rather than 16 tiles, right? So it uses 1/4 the memory in the engine, so it's efficient with the engine, and it also uses 1/4 of the artist brain power, right? So we are increasing the efficiency of both the human being and the engine. Now the trade-off is that we are going to have to generate some of those 16 tiles on the fly, right? So we're going to have a trade-off between how much data is used and the processing, right? So a lot of times there's this trade-off, right, between processing and data, right? So a good example is a lookup table, right? A lookup table is a trade-off between we're going to do less calculations because we're going to hard code all of the answers into a lookup table, but now we have to use more memory, right? So you have to figure out, like, you have to be cognizant of that trade-off and decide what kind of trade-off you want. Since I'm going to be doing all of this stuff in kind of shader code, and shader code is pretty fast, and I'm not doing too much crazy stuff, I'm pretty sure this is a good trade-off. We'll kind of see as I go. But anyways, I have to do my push-ups because if I look at my thing here, I have 70 more to do if I want to at least get to my 100 for the day. So I'm going to put on a little timer for like 20 minutes, and then I will be back in 20... Actually, we're going to do like, let me think. Do I want to give it 20, or I'm going to give it 30, because I would actually like to get a little bit extra done, because if you see on Tuesday, I did not get 100 push-ups, so I've been doing a little bit extra, and it's almost midnight, so I'm going to just try to cram out at least 60 push-ups. Oh no, I need to get 70, at least 70. Yeah, so I'm going to start a timer, and the way the timer works is if I get done early, I still wait for the timer to go all the way down. So whatever I set my timer for is what is guaranteed for you to be a break, right? So I'm going to do that now. So let me just, I'm going to pop open my browser here, and I'm going to go to countdown timer. And then, let's see, is this, this is not the right timer. Oh, this is not the right timer. I want to go on my break timer. Okay, there we go. And we're going to set this to 30 minutes. And I'm going to turn on some music. And, hold on. Media, open folder. I'm going to turn on some music. MP3s, open that folder. Okay, and 30 minutes. It was good talking to you, so maybe I'll see you back here, maybe I won't. But it looks like, did you subscribe? It looks like you did, because I see 45 followers instead of the 44 I saw earlier. But thank you if you subscribed, and I'll be back in 30 minutes, and enjoy your smoke break, because nicotine, get that brain working. there we go. Turn up that volume. Okay, cool. So we got the volume. Okay, so here's what I'm gonna do. Like later, if you come back on the stream, like I don't know if you're here, but actually I'll just send you a message just in case. Actually no, I'll send it in the chat. Oh, you're here? Okay, well then I guess I'll tell you what libchan is all about then. And then once I tell you about libchan, I'm going to get back to writing my, oh nice, okay, cool. So it's probably kind of obvious that I'm kind of a, maybe that's not obvious. So I'm kind of a pocket knife person over a blender person. Like if I had a kitchen, like when I lived by myself, I had one spoon, one knife, one plate, one bowl, one pot, right? And my idea there was, well, if I have only these very simple tools and I only have one of each, then there's no way I can like make a mess in the kitchen, right? And so the way I do things in a very stripped down kind of way. So my development environment is very stripped down. I'm just using Notepad++ and Bash scripts. And I think that kind of helps me write code better, because sometimes the IntelliSense, it helps you find things, but then it encourages you to write sloppy code. And then you'll notice that I'm not really a master of, I'm not very much of a master of, what do you call that stuff? Metadata? Not metadata. Markdown. I don't know shit about Markdown, so I was like, you know what? I'm just gonna, I'm gonna use a Markdown header, and then the rest I'm just gonna indent as code. Like if you're looking at my README, right? It's just like in there, like it's just a big code comment basically, right? So there's a whole bunch of weirdness about how I do things. I think that, you know, as you've code for longer and longer, I don't think it's just me. I think anyone, you know, the more we code, the more weird habits we get, right? Because we get these, like, things that, that just happen from, like, writing code so much, if that makes sense. Also, I've done a lot of experimentation with writing code in different ways. Like, you'll notice that my name is Kanji Coder, right? And, like, why is my name Kanji Coder? Well, that's because I experimented with elaborative encoding techniques, and I thought an interesting way to write code very tersely would to use one Japanese kanji per class. So there's a video called... I was following everything else but that last... Oh, don't worry. So so let's say that I have a class and it is called... so let's say I have a command prompt class and my command prompt is nicknamed Dragon, right? So instead of saying class Dragon command prompt instead of saying this in my code, I could call it class T Dragon. Wait, hold on. Hold on. I got this. I could call it this. Hold on. You're going to see it in the chat in just a second. So instead of saying class Dragon command prompt, I could call it class T Dragon like this. So basically, I'm doing a whole bunch of very horrible things that people hate. So first of all, I'm using a Hungarian notation. So I'm going to say T for type, and the type is going to be Dragon, and Dragon is going to stand for Dragon command prompt, right? So the only way you could tell what the code does is you have to do a thing called RTFM. And so the idea was like, oh, maybe I should write code in a way where people can't grope their way around using IntelliSense, right? Because there's no context clues. You actually, if you want to know what T-Dragon is, you actually have to go to the class and read up about it. Now, the problem with that is it involves a huge amount of front loading, right? So for someone to even start writing a little bit of code, they have to, like, read through every single class to, like, get the big picture, right? Because they can't make any assumptions. And after trying this as an experiment and actually writing a 20,000 line code base in JavaScript and another 20,000 line code base in Golang, both being the same exact code base, but one written in JavaScript and another one written in Golang. So I did Golang and OpenGL, and then JavaScript and WebGL. And after doing that, I've kind of decided that, yeah, RTFM is a good idea, but you gotta let people make some level of assumptions with your code base. Like, we are, unless the only people working on your code have, like, photographic memories or eidentic memories, unless somehow you're just that lucky and everyone working on your code base is just, like, a complete genius, you really want to allow people to make assumptions and have ways that people can kind of get into your code base easily. So I decided that writing class names using kanji was a interesting experiment in writing terse code, but ultimately unmaintainable for me. A huge barrier to entry for other people to mess around with my code. And then the other thing is that I'm the only one who can do it, right? Because I have, like, scripts that let me type these Japanese kanji, like, really quickly, and other people using an English keyboard don't have that luxury, right? So I'm making the code hard to edit. So it was an interesting experiment, and I think that people should experiment with different styles of writing code, because, yeah, it is, it is pretty batshit crazy. So actually, I can probably find, like, a snippet of that, of, like, let me see if I can find something on Imgur for a second. www.imgur.com. Like, I have some examples of what I was... Oh, wait, no. Imgur, not with a... I need, like, a little... I need some type of addition to Chrome that will prevent me from going to sites that are typos of the sites I want to go to, because I swear that one of these days I'm going to get a virus from typing the wrong URL, and it's going to take me to some site that's just going to inject me with some JavaScript shellcode nonsense or whatever, and I'm just going to be in trouble. But if I go back far enough into my Imgur, I might be able to find some stuff. So also, I have some mechanical patents I've been working on as well. So if you wonder why there's a lot of industrial design stuff in my Imgur page, that is why. And also just things I find funny, like the Gundam duck. Chrome Omni suggestions went to shit in last year's Omni suggestions, huh? I'm not familiar. And I'm going to have to go pretty back, but I'm going to keep on going because I know I can find an example. The address bar thing, got it. Let's see, further back? It should be actually back pretty far. Let's see. Oh, this is my Stack Overflow profile icon right here. I don't know if it's appropriate or not, but I have a morbid and violent sense of humor in some regards, and I find this fucking hilarious. Actually, hold on. I know I'm on a rant here, but yes, very professional. Yes. Let's see if you can find my Stack Overflow really quick. Yeah, so right here, Stack Overflow. How do I see my profile? I haven't done this in a while. Public, home, maybe? Yeah, I don't know how to quite use... Yeah, but there I am right there. There's my little icon. So the only reason I have a lot of Stack... Or, I don't know, I have a medium amount of Stack Overflow cred. That's just because I wanted to learn, like... what do you call it? some stupid framework. Oh, Angular. I wanted to learn Angular 2. Holy shit, so karma. Holy shit, so karma. I wanted to learn like Angular 2 or something. And what is karma? I thought karma was Reddit. Oh yeah, so I wanted to learn a framework for a potential job interview. And so as I was learning it, every time I got a compiler error. So since I don't use an IDE, I get a lot more. Oh, got ya. Since I don't use an IDE, I get a lot more compiler mistakes than most people because I don't have any like squiggly things showing up when I type something wrong, right? So as things kind of pop up and I get mistakes, every time I get a mistake, when I get a mistake, before I fix a mistake, so here's what I try to do to get points on Stack Overflow. Every time I make a mistake, I Google it on Stack Overflow, right? Or I search it on Stack Overflow, and then I answer it, right? So rather than trying to look for questions to answer, every time a problem comes up, I go to Stack Overflow and try to figure out who's asked the same question and then do that, right? And I haven't been doing that too much lately because it's like, I don't know if it's worth my time. So so without getting into too much details, I am in a position where I'm the opposite. I do everything in Visual Studio, even Linux stuff. I'm a fucking pleb. Well, I mean, Visual Studio is awesome, don't get me wrong. Like, I used to use Visual Studio all the time. It's just that my coding style has, like, gone batshit crazy as I've gotten older. But yeah, when I was a kid, I used to use Visual Studio a lot. That's kind of weird to say. Yeah, I used to use Visual Studio a lot as a kid. But yeah, I used to write, like, a lot of Visual Basic. Yeah, like, right, because it kind of fucks with your, it fucks with your memory a bit, right? So, so the way I do things, so here's what I'll do. So let's say I don't know what a variable name is in my code base. So you probably noticed a lot of my variable names are kind of weird as hell. So let's say I think there's a variable named pixel array, right? So if I type pixel array like this in 2 commas, it'll correct it to the correct format. Now, if I type it like this, pixarr like this in 2 commas, it will put a little check mark next to it to say, hey, you got that correct. Now, for newer variables, I'm a little bit more careful. So let's say we have a tile exponent. So tile exponent, TIL underscore exponent, 2 commas. Really, is that an old one as well? Okay, hold on. We're going to correct these ones really quick for a second. Hold on. So, tile exponent, where are you? I know you're in here somewhere. A lot of stuff. I should learn my regex better so that I don't have to do this, search through here like this. I actually have some pre-made regexes for this kind of search, but, Okay, we're gonna try this. Hold on. Probably find it here. I'm going to read your comment just as soon as I figure out where the hell I am. That's not what I want. Tile exponent means, tile exponent. Okay, so right here, if I type it correctly, I have a little check mark to say I typed it correctly. Now, the problem with doing it like this is because I could type exp, and if exp is a variable, and I type tilexp, I'll get a check mark, and I'll think that I typed the thing correctly, but I actually didn't. So to fix that, from now on, when I type something and I want to spell check it, I'll put it in square brackets to confirm that that's the variable, right? So instead of IntelliSense, what I'll do is, let's see if I can find something kind of further up here. What about pixel array? No, pixel array, let's just look through here and kind of find a variable. Number of pixels, total pixels. I know I've made a lot of variable names recently. Okay, so DIPIY. And what was that for? Well, let's not worry about what that's for. Let's just do it. So let's go over here for a second and say DIP underscore IY like this. And if I go 2 commas, it surrounds it like this and puts a little checkbox. So rather than having IntelliSense suggest what to do, I take a guess and I basically quiz myself on it. So it's like a Intella quiz, you could say, right? So if I'm trying to reach for a variable and I'm not sure what it is, the first thing I want to do is kind of take a guess at it and see if I can guess correctly to try to reinforce my memory a little bit better. Also, if I want to know what this variable is, I can go DIP IY means, or, well, that's not correct. Sorry, DIP IY means. Okay, so I guess I didn't make that one. I'll have to spell it correctly. DIP IY and then means. And then we can see that we have a little summary for what this variable is. So it stands for discrete pixel. So DIP is for discrete pixel. And then IY is for the frag chord. So IY means integer y. So what I mean by discrete pixel is in OpenGL. In OpenGL, the convention is that pixels have a center coordinate, where when you get frag chords in a shader, they're always float coordinates, and they're always like 0.5, actually 0.5, 1.5, 2.5, 3.5, 4.5, because the coordinate is the coordinate of the center of the pixel. Holy shit, macro to summon documentation. Yes, yes. And in fact, if I need some documentation that's like more detailed, let's do like AAC 2020 diagrams for example. Okay, diagrams. So we don't have that. Let's do atomic Alice 2020 diagrams. See respective star dot D. So I don't really have a centralized diagrams thing for the AAC 2020. So I'll make a note for that for later. But I had some older stuff where I made diagrams. So let's say atomic Alice 2020 diagrams. Let's try that. Nope. You could develop an IDE around those features. Yeah, so the idea was to have, like, use my shortcuts as an IDE agnostic kind of thing, where I can use these shortcuts in any development environment. So I can, like, if I am at a job, right, and the job requires me to use a certain IDE, I can load up my shortcuts and just be, like, have all my snippets kind of, like, at my fingertips, right? So, AA2, how about AA2 diagrams? No luck. So remember how we said, like, the longer the word is, the more entropy it is, so the harder it is to get a correct guess, right? So one way we can help ourselves out is to say something like, let's make a shortcut called diagrams, right? And so we don't have a shortcut called diagrams. Less collisions, yeah, exactly. So let's make a shortcut called diagrams, and we'll use it to give us a prompt to get to different diagrams. So the next time we're trying to guess around and we're trying to get diagrams, if we type diagrams, we'll have a suggestion that gives us the correct thing to type to get to our AA2 diagram. So I think for whatever reason, it is called AA2 stream for a reason, because it was like a stream of consciousness kind of thing. Yeah, so this thing here is a whole bunch of diagrams. So this is like a stream of consciousness for how to do some things. And some of this stuff is just ridiculous and stupid now. But I like to diagram out all of my thoughts, right? So this is just a big, like, conceptual, it's just a big mental dump of how I was going to make my engine. And I wrote this like 3 years ago. So some of the ideas in here, oh, I guess this is 2019. Some of the ideas in here are still good. Some of them are bad now. But some of them are good to keep, right? So you see this kind of like quad tree kind of structure. So this is like a MIP map. So basically I use a MIP map like structure to encode a quad tree structure in a contiguous segment of memory. And I think I kind of showed you something like this earlier in the main code base, but this is kind of where that idea kind of came from. You are truly one of a kind in a good way. Yeah, so yeah, I hope. So I like to think that, I like to say that people are rare, but never unique. So that's what I usually like to think, that people are rare, but never unique. So, like, somewhere out there is my fucking doppelganger, and I need to find them to get them to work on this project with me. But the problem is that my doppelganger is also working on their own thing, so I'll never be able to recruit them when I find them. But I think, like, if you've ever tried to work on a project and get other people together on it, the hard thing is when you come across another programmer who you're like, I want to work with you. Yeah, exactly, right? You come across a programmer who's actually worth their salt, but the problem is that all the programmers who are worth their salt are doing their own fucking thing, right? And so, that sucks. That fucking sucks. So I'll give you some advice that can help. One thing that can help is do your own thing for a while until you get a nice prototype, right? And once you have a nice prototype, you have a little bit more leverage to get those good programmers or those good artists on your team, right? Because people who are like really good at what they do, they don't want to be on a train wreck, right? The people who are really good at what they do aren't just going to say yes to any person who says, hey, I have an idea, right? And so if you want to get those good people, you can't just say, I have an idea. You got to be like, I have a prototype, right? And you say you got a prototype, and then you can get people. So, like, what I like to do is I like to collect people. So actually, let's, well, first of all, let me take this diagram here, and I'm going to put it into here, right? I'm going to take these diagrams here, and for next time, I'm going to be able to access this really quickly, right? And it's really not diagrams, though, so I'm going to say use AA2 stream stream of consciousness for AA2 tech, written in 2019. I'm going to paste that. AA2 stream. Let's take this. Oh, this is already a thing, though, right? AA2 stream is already a shortcut? Yeah. AA2 stream is already a shortcut, but not AA2 underscore stream. Okay. Edit file. And I'm going to read your comment right after I finish up this thought. Try AA2 stream. And then sometimes I like to date my shortcuts, say it is 2021, it is 01, it is 22. Okay. About 5 years in university environment without finding a single soul with such enthusiasm or similarities, it was kind of depressing. Yeah, so I went to DigiPen. The dropout rate for artists, which I was an artist, I did make it through, I got my degree, was 80%. And with the 80% dropout rate, you had really high caliber people. So the higher your dropout rate, I think, the higher caliber people you'll be surrounded with, which is a good thing to note for the future, because I was shocked. I was shocked by the caliber of people that I went to school with. Like I never liked working on group projects in high school, but when I went to DigiPen, I'm like, oh my god, everyone's competent. Actually, working on group projects is not bad when you're in a group of people who are actually competent. So let me show you something. So let's do programmers to stock. Let's try that. Nope. How about coders to stock? I know I got a list. I know I got a list here. With same motivations. Yeah, exactly. How about programmer peeps? I'd probably call it programmer peeps. Yeah. These are their Facebooks. Probably shouldn't be showing that, but they are public Facebook profiles. I'm going to take this for a second. Full file path to clipboard. let's see, programmer of Facebook. That looks like programmers of Facebook. I know I have another list. Oh, I know what it is. Edit file. So I'm going to take this because that's also a good list of people that I'm just keeping tabs on. But also it is, I think it's called devs to stock. I think that's what I called it, devs to stock. So like when I find somebody who's interesting on like YouTube or whatnot, I started making a list. So here's the guy who does like Marble Marcher, right? So there's his YouTube channel. I don't have their personal information, but like anybody who is like doing something of a high caliber that I kind of stumble upon on the internet, that I just kind of like take note of who they are. And you know, Joshua Fluke, you might be familiar with, right? And I don't know if this is their actual email. I think this is probably a burner email of theirs, right? But I just kind of like collect information about them. Here's my brother. But yeah, I just try to collect information so that like if I ever want to build a team, I've kind of like collected. I've collected people, right? So let's say that devs numbered list of devs to stock, and numbered list of devs to stock, numbered lists of devs to stock. Okay. So what we're gonna do is we have programmers to stock and we got coders to stock. We're just going to say pick, and we'll say DTS numbered, or DTS right, so I'll make a list here. Right, and we got all these synonyms. So this is going to be, this is my numbered list of devs to stock, so DTS numbered. Right? And then right here we're going to say DTS devs to stock, right? So yeah, it is kind of like I am kind of like making I am kind of using my shortcuts as like as a query language. You could kind of think of it like that, where I'm kind of because I'm using my shortcuts as like a database in a way, right? Because it's not just for snippets, right? It's like it's a knowledge base, right? But yeah, so DTS numbered, and then DTS Facebook list. So I'll put this here, and then DTS Facebook list. So you'll notice that like DTS numbered and DTS Facebook list, these are never things that I actually intend to memorize, right? Because they're not in a natural language. Like I expect that I will, you know, remember to type, you know, programmers to stock, or I'll remember to type coders to stock, but I don't actually intend to memorize DTS numbered or DTS Facebook list. But sometimes I will have my shortcuts made in a way that helps kind of enumerate them, right? Because we have this common prefix of DTS, right? DTS numbered versus DTS Facebook list, right? And that's just to help me kind of categorize things a little bit, right? So the next thing we could do is we could write stock. And stock has a kanji for it already. So what I'm going to do here is I'm going to look for the stock kanji. So I don't really do any programming with kanji anymore. I was going to show you that. I'm going to show you that once I find this for a second. So it looks like I was using this kanji for swizzle, which is kind of crazy. I'm going to take the I'm going to take the Unicode code for the kanji, see if I can find it in my shortcuts. Where are you? I know you're somewhere. Oh, it's right here. I'm just not paying attention. So I'm going to take this shortcut. So at one point I was numbering my shortcuts. So this is a very old shortcut back when I was numbering my shortcuts. It's shortcut number 113. I'm just going to make a insertion here. And I'm going to say stock kanji, and stock kanji. And I'm going to paste this here. And then make a note that it is this kanji right here. Paste it right here. And I'll also make a note of when this was inserted, right? So I'll keep like a revision history in here as well. So I'll be like, inserted date. And it's like, really labeling the date at which this was inserted is probably kind of pointless. Like, I don't see when it would ever matter. But it's kind of nice to... there is something rewarding about looking through your shortcuts and seeing that, oh, I wrote this shortcut like 3 years ago. I wrote this shortcut 5 years ago. There's something rewarding about that, like psychologically, to be like, oh, I've been building up all of this stuff for like years. Like, there's something rewarding about that. So I don't think there's any utility to this right here, but there is some psychological satisfaction. But I guess maybe you could say that there is utility and psychological satisfaction. But anyways, we're going to go up to the top here, and we're going to find stock, and we're going to say pick, and we're going to say stock kanji, or stock list, and then we'll say stock list, and we'll say try programmers to stock. And you know how I said that I use dashes when I write a sentence? So you might wonder, well, why do I have like underscores? Well, I have underscores here so I can just double click and paste. And I've double clicked and pasted, so I absolutely know that I haven't made a typo. So a lot of times in my prompts, I will use a underscore version, but if there's an underscore version of something, then there is also a dashed version of the same thing. Okay, so try that, and then we can also make a date for when I made this entry, 2020-01-22. And then there we go. So now if I ever try to look for devs to stock, right? So if I write devs to stock or something dash stock, this shortcut will be invoked, right? Like if I do some type of like gibberish dash stock, it'll read backwards and search through for a shortcut match, and it's going to find this right here. Also, if you want to know how my shortcuts are implemented, my shortcuts are all stored in a sorted list, but all of the shortcuts are actually written backwards. So there's no entry called stock. So this thing that's stock in the memory, it's not going to be stock. It's going to be KLATS, right? So there's not going to be an entry called stock in the actual data. There's going to be an entry called CLATS, right? And the reason for that is because as I'm typing stuff, we want a scrolling window that tries to find a match, and I found that it's easier to create like a scrolling window that keeps on looking for matches if the entry is written in the data backwards. So like if I write so if I type S is put into the queue. If I type TALK, so this is the last thing. K is the last thing in the queue, right? If the last thing I typed was K, then K was the last thing. So it looks for K in my sorted list of data, and it finds a K, right? Then it looks for a KL and finds KL in the sorted list of data. Then it goes KLA, right? It keeps on walking backwards through the sorted list of data, and then actually goes all the way back here, and it finds a full match, right? Now, it will try to find the largest full match, right? So if I have a shortcut called pizza and I have a shortcut called pizza pie, it's going to match the longest thing. Or actually no, I mean to say this. I meant to say this, right? If I have pie and I have pizza pie, then it's going to match this. So it's going to go backwards, and yes, pie matches, but it's going to keep on going back to see if there's longer matches, and it'll take the longest match that you type. So that's how I resolve substrings. Like what do we do when both of these shortcuts, this shortcut here is a substring of this shortcut. How do we resolve that And the way we resolve it is we take whatever's longest. Also, if we hit the Enter key, whenever we hit the Enter key, we erase the queue, right? So if we want to start over fresh, we can hit the Enter key to start over new. Also, the backspace key, I believe, will... Oh, actually, the backspace key does not. So if I type index to XY C99, right? So I got, like, these index to XY snippets. My queue of keys that I'm pressing is actually backspace aware. So if I go index to XY, and then I go C blah, 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 and I forget what I was doing, I can backspace, say, oh, it was C99, right? And then I can go comma, comma, and then it still works, right? So the queue actually keeps track of the backspacing as well, so that I can edit the queue in case, because a lot of times I just make typos when I'm typing, right? So if it's a very long shortcut, I don't want to have to be like, oh god, I made a mistake with that one character, and now I have to type over the whole thing. So the queue is actually able to be edited by backspacing and retyping over things. So now I realize that I was going to show you, I got carried away because, you know, the very professional, you know, my very professional Stack Overflow profile picture. Oh yeah, so I am in a situation where I don't think I'm ever going to be able to have another job, like work for somebody else, because I don't know how much I want to say about my life. Medical bills. Medical bills and the drugs I need to take to stay alive are very expensive. Yeah, so, I mean, you can take your guess as to what kind of drugs I probably need. But yeah, they're really expensive, and so if I get a job and then I have to start paying for my health insurance because I can't get Medicare anymore, then I might actually just be making... I might be worse off. Because then I'll have to, like, work on other people's code. Yeah, I'll have to just work on other people's code to, like, stay alive. And, I don't know. Life is short, so I'm like, I don't know. Yeah, I don't know what to... Yeah, I'm hoping I don't, like, my lifespan isn't too shortened, but yeah, I'm not... Yeah, it sucks, but yeah, whatever. But yeah, so you gotta think about, you know, people will tell you to be a responsible adult or whatnot, but, like, in the end, right, we all die, so it's like, you know, maybe focus on something interesting, and, like, my kind of philosophy with life is kind of like, you know, if I'm gonna fail at if I'm going to fail, I want to, like, fail spectacularly, right? Like, I want, you know, I want to put all my effort into actually doing something, right? And I'm either going to be very successful or I'm going to be an utter failure, but I'm not going to hedge my bet, right? So it's either complete success or complete failure, and there's no middle ground here. And you know what? I think I'm okay with that. I also think there's really no sane mode of existence. Because if you think about it, I mean, I'm sure there's more than one way to view the world, but, right, you could either be kind of religious or you could be atheist, right? Those are the two big groups, right? And I think either mode of existence is kind of insane, right? Because if you're atheist and nothing exists after you die, then why are you working towards things? Why are you creating things, right? I'm an atheist, and so it's kind of insane of me to say I'm going to not exist eventually, but yet here I am making things, and no matter what I make... Oh, you're from Europe? Okay. Yeah. But yeah, the U.S. is kind of fucked with healthcare and whatnot. But yeah, I'm making stuff, and eventually the heat death of the universe is going to destroy everything, right? Like, anything anyone has ever worked on, even if somebody creates a legacy, it'll all just eventually go away, right? So, like, nothing is permanent. So that idea that we work towards things, even though nothing is permanent, is kind of, like, weird, right? That, like, where does motivation come from when everything eventually is, right? There's that nihilism, right? Like, so so if you're like a productive person, but at the same time you're able to logically accept nihilism, it's like, that doesn't really make sense to me. Like, I don't think the mode of existence that I have is a sane mode of existence, if that makes sense. Like, I'm not a completely logical person. Not everything adds up, right? Me 3, I believe the same. Very materialistic. Nothing exists after death. Sad, but it's okay. Yeah. But yeah, let's see where we can... I know I was looking for some crazy diagram stuff. Oh yeah, here's some... So here was some, like, crazy kanji kind of stuff, right? Where I said I was doing stuff in kanji. And so I was, like, diagramming how the system was, how all the different parts were kind of linked up. And I was like, oh, well, since I have one little kanji for every single class name, it makes it really easy to make these very terse diagrams, right? Because every single thing in here is a different system. And then, oh, hold on. And then we can see that we have different numbers for the systems, right? So we got a kanji for the system, and then we also have a specific number for it. But it's like, you know what? I don't remember what any of this stuff is anymore. I know that this is get layer, and this is put layer. This is get tile size. This is put tile size. I know that over here is brush. So this is a brush class. Oh, broom. Okay, close enough. Broom, brush. But what else? Like, I can tell there's like a moon in here and something else. I don't know what else is there. This is gold with something else, right? So I can kind of remember parts of these kanjis, but I can't, like, remember all of them. But yeah, so the idea is, like, you know, you come back to this in a few years and you have absolutely no clue what any of it does, and it's, like, completely cryptic. Like, the 21 right here, I believe, is bone. And I believe I used it for a scrolling class, because I called it Bone Scroller, so just a whole bunch of weird stuff. So yeah, we see submitted 3 years ago. But yeah, just a lot of crazy, insane stuff. And what are these diagrams? I just want to see what these diagrams are here for. So this was, like, one of my first attempts when I was kind of learning how to, like, pack stuff into textures, I believe. But yeah, I really like ASCII diagrams. I think they really help kind of figure stuff out. What else do we have in here? This is a good meme. I think that this you just need to you need to have that ready when you're browsing Facebook so you can spam it all of the time. What really made you use those? I assumed you knew Chinese or something. Yeah, so I know, so what I do is, so once upon a time I was a Japanese exchange student, but I never really learned much Japanese. But the thing is that you don't need to know how to pronounce them. You only need to know what they stand for, right? So if we go to gshow.org, right, the important thing to remember is, like, the meaning, right? So, like, if we go for, like, moon, right? So, moon or month, right? So, when I'm trying to remember things, like, I'm not trying to remember how to pronounce it, right? I've long forgotten how to pronounce hiragana, right? So this is hiragana right here, and this is katakana. I just kind of... I remember what they look like, so I remember this is hiragana, this is katakana, right? So hiragana is for the native Japanese words, and then katakana is for foreign words, right? So when you take a foreign word and you I don't know, Japanize it, you could say, like ice creamu, right? Like then you would spell it out with, like, with katakana, right? And so I don't need to remember how this is pronounced. Like, I've never known how this is pronounced, but I know it's moon, right? And then I looks kind of like this, but I is, like, it has a line on the bottom, right? So I will look kind of like moon, right? So here's I, right? And so, like, so there are a lot of kanji that I still remember, but I don't know how to pronounce them, right? I just know what their meaning is, right? Because the important thing for me when I was trying to experiment with this to write code is we're going to, if we want something for modulus, right? So let's say I want a modulus class. Well, modulus is used to sometimes create like wrapping or tiling patterns. So for a modulus class, I use a kanji that means wrap, right? So if I do mod kanji, I might actually be able to get it. Mod kanji? Nope. Let me put that in my shortcuts while I'm here. Too many text editors are open. So it should probably be this. Like if I do wrap, I'll probably find it. So this guy right here. But I don't know if that's the class I use for that. Let's go look for this for a second. That doesn't quite look right. I know there's probably another kanji I use for that. Wrap as in cover. Modulus. Let's look for modulus really quick. We'll probably have better shot if we searched backwards, honestly. So let's backwards direction, modulus. Multiply in modulus. Not what I want. Wrapping modulator. Okay, so this is the thing. So this also means wrap, I believe, and this is what I used for... I'm going to take this. And so I used this class for like a modulus class, right? Because the kanji itself meant wrap, right? So I'm just going to put that right there for a second. And let's take a look at that and see if... look at that in Jisho for a second, right? So air, wrap, or wrap around. Wrap around, right? So a lot of times when you're using modulus, you want to, like, wrap something around. Like, you want, like, when you're playing old school Mario, Super Mario 3 for, like, NES, and you're in the battle mode, and your character can, like, wrap around the screen, right? To kind of do that kind of logic, you might need to use modulus. So I have a friend. She's actually studying, like, Chinese. In Chinese, right? So a lot of Japanese kanji are stolen or borrowed, whatever you want to call it, from Chinese. So she's studying Chinese, and it's interesting because, like, a lot of the kanji that I know, she also knows, or they have, like, a very similar meaning, but not quite the same meaning, or they're drawn... Influenced. There you go. Influenced, yes. There's a lot of kanji that are the same between Japanese and Chinese, or they're the same kanji but they have a slightly different meaning, or maybe there's a slight edit to it. But there's definitely truth to saying that, you know, somebody who's native Chinese or somebody who's native Japanese, a lot of times they can kind of like understand writing, right? Like if they, like a Japanese person could get a rough understanding of what's going on if they read a Chinese newspaper, which I find really interesting because Japanese and Chinese are not pronounced at all like each other. Like Japanese is very simple to pronounce, right? Because it's just consonants and vowels, and the pronunciation is very consistent. It's very regular. Right? You don't have to worry about long and short vowels like you do in other languages. But like Chinese has like very strange intonations. Like intonation matters a lot with Chinese. And like your fluctuation, like if you're going or if you're going ooh, like woo, right? Like if you're, depending on how you're going up or down with your intonation, that can like change the meaning of what you're saying. It's like, if you're not used to like doing that when you talk, right, it just, holy crap, hard to pronounce. But yeah, like when I was a kid, like I broke out like a whole bunch of like those Pimsleur audio books to like learn different languages, and I just tried like a whole bunch at the same time. So I was like, I tried Russian, Arabic, Chinese, and Japanese, like all at the same time. And then it's just like, oh, I randomly know like just a few random phrases in different languages. But anyways, so old game screenshots, so that's cool. What else we got in here? Oh, actually, here, I'm going to show you, so I already showed you the Japanese kind of diagram stuff. Let me show you the old game, because I have some screenshots I can show you. Oh, actually, you know what? I got one better. Right before the new year, I recorded some videos, because I'm like, you know what? I'm gonna, if I don't record something soon, we're not gonna be able to show anything what we're working on. So I recorded something, I think it was video 64. This is a pretty old prototype, but it kind of gets the message across pretty well. So let me show you the old prototype really quick. So let's go over here. All right, we're rolling. So and let's mute ourselves so we don't have like two people talking at the same time. And let me go to a full screen. Where is a full screen? Do we have? That's good enough. That's not serious. Okay, so actually let's try to oh well, we're just gonna get this thing, I guess. So I know absolutely nothing about Chinese, Japanese. I know Portuguese, Spanish. My English is shit, and it's enough. No memory space to learn another natural language. Oh, so my mom speaks fluent Spanish. When I left for college, she went off to Guatemala and started a bakery in Guatemala. And her Spanish, I guess, sounds like I don't know how to describe it. Spain Spanish, like it sounds like she's from Spain, I guess, according to what people tell her. But yeah, I mean, she's spent years and years learning Spanish. I had Mexican roommates as a kid because my mom was so crazy about learning a different language that she decided that she would rent out the spare rooms in the house to people who natively spoke Spanish, right? So that she could learn better, right? But yeah, so this game, right? So you got your two-way bombs, you got vertical bombs, horizontal bombs, and four-way bombs. They're all proximity mines. But sometimes you can instantly detonate the bombs by pressing these little buttons, and the buttons like emit these sparks, and they will cause these little chain reactions, right? And so we did like a lot of different level designs. This is like an older version of the game. So it was fun because the idea was like you could create like all these kind of like chain reactions. What else we got in here? I want to see if I can find actually, I have some GIFs. The GIFs are actually a little bit better. So let's look and see if we can find the GIFs. So I'm going to keep this open because I'm going to do that later. Windows E. I'm going to do AAC Atomic Alice GIFs folder. Let's try Atomic Alice GIFs folder. Not quite right. Okay, I'm going to type this up here and say Atomic Alice GIFs folder. Or AA1 GIFs folder. Okay, use AA1 GIFs. And I don't know if AA1 GIFs folder is a shortcut with the underscores like that. No, it's not. So AA1 GIFs. Okay, so let's open this up and show you those GIFs really quick. Oh, there we go. This is some good stuff. Okay, so let's see if we can... I should actually have a screen where we can do... There we go. GIFs, Windows slideshow. There we go. Okay, cool. So here's the old game GIFs. I had over 800 testers on this game. It was like almost 8 years ago, I think. I got 800 testers. There's that loading screen I was talking about that I showed you earlier. So you've kind of already seen this GIF or a similar one. So here's the first level of the game we released on Newgrounds. So you got these little chain reactions, right? So when this heavy stuff hits a... I really should have done one level per GIF. But right, so as heavy blocks collide with bombs, they make the bombs instantly detonate, right? And then there's a chain reaction. So it's kind of like Bomberman, except if the bombs are connected, they don't all instantly go off at the same time. There's a little bit of a delay, right? So that you can create these nice chain reactions that you can try to escape. Now you'll see that when Alice jumps and when she hits these levers, they cause some explosions. And it's because those pistons up there, they're called flame pistons. And when you press the button on them, they emit a spark. And if a spark contacts a bomb, then the bomb immediately will explode, right? So the idea was that this game uses proximity mines. Let's see if we can find a level that uses proximity mines. So right here, so you see Alice going by here. She touches those bombs, and then there's a delay before they go off, right? They light up, they flash, and then they explode, right? So she touches those bombs, they light up, they flash, they explode, right? So the idea is to create these bombs that they're not an actual impediment, right? You can walk right past them, but once you've walked past them, you've pretty much set off a trap, right? So the idea is to get through the level without getting blown up by a trap. Now, the problem with this level design is that sometimes the levels can be very slow, right? Because there's this delay between when you touch the bomb and when the bomb explodes. So sometimes you want to speed up the pace of a level. And to speed up the pace of a level, we implement pistons that when you touch them, they immediately blow stuff up. So I think right here, so this piston right here, we touch it and it immediately detonates those bombs. And so you can speed up the pace by using these pistons, right? So as a game mechanic to speed up the pace of the game, right? Also, we had these fun level designs. There was basically a push a button and try and see which button doesn't kill you kind of a game. So I made like a set of really stupid levels where it was just 2 buttons in a room, and you had to press one button or the other button, and if you pressed the correct button, it would blast open a path to the exit, and if you pressed the other button, it would just destroy you, right? It would just set off like a Rube Goldberg chain reaction that would just kill you somehow, right? In a very just over-the-top kind of a way. So you see in this level here where I open that box, a character comes after you, and that character tries to push you into the instant kill bombs. So the bombs that are skulls are instant kill, which means that if you touch them, they don't delay, they just immediately ignite if you touch them, right? So most bombs are proximity with the delay, like these circular ones I just touched. But there's other bombs like right here, those are instant kill. So the NPC hits the instant kill and opens up the path to the exit, right? So I had to like sacrifice him to get to the exit. This was just a level where I was testing an NPC, and the NPC causes a chain reaction to like open up the exit. Let's look at this level again. So I was thinking about the design, and I'm like, well, if you're making a game where you can just blow everything to smithereens, how are you going to make it so that you don't soft lock yourself into the level? And so an interesting idea was, if you look right here, sometimes when things blow up, they leave a scaffolding that you can climb. So when these tiles right here where my mouse is, when those tiles blow up, they actually leave behind a ladder type tile or a platform type tile. You see it right there? It got blown up, but that actual residual, the shrapnel that is left behind from the wreckage can actually be climbed. And so we use that mechanic to kind of create levels where you can just climb through the wreckage after something has kind of been blown up to smithereens. What else do we got in here? So we got a lot of interesting like puzzles. Now the problem with this game design, well, first of all, the levels are very visually dense, right? There's a lot going on, right? Your character is like this really tiny thing here, and you got like all this stuff going on one screen, and it's really hard to keep track of everything. So the next engine is going to allow you to kind of like zoom in and out on this kind of stuff, and some levels will be one screen levels like this, but other levels will be more of platform style levels, right? Where the camera kind of follows you and you can't see the big picture, right? So the big picture is necessary when you're making a decision that's going to trigger some type of large chain reaction. But sometimes you want to make a level that's kind of more of a platformer style level, right? So the engine is going to support, you know, a better camera. And the other thing is this was done in pixel art, so you can't really zoom into it, right? Because if you zoom into it, it gets all pixelated and ugly. And that's where the demos come into play, right? So those demos I was showing you again, right? Like, let's go over to the demos again. So let's go... Hold on if we can... so I think my server is just taking a bit to spin up, so it's done on Heroku, so... The server hibernates after a little bit of time. All those stuff seem to have ridiculous potential if polished. Oh, definitely. Absolutely. And I know that I'm going to get there eventually. It's just going to take a very long time. And I'm going to, like, I'm slowly building a team. But right now it's just me and my artist. And then, oh yeah, I do have plans to commercialize it. So I am actually hiding... I won't tell you where. I'm not going to tell you where I'm hiding code. But, I am hiding byte sequences with my copyright information in certain parts of the engine in multiple places. I'm hiding it in a way where you can't use a hex editor to find the information I'm hiding, but I'm hiding my copyright information into the engine source code in multiple places and getting it very highly ingrained in there to make absolutely sure that I can prove someone's using my engine. And I am going to commercialize it. Now, the thing is that I'm going to do something like an Unreal or Unity license where unless you make $100,000, if you make more than $100,000, then you owe something. But if you make less than $100,000, you don't owe anything. And it's not going to be once you hit 100,000 you owe something. It's going to be for every sale after 100,000 you owe something. But it's not exactly. It's not. I did some kind of complicated stuff with the license, but that's the basic idea, right? So the next thing is, well, how do I? Yeah, I hope so too. So the next question is, well, how do you know somebody is using your engine? And the answer is that my engine tech, the way I render things, is so different from the way anyone else is rendering things that the style of the game gives away what engine it is, if that makes sense, right? Because I'm going to do, I'm doing fractal auto tiling, right? And so, well, look at this. So look at this, right? Like, you can tell that if we tried to make a game with this tech, right? And I made an engine revolving around... Oh, hold on, sorry. Let me go over here. So if I made an engine revolving around this tech, right, and then somebody used this engine, it'd be pretty damn obvious that they were using my tech, right? Now, the thing is that somebody else could come across and also, like, clone this tech, right? But I'm going to do something even crazier than this, right? So this obviously has a very obvious style that comes along with it, right? So because So what is that saying in biology? In biology, they have a saying called form fits function. So the functionality of how the engine works and how the engine renders things and how the engine stores data and how you have to procure the data for the engine, all of those things result in a very specific style. And that style is so it stands out so much that I will know if you're using my engine. And you'll be like, well, you can't keep tabs on everybody, right? And it's exactly right. I cannot keep tabs on everyone. So that's why only the people who are making a lot of money would... oh, yeah, those guys, yeah, the... yeah, that is... oh, yeah, no, I... So, So yeah, I actually don't care what you say. Like, I don't know what's the... I think the auto mod thing is just a thing to, like, force some responsibility on me. I think, right? They're like trying to foot the bill. Like I don't care what anyone says. I'm kind of like a... I don't want to get too political, but I'm like, I am one of those crazy free speech people. So I don't care what you say. Now, I will censor my language, but I don't want you to censor your language. You can say whatever you want to say. Like, if I would be swearing a lot more if I wasn't trying to, like, keep this, like, like, I guess to keep my stream from being, what do you call it? To keep my stream, what do they call it? To keep my stream not mature, I guess Twitch says that I can't swear, which I think is completely stupid. Yeah, so... yeah, that's fine. But anyways, yeah, like I said, I'm one of those people who, like, in my household, when I grew up, we were allowed to say anything we wanted. We could use any word we wanted. The only stipulation was that we weren't allowed to direct it towards somebody, right? So F you was not allowed, but F this, totally okay, right? So WTF, unabbreviated, totally allowed, right? We could use any word we wanted. It was more about the intention, right? So, which I think made sense, right? Because I think it's ridiculous that that somehow I could tell somebody to go die in a fire, and that's totally okay. But if I say a swear word, oh my god, that's totally horrible, right? So, you know, I could stub my toe, say the F word, and get in trouble, and then somebody else could go tell someone to go die in a fire, and somehow I'm the worst person. And I actually got suspended in high school once because something like that happened, where somebody was like, people were like throwing stuff at me, and I was getting angry, so I said a swear word, right, and I got suspended for, like, I think I got suspended for a day, and it's like, I was the person, like, having people were, like, throwing stuff at me, and I was getting angry, right? Yeah, right, like, there's that, right, when you make it a big deal, when you make something a big deal, then you give it more power. That's totally a real thing, man. But anyways, I operate under a, no offense given, no offense taken. That's how I operate. And yeah, but anyways, so you can see there's an obvious style here, right? And so when you're trying to, I'll address the Chinese clone companies in a second. So yeah, there's an obvious style, but yeah, I can't keep tabs on everybody. So you just keep tabs on the people who are making thousands and thousands of dollars, right? Because if they're making thousands of dollars, then you're going to know about their game, right? Because it's going to be a popular game that everyone's playing, so you're going to eventually see it, right? It's going to pass by your radar, because once somebody gets big enough, you're going to notice them. And so since you're only going to notice the people who get really big, just make the people who get really big, make them the ones that need to pay, let everybody else do it for free. And so, and because the style is so obvious, right, I'll just know that they're using it, right? I'll see the style of their game, I'll absolutely know they're using it, right? Then I'll download their game, right? Like, I'll pay for their game, and then I'll look at the source code, right? Like, I'll look at their code in a hex editor, and I'll be able to find the signatures of my engine in their code, right? And then I'll be able to know that they're using it, right? And like right now, I don't really have a policy of how people are to pay me in my license. I think I'm actually just going to make my license a I'll find you kind of a thing. You know, don't try to pay me. Like, I'll find you. If you make it big, I'll find you, right? Like, I don't know if that's a good way to do it, but I'll think about that as things kind of go further. But yeah, like Chinese companies, so like yeah, that kind of gets a little bit political, but you do have to worry about copyright law when it comes to the Chinese definitely have a bad reputation of not respecting copyright law. And in fact, sometimes people will do things like they'll outsource their factory to China, right? Because, you know, they'll outsource their factory to China, right? And then people lose jobs in their home country, right? Because it gets outsourced to China. And then, eventually, after the company has outsourced all their productive capacity to these Chinese factories, China will say, hey, guess what? These are our factories, screw you. And then the entire business goes under because if you outsource all of your production capacity to somebody else, then then you're not really necessary anymore, right? And but I mean, I don't know, and that's kind of, I don't know if I really feel bad for people who are like outsourcing all of their work to other countries, and then right, like the income inequality between an average worker and a CEO is getting like wider and wider and wider, and it's kind of like spiraling out of control. So personally, I think that yeah. But yeah, so I think yeah, I'm gonna say one last thing, and then I'm gonna avoid getting too political. But I definitely think that like a worker-owned co-op could be a good compromise between, right? You got your like capitalists, and then you got your communists, and they're kind of like at each other, right? Like, right, like. But I think there is actually a middle ground, and I think it is a worker-owned co-op where you can have a worker-owned co-op can function within a capitalist system, but you can get kind of like that social safety net of everyone has an equal stake in the company, and when somebody is no longer useful because their position is no longer needed, you find something else that they can do rather than fire them. I'm one of those weird people who I like Richard Wolff and Milton Friedman at the same time, and those are like two like diametrically opposed people in terms of economics. But yeah, I don't know. I think that if there is such a thing as absolute truth, there is no way in hell that absolute truth is perfectly aligned with any political ideology, right? So if there is an absolute truth, like, there's no way that coincidentally absolute truth is aligned directly with one political ideology or another. That seems astronomically impossible to me. But the thing is that if that's what you believe, then you gotta be careful discussing politics, right? Because if you're really good, if you're going to be as logical as possible, that probably means that you do not fit neatly within any political ideology, and that means you're going to take shit from both sides. And usually, if you fraternize with both sides, then both sides don't like you, because they usually like, right? I don't know what it is with human psychology, but that seems to be how it works. So I try not to commit social suicide, but you know, I'm too honest, I guess, or I just have trouble keeping my mouth shut sometimes. Anyways, so anyways, we got all these technical demos, kind of showed you that. So what I'm up to, nothing in this world was meant to make sense. We just need to come to something less shitty that includes most people. Yeah. So what I was doing really early is I was writing some tests, and the tests are kind of failing. And I can actually show you what the tests look like and try to explain what's going on. So too many editors. Let's keep this open for now. So in here, well, let's look at this unit test data. So look, we got all these hex codes here. I'm going to find where these hex codes are in this file here. Okay, so don't worry about understanding all of this, because obviously there's a lot of stuff here. And, like, I've already lost my spot. Oh, wait, no, I haven't lost my spot. Okay, so here's a test function. And it is testing a conversion from, this is called canvas user view pixels. And this is canvas user view bits. And so what do I mean by canvas user view? I mean, here's the data view, right? Here's the data view of how all of the data is packed on the GPU. And then this diagram is what is actually being rendered to the screen. But it's not exactly what's being rendered to the screen, because this canvas here is always a 256 by 256 pixel canvas. So it's not quite the client area. So these pixels in here aren't at exactly the client area, but they are view coordinates. They are like, these are coordinates that map to kind of like what the user actually sees on the screen, whereas these are coordinates based on how we're segmenting the data. So if we look at all the coordinates in this sector here, all the coordinates in this sector here are represented by this data here, right? And if we're on a certain layer, let's say we're drawing on layer 1 of this sector here. So the artist is in the editor, and they're setting down pixels and things on layer number 1. Well, what does that mean in terms of the data view? It means that they are looking at layer 1 here, layer 1 here, layer 1 here, and layer 1 here. If they switch to the next layer, the second layer, or layer indexed 1, then that means they're using this data, they're using this data, and they're using this data, right? So if they're setting the smallest tile size on layer 1, they're setting this data. If they're setting the second largest, if they're setting a tile size 1 larger than this, 1 factor larger, then they're setting this data. If they're setting another tile size that is double the size of these tiles, then they're setting these tiles, etc., etc. So the coordinates in here are data coordinates for where the data is actually packed, whereas the coordinates here have to do with what's actually on the screen. But like I said, it's not exactly what's on screen, because this canvas is always exactly 256 by 256 pixels. Now, depending on if you are zoomed in or zoomed out, you might have a different subsection of this. So let's say we zoom in on the center of the canvas like this, right? So basically we want to, if the viewport is zoomed in on this, then we want to render this section. So we want to map the user view coordinates to the data view coordinates, right? To the underlying data, right? So we want to know what tile values are underneath the pixels here that are mapped onto here. Screen pixels or game pixels. So these would be screen pixels. Well, I don't know if we really have a game pixels yet. Right now we're working on the rendering engine. Well, actually, let's say these are game pixels. I guess if I was to say screen pixels or game pixels, these are game pixels, because we're going to have to abstract this one level further into the client area, like the viewport. So the viewport is going to map onto somewhere onto here. That could get very small in high-res screens. No, yes, so exactly. That's why I say that. That's why I say this is not quite the screen viewport. This is not quite the what's going to be on the screen, right? Because how I said this is always 256 by 256 pixels. But it's not what's going to end up on the screen, right? So if I'm rendering this entire region to a screen that is 1000 by 1000 pixels, then I render everything 1000 by 1000 pixels. But I have to take a viewport that's 1000 by 1000, and then I have to map it onto this, which is 256 by 256. But this is the visual layout of where I guess these are the game pixels from what you're saying, right? This is the game pixels, right? 256 by 256. And this is the topology of what the artist sees when they are designing the tile sets, and this topology needs to map to the actual underlying data, right? So we have to map from the screen coordinates to this topology here, and then we have to map this topology to the underlying data. Which gets it gets confusing. It is confusing. So just figuring out the names for these things, I have to like come up with conceptual names for these diagrams to figure out what the hell I'm talking about, right? Because I can easily lose track of what I'm talking about. So I just decided to to use the acronym CUV for Canvas User View, or CUVI, depending on right, all my variables are either 3 or 7 letters long. So sometimes there'll be some weirdness with my variable names, because I do weird things to guarantee that they're always 3 or 7 letters long. But yeah, so this is the data view pixels. This is the canvas user view pixels, which is not quite the screen viewport pixels. I guess from what you're saying, these would be the game pixels. And then the screen pixels has to map somewhere onto here. And then from here, we have to map this to the actual underlying data, right? Because if we're going to render this subtile of the auto tile set, we have to figure out, well, what's the actual data that Josh has drawn into here, right? And the actual data that Josh has drawn into there is all stored in here. Now, if Josh is editing the lower right tile, then this is the data, and the actual canvas user view for that is right here. So there's like a lot of transformations of the data, and it gets really confusing. Like even with drawing all of these diagrams and having like very stringent variable names with very specific definitions, it still gets like a lot to handle and very confusing. So let's forget about what all this means for a second, because it's not too important to what I'm about to explain. So we have a test table, right? So this is the first set of test inputs. This is the second set of test inputs. The third test, the fourth test, the fifth test, the sixth, all the way up to 8 tests. And for each one of these tests, these test blocks, we have like 3 answer keys for each test. So this is the first test block, and then this is the first set of answers. And these answers are binary strings, but C does not have a binary literal type. So I made defines for the binary, right? So this is just 16-bit binary of all zeros, right? And where are we getting these 16... Where are we getting all of this binary from? Well, if we go up to the first test, we're taking all of these bits right here and smashing them together, and that gets that first binary string. Then we take all these bits and we smash them together. We get the second binary string, and we take all these bits and we smash them together, and we get the last binary string. So the first, second, and third binary string. Now the problem is that this is a pretty big block of data to define. And then after we define this gigantic block of data, we have to meticulously define these binary constants. So if we go up to the top, right, we see that I had to go into a calculator, right? So I had to manually make these defines. And then after I manually made these defines for these different binary strings, I had to go into a calculator, and I had to figure out the exact hex codes for these binary strings. So you can see how error-prone this might be, and also how completely tedious it is, right? So, because these binary strings were highly irregular, right? So you see these hex codes aren't as regular as these hex codes up here. So since these binary strings here are very irregular, I also have some checks to make sure that those binary strings are correct. So right here is where I'm checking these binary strings. So I'm going to take this first binary string, and I'm going to take all the binary components of them, and I'm going to shift them into place, right? So I'm shifting them into place, and each binary substring is 2 bits, right? So I'm just smashing together a binary string to absolutely check that this binary string has been hard-coded correctly. But this is a hell of a lot of work. And then after we do all that stuff, we have all the test runner code as well. So I thought an interesting way to do this, to write some more tests, is to write the tests backwards. So what if we started with these binary strings here, and then we worked backwards to create the input data, and then we ran our tests. So this is the input data, this is the inputs, and this is the expected outputs. But we could do it backwards. We could start with the expected outputs and use this to derive the inputs, and then we could run the tests. So, scrolling up, that's exactly what we're doing. Actually, so let me, so let's go over here. So you see this big table? These 3 hex codes right here that I've highlighted correspond to like 3 hex codes right here, right? Because this is a 16-bit binary string right here. This right here is also a 16-bit binary string. So here we have 3 16-bit binary strings, and here we have 3 16-bit binary strings. But you see, this is table UTC out. So this is the expected outputs. So I thought, well, it's a real pain to create these binary strings. So how about we create a big list of binary strings, and then we derive the big chunks, right? So we're gonna take these 3 binary strings, and from this binary string, I'm going to derive this column. From this binary string in the middle, I'm going to derive this column of binary values. And from this binary string, I'm going to derive this column of binary values. And so you can make a util program to generate the literals. Yeah, like I could, yeah, I could. I actually do have some utilities to generate some things for me. So I have written some utilities. And actually, I'm going to write a utility now to help check some things. So you can imagine that that all of this transformation is pretty complicated, right? Where I'm doing all this weird work to create the input table, right? So this is a hard-coded table of inputs, right? But I'm gonna work backwards, right? So these are the expected outputs, and I'm gonna use the expected outputs to generate a table of inputs, and then I'm gonna run the tests. So I took so up here is the next test, and you'll see it says right here, it says above, cut and pasted from here, right? So this is what I cut and pasted from. So I took all the test runner code from the previous test I wrote, and I pasted it all into here. So this is all a big cut and paste job, right? So all of this, a big cut and paste job. It's all the test runner code, which is very redundant and it's hackish. It's redundant, it's hackish, it's wasteful, it's ugly. But the thing is this is test code, and I allow test code to get a little bit ugly because it's test code. And I'm not really worried about efficiency. I'm just worried about, like, massively, what do you call it? Overwhelming force, right? Just write a whole bunch of test code, do everything in your power to guarantee that your main code is functioning correctly, right? So over here, all of this code is trying to correctness. Yes, correctness. Yes. The code at the beginning of this function is going to use some of the same macro names as the previous test code, just to keep everything kind of so I can see the analogies between the old. So by auto-generating the test data, or working backwards from the expected outputs to the inputs in this function, I'm adding on another layer of abstraction, right? I'm making this even more complicated. I'm making this even more confusing. And so to help mitigate the damage I'm doing from that, I'm using these names here are the exact same macro names as the macro names in the previous function. So that way when I'm looking at this function that's added on one more layer of abstraction, I can hopefully kind of see how this code evolved from the previous code. Okay, so for example, this thing that says table UTC input and table UTC output, that's the exact same names as the previous test. However, unlike the previous test, you'll see that these tables are empty. This table is empty, and this table is empty, because we're going to have to populate these. So the output table is going to be fed this data set or this data set, and both of these data sets are actually, one is little endian and one is big endian. So all of these byte sequences from here and here, they're actually just big endian and little endian versions of each other, so that I can detect any problems that might come from the endianness when doing logic with bit packing. Okay, so the first thing we want to do is if we look for UTC out, we see that we're doing a big loop over big or lit. So big lit can be 1 or 2, and if it's 1, then we're going to use the big endian data set, and if it's 2, then we're going to use the little endian set. So you see it has this table UTC out, so it's table unit test code outputs, and we have the big endian and little endian versions. These are macros for these data sets here and here, right? So here's the big endian, here's the little endian data set. And then in this loop here, in this, all this looping stuff here, it says populate test data table. So we're going to go through the output table, and we're going to generate the input table, right? So we have to work backwards to do all of that. And this is just ridiculous. It's ridiculous, it's very error-prone, and I have definitely, absolutely made a mistake somewhere in here. So so now we have, so there's that question of, like, who watches the watchers, right? Like with the movie Watchmen, right? Who watches the watchers? Or the halting problem, right? The halting problem says, you know, you can never write a program to, like, guarantee its correctness, right? So when you write test code, what you're really doing is you are just shifting the errors, really, is what you're doing, right? You're going to lower the probability of problems in your main code by writing test code, but now you have test code that might have problems, and now you got to error check the test code. But whatever code is terminal in that link of this code checks that code, checks that code, checks that code, whatever test code, whatever code is terminal probably has the same probability of errors as code that never had any tests in it at all, right? But we mostly care about the correctness of our main code, right? But anyways, but we also want this code to pass, right? So we do need to do a little bit of checking to make sure that the test code is correct. So in order to make sure the test code is correct, after we generate those test tables, I'm going to check the first generated values. So you see these blocks here? This is, okay. You can get it. Okay, so this block right here, so you see this block right here? That is these three values, right? So we've unpacked the 2-bit binary values from here, and we've generated this. So I hand hard-coded the first values to make sure that I was doing the logic correctly. And it turns out that I'm making a mistake somewhere. But if we can get the checks against this to pass, I'll be fairly confident that the process I'm using is working correctly. But until then, I'm not confident that the process I'm using to unpack these is correct. So if you look at this binary value right here on my left monitor, that corresponds to unpacking all of these binary values. And this binary value here, right in the middle, that is unpacking the 2-bit binary values here. And then this right here is unpacking these values here. And it's the same thing with this. This is the little endian block to help check my my extraction of the test data. It's easier to write the hex. It's easier to write this because I'm just trying to test with some arbitrary data. So it's easier to write this, right? Because I can just make this up. But in order to make the binary literals, so let's look at those binary literals again, right? So when I'm making the binary literals, right, for every single binary literal, this is actually quite a lot of work for me because I have to, first I have to go, so let's go over the process. I can show you the process for this, right? So for making these, I'm going to have to go into the calculator, and I'm going to have to, for every one of these entries, I have to go into here, and I have to look at this, and I have to say, okay, 0, 0, 0, 1, 1, 0, 1, 1, right? So I have to go 0, 0, okay, 0, 1, okay, then I got to go over here, and I got to go 1, 0, then I got a 1, 1, and then over here, I'm going to look at this next section, I'm going to go, all right, that's a 1, oh, wait, that's wrong. I did something wrong here. So I've already screwed it up. This is 0, 0. This is a 1, 1. This is a 0, 0. And that's a 1, 0. Okay. So there. So when I'm transcribing this, right, this is very error prone right here. This is very error prone. And then once I've done this, right, I get the hex code, right? And that doesn't look right. I got, oh no, that's right, 1B8C. And you can see that I've encoded 18BC. So it's easy to get something like this, but it's hard to get something like this, right? So it would be easier if all of these binary values were just encoded like this, and then we worked backwards to get these clusters here, right? So what I'm trying to do is just automate the process to make it a little less tedious and to get like a big chunk of tests that I can make, right? And I'm actually sick of this by now. I wish it was just over by now. What do those values represent? Okay, yeah. So let's talk about that. So let's look at so this is our input table, right? So this is layer 1. This is layer. So let's go to my diagram here. Okay, so let's look at this. This is layer 1. So what does this represent right here? This right here represents layer 1 or layer 0. So it represents any data in this block. It represents any data in this block, and it represents any data in this block. Now, this column right here is layer 1, or the second layer. It represents any data here, or here, or here. And this is the third layer. So it represents data here, it represents data here, and it represents data here, down here. Now, but you'll notice that, so you see these things that say tile exponent? so tile exponent is talking about the size of the yeah, yeah. This is batshit crazy, right? So this is why I'm saying that my rendering engine is going to have a very unique style that no other engine has, because of the way that I'm just thinking about the data and how the engine is going to work. So you see how these say tile exponent? The tile exponent is the tile size. So this is tile exponent 0, this is tile exponent 0, layer 0, this is tile exponent 0, layer 1, this is tile exponent 0, layer 2. So if you want to know where those are in that order, tile exponent 0 on layer 0 is here. Tile exponent 0 on layer 1, that's these here. Tile exponent 2, tile exponent 0 on layer 2 is here, right? So all of these blocks here, and here, these are all the same tile exponent, but they're different layers, right? This is layer 0, this is layer 1, and this is layer 2. And I'm going to show you one other tech demo that I haven't shown anyone in quite a few months. So, but you asked what that data meant, so I feel like I really need to show you this demo now, because I think it's going to help you understand what's going on. So, for Andrew, I think I called it for Andrew 01. Yeah, so I have a for Andrew 01 and a for Andrew 02. So this is going to take a while to boot up. I should probably put this in my main tech demos as well. But when I said that my demos page had like all the proof of concepts, I actually lied. There's more proof of concepts. So let's see if we can, let's see, show same tile sizes, isolate active tiles. This might take me a while. Okay, cool. So, on layer 0, so right now we're on layer 0, tile size 0, right? So tile size 0 is the smallest tile size. If we move up one tile size, we get tile sizes that are twice that size, right? If we move up another tile size, we get tile sizes that are twice that size, right? If we move up another tile size, we get tile sizes that are twice that. If we move up another tile size, we get tile sizes that are so big, right? We move up another tile size, we get even bigger tile size. We move up another tile size, even bigger tiles. We move up another tile size, even bigger tiles. It's just it looks like a big screen of color, right? And so eventually, when you get to tile size 8, this tile size is so big, it fills the entire level, right? So let's talk about that one tile size that fills the entire level. Well, the one tile size that fills the entire level, it's way down here, because you only need 1 pixel to encode that one tile size, right? Because it's so big, it fills the entire tile map, right? So the smaller your tiles are, the more of them you need. That's why when we're partitioning the data, the smaller tiles get a bigger data segment because you need more of them. Okay, so let's go back down to the smallest tile size right now, right? And let's try to show all, right? When we show all, look how ridiculous this looks, right? We can't even see anything because it's so like there's so much stuff there. So if we could try to like run the eraser, maybe we could erase some stuff. I thought 0 erased stuff. Oh god. So I really wish I made like a clear screen thing because I mean this is a good oh wait, orthographic. If I turn orthographic, no. Let's so there's different layers as well. But yeah, you see how dense this is? Like, so at first I thought, I have absolutely no experience with game devs, so at first I thought it was something close to normal. Yeah, yeah, I don't know. I don't think I'm anything close to normal. But yeah, so this map, unfortunately, I really need to really make a good example of what's going on here. I really should make a, I really should have had an example in this demo where I was able to, like, clear everything, because right now there's so much density in here that you can't even see all the different tile sizes, right? Because these little tiles cover up the bigger tiles, right? So you can kind of tell that there's a gigantic tile right here, but it's hidden under, right here is a big gigantic tile right here, but it's hidden underneath all these other smaller tiles, right? So there is different tile sizes, and there's also different layering, right? And so it all just makes everything very dense. But we should have a for Andrew number 2, for Andrew 02, and this is going to be kind of the same thing, but it's going to have parallax in it, which can kind of, oh, that's not the thing, never mind. I swear I have some type of parallax trigger on here. Let's see if we can do ortho toggle. No. Huh. You know, I'm sure I have something somewhere, but it's just been so long that that I don't know where to find it, right? I'm going to read that in a second. Isolate active tiles. Yeah, so I guess the best thing I can do is I can just isolate the tiles of this size, so that way you can kind of see, so that you can see that we have this size tile, we have this next size tile up, right, and then gigantic tiles, right? Okay, so at a single time, you are only rendering one of those turtle tiles. Oh yeah, so not quite. So let's get into that for a second. So, because you're asking, like, what this represents, right? So I'm working on the rendering engine for this right now. And the way the rendering engine is going to work is, let's say the rendering engine is looking at a single pixel, right? It's looking at a single pixel, and the rendering engine wants to know what tiles are underneath this pixel, right? And so there are 8 different tiles underneath a single pixel, right? And there are different tiles of different sizes, right? Actually, there's not just 8, there's 24, right? That's why we have 3 times 8 right here, right? There. Oh, hey, how's it going? Sorry, I'm still explaining some stuff. Yeah, that's my girlfriend. They want some attention, or maybe they just want to feed me. I don't know. Let's see. That garlic jerky is mine. I will not share. Good night. Okay. Understood. We bought a whole bunch of beef, and we cut it up into slices, and we put it in the oven and convect at low temp at 175 for 4 hours. And we made some pretty good jerky. And then we also made jerky without any seasoning, right? We just took the meat and we put it in the oven. You know, because you want a control variable, right? So we put some unseasoned meat into the oven and gave that a shot. And we had some, and the unseasoned meat without any salt, any spices actually tastes pretty good. But okay, so anyways, so you have a certain pixel you want to render. You need to know what tile is underneath it. And there's going to be 3 layers underneath this pixel, and there's going to be, for each layer, there are 8 different tile sizes. So we need a way to query one of these pixels, one of these fragment coordinates, and figure out all the data that's underneath here. And so for a single pixel, you're going to have all of this data here, because all of the tile values are actually 2-bit values. So you could say that I'm using 2-bit color, right? So you can either have the value 0, 1, 2, or 3, right? So in binary, that's going to be a 2-bit binary value. So that's why you see the 0, 0 here, right? So if we want to figure out, so we have a command that we're running that's going to give us an array. Or it's actually not going to give us an array. It's actually going to give us a bit-packed value that has 8 2-bit values for all of the different tiles that are underneath a pixel for a given layer. So we have to query, so for every pixel, we have to query that pixel 3 times. We have to say, hey pixel, for layer number 0, what tiles are underneath you? And then it'll give us back a bit packed value that has all of these values in it, right? So the bit packed value of this is one of these things here, right? One of these 16-bit integers, okay? And then we're going to say, hey, that's great. Now, for this pixel, for the second layer, what tiles are underneath my pixel? And it's going to give back a 16-bit integer with all of these values packed into it, right? So you see tile exponent says what tile size, right? So there are 8 tiles underneath the pixel for any given layer, right? And then once again, for the final layer, for the third layer, I'm going to say, hey, for this pixel, for the third layer, what are the tiles that are underneath that pixel? And it'll give that back, right? So that's some pretty ridiculous stuff, right? And it's a lot of data, right? This is 20, we have 24 different tiles that we need to sample from to render a single pixel. So you asked, so at a single time, you are only rendering one of those turtle tiles. Actually not, right? Because a renderer works pixel by pixel. So when we're trying to sample one of these points, we're actually rendering it all at once. So let's go show all. So we're actually rendering for any single pixel, we actually have to know every single tile that is at that location. Now, if I was using something like OpenCL, I could write probably a more optimized algorithm that is more friendly to the way I'm subdividing space. But because I'm kind of bound to OpenGL, I have to write a fragment shader. And a fragment shader is massively parallel, right? It executes code for every single pixel all at once on the GPU. And all 3 layers are rendered mixed in the same pixel. Yes, correct. So, so the code, this code right here, isn't going to tell me all of the rendering details, right? It's just going to tell us me the tile values. So the next part is I'm going to use palletized color, right? So I'm going to use a lookup table, and I'm going to use a color palette, right? So I'm going to have colors. 0 will probably be transparent, right? Like a no tile value, right? And then I'll have colors 1, 2, and 3. And then different layers could have different palettes, right? So what I'm going to do is I'm thinking that I'm going to alpha blend all of the tiles that are on the same layer. I'm going to alpha blend together. So I'm going to alpha blend these tiles together. I'm going to alpha blend these tiles together. Then I'm going to alpha blend these tiles together. And then when I composite the layers together, I'm going to probably keep them opaque. Maybe. I'm not sure of the exact implementation, but I definitely think I want to alpha blend these tiles together, alpha blend these tiles together, alpha blend these tiles together, and then I want to probably do more of an opaque layering of this composite, and this composite, and then I'll get the final pixel value. So it is ridiculous. It's completely ridiculous. It's completely insane. And so, the current problem I'm having, right, is so I'm trying to generate these values, and something's going wrong, right? And I don't know what's going wrong, so I'm going to start to make some utilities to help check that, right? So we're actually, when you kind of stumbled into my stream, I was in the middle of writing a utility to help me analyze pixel values, or analyze 16-bit integers. And what I want to do with my 16-bit integers is I want a unsigned 16-bit integer, and BPA U16 is my namespace here. And I want a I want to let's say compare, right? So let's think about like yeah, I mean, so the thing is that so here's what I'm going to do with the entire picture. So I know that a lot of the code I'm doing is going to be like ridiculously crazy, and a lot of times it's going to be really boring. So what I'm going to do with anyone who's following me is yeah, so well, I don't know. I mean, I think I'm not okay, well, I'm not a complete noob, but I wouldn't consider myself an expert at C. Like, there's always things I could learn. I mean, I have a pretty good grasp of my pointers, right? I mean, I guess after you know your pointers and you know how to make a function pointer type def, I mean, then you're probably set, right? But yeah, so what I'm going to do with my stream is anyone who is following me, I'm going to personally message every single one of my followers when I have a new tech demo, right? Because I know that most of this stuff is going to be boring, and it's really hard to see the big picture because a lot of the picture is right now, it's only in my head, right? Like, until I get some more rendering tech out there that you can actually see, a lot of the mental models are in my head only. And so it's very hard to like get that out to other people. But this is actually going to be pretty easy to explain, this code here, because this is just going to be a little utility to help me check for some problems. So we're going to make a little utility that's going to compare two 16-bit integers, and it's going to be like str compare, like the C function called strcmp, right? Where strcmp returns 0 when they're the same, right? Because the delta between the two ASCII strings is 0, right? So therefore there's no difference, there's no delta. So what we're going to do is we're going to do like a U16, and we're just going to say, we could call it U16 number 1 and U16 number 2, right? Very, very, I know a lot of people will say that you shouldn't number variables, like, oh my god, if you put a number on a variable name, you're doing something wrong, and I say to that, I disagree. Just because I like numbers better than I like letters, because, like, alphabetical order is always hard for me, so, like, naming something like U16 A and, like, U16 B, I find it harder for me to mentally comprehend. Like, for some reason, I comprehend numbers faster than I comprehend letters. So rather than call it U16A and U16B, I'm just going to call it U16-1. So first number, first bit field, uint 16 to compare. And then over here, we're going to call this the second bit field to compare, right? And all we're going to do is, we're not just going to, you know, say, oh, if they're different, you know, return a number, right? That wouldn't be very useful. We're going to use this as the diagnostic tool. So when the numbers are different, we want to print off some type of information about what's different about them, right? Like, maybe the numbers are almost the same, except the endianness has been swapped, or maybe the numbers for some reason are like inverted, right? Maybe we wrote the bits in the exact wrong order, right? So I think that there's the potential when I'm bit shifting logic that I could bit shift things in the wrong order, right? So maybe these two binary strings are just mirror images of each other, which would be indicative, that would be a sign that when I was doing my bit shifting logic, I was shifting everything the wrong way, right? So everything that is in the most significant bit position actually needs to be in the least significant bit position. And if I can make a little utility that tells me kind of the patterns that are detected between this value and this value, then I can help diagnose what the heck I'm doing wrong. And so we want to make a little utility for that. So the first things first is let's just say, let's not worry too much about, U16, let's say, do we just want to say delta? Let's say U16 delta, and let's say U16, U16, min. Let's make another U16, we'll call it U16 max. And, I'm actually going to say that this one is going to be U16 delta, right? So this is the delta. And for this, I don't really have... yeah, yeah. So I've done all that insane stuff, and now I'm just kind of like... oh, yeah, so here's what I do. So I haven't actually... so sometimes there's a whole bunch of loose ends. So let's start... I'm going to explain that right now, because I actually haven't done it yet. So, comparison function. So I'm going to make a little section for the comparison function. And I'm going to just be like, whoop. And I actually, I used to use type defs a lot, but I actually don't use type defs anymore. Well, I use type defs, but you'll see. So I actually like defines instead of type defs. So what I like to do is I like to define U16, and then I like to undef it. So I like to keep all of my... I mean, functionally, this is a type def, right? Functionally, I am using it as a type def, but I prefer defines rather than type defs. And one of the reasons is because I can get rid of this after I'm done with it, right? So after I am done with this, I'm going to undef it, right? I'm going to keep all of my defines local to a section. And the reason I'm going to keep my defines local to a section is because shit gets out of hand really easily if I... let me just show you this. So, macros out of hand. Let's try out of hand. Macros out of hand. So there, look. See that? See that? It's already a thing. I'm going to make more synonyms anyways. Macros are out of control. Let's say, how about macro proliferation? I don't know if that's how I spell proliferation, but anyways, macros out of hand. Okay, so I'm going to make a new date stamp here. I'm going to say it is 20/21/01/22. So I'm going to show you some examples of macros getting out of hand to explain, like, why the heck do I make a section divider? And then why the heck do I put all of my macros at the top and the bottom of the section divider, right? Because that's probably pretty weird. And there is a reason for why I do that, right? So my style has been kind of evolving. And let's go find my shortcut script. Oh god, too many text editors. Oh, it's over here. I'm going to paste that in my shortcuts really quick so it's there. And then I'm going to show you what's up with that. So let's do mac non 01. So I believe 01 should be my best example of macros that are out of hand. So, okay, yeah, so this is pretty out of hand stuff. So, I got really out of hand with a whole bunch of macros. And so I made an include file where I would have an include file that I would include this file before a source file. So I would include this file at the top of a source file, and then I have a complementary file that is just a whole bunch of undefs, right? So these are all the defines, and then I would have another file that would undefine all of this, right? And my macros got way out of hand. So I find that if I try to make a master list of macros that I just include, it just has the propensity to grow and grow and grow over time, and then it gets into one of these ridiculously long lists, and then it just it proliferates out of control. So to mitigate the proliferation of macros, I always have a custom list of macros, local macros, for any single section in my code. Now, if I have a macro that needs to be defined in one file and used in another file, then that macro probably will be something like AAC 2020 macro blah blah blah, right? So I'll keep the name. If the macro is not local, then it needs to have the name macro in it, or at the very least it needs to say, you know, mac, right? At the very least. So one of the worst things about macros, in my opinion, is not knowing their macros. Like when you're doing Win32 code and you're all like, load library, right? Load. Oh god, I will develop PTOs. Yeah, so when you're using load library in Win32, it's not actually load library, it's a macro. And if Unicode is defined, it's going to be load library W for wide. And if Unicode is not defined, it's going to be load library A for ASCII. Oh, is it a lowercase w? Like load library W? Hold on. Yeah, I don't quite remember. But yeah, you get the idea. Right? And that kind of stuff. Oh, okay, I'm correct. Okay, cool. Yeah, so that stuff annoys the hell out of me. And if you want to see some other crazy stuff, what if I told you that I use load library and I use get proc address, but I don't include windows.h. I just have a piece of assembly code, and I use that assembly code to walk the peb file, and I walk the peb file and I find the base address of kernel 32, and from there I find the function pointer for load library and get proc address. So, you know, to figure that out, I found, you know, I wasn't expecting to find myself on virus writing forums, but it turns out that when you try to start doing stuff like that, I guess the people who usually do that write viruses. That's not me, but I wanted, you know how there's the header for lean and mean? Like Windows has a, for the windows.h, you can specify lean and mean, and it like doesn't bring in as much cruft. Well, I'm like, oh, you know what the leanest and meanest version of Windows.h is? The leanest and meanest version of Windows.h is not including Windows.h. Yeah, define to cut the junk, yeah. So now the only problem with that is that right now this code base, guess what? When you do custom assembly code, that means that it only runs on 64-bit Windows 10, right? Because all of that code for load library and get proc address is specific to the operating system, right? Now, I didn't just do all assembly code, though. I actually only have one line of assembly, right? I just need to get the base address. Once I get the base address of the peb file, I actually wrote some helper functions to make the walking through the data structure a little bit more pleasant. But I walk through the data structures without including any struct prototypes. Or maybe structs? No, I don't include any structs, right? I'm not even using any Windows structs, right? So I just know that, okay, from this struct, we need this relative offset, right? And then we get to this piece of data. And, oh boy, I will tell you that when you try to walk through structs by just using the memory addresses and the offsets, you start to learn that, you don't quite understand dereferencing like you thought you did. Like, you think you're a badass with pointers, and you think you really know pointers, and oh, look, I take the memory address of things, and oh, look, here's me dereferencing things, and ooh, I know that a pointer to an integer is just an array, and look how fancy I am, and oh, a double pointer, look, now I can pass things by reference like it's C++, and you think you know what you're doing, but then when you try to start walking data structures, you realize, oh crap, I don't actually know what dereferencing is. It's like, oh crap, what the heck is a value? What the heck is the difference between a pointer and a value? Because then, once you start walking data structures like that, the line between memory address and value gets pretty blurry, right? Everything gets blurry, man. So it's like, all right, I'm gonna dereference this struct. Wait, hold on. If I'm gonna dereference a struct, but hold on, this struct is like a 128-bit struct. We can't dereference that. How can you dereference that? There's no there. You only have 64-bit width variables. How can you dereference something that's 128 bits? And so like, oh wait, we dereference it, but that doesn't really dereference in the way it's still confusing to me. Like, I've done it and I'm still confused. Like, I understand that, yes, when you dereference something, you look up the memory address and you interpret the bytes at that memory address to be a specific type. Yes, that makes sense. At a high level, that makes sense, but when you start to walk data structures and you're just jumping from memory address to memory address, all of a sudden, that abstraction, the way you've been told dereferencing works, all of a sudden it just doesn't make sense anymore. But yeah, holy crap, that stuff can get complicated. But anyways, if you're ever interested about that, there on Wikipedia actually has the answer to that. Let's see, file segment. I think file segment. Let's do file segment. Nope. Let's make some more shortcuts really quick because I know where it is. It's like file segment, peb file address. Peb address. How about peb address? I know it's somewhere here. Peb address WinDebug. Well, I mean, that's a good one. So like, I used a little bit of WinDebug to do this. All right, so I didn't have to look up documentation. Right, WinDebug has a command where you can do where you can get the base address of peb. I'm not super familiar with WinDebug, but I had to use it a little bit to write that assembly code. But holy crap, just it gets out of hand. So peb file address, peb file base address. Peb file address Wikipedia. How about PebWiki? There we go. There we go. So this guy right here. Yeah. So we look that up really quick. Yeah, so there's the tab, and then the peb, right? Thread information block, and then there's the peb, right? And so, I think it should be like 0x30, I think. Yeah, right here. So 0x30. But what bit is this? So 32-bit. Okay, yeah. So for 32-bit, we want FS30. And then for a 64-bit operating system, we want GS60. So, I always wondered, like, okay, well, how does get proc address and load library work under the hood? And you want to ask a question like that, and the answer is like, to really understand that, it ends up like taking up like a month of your time, because right, like, yeah, right, because you have to look at some undocumented Windows internals, right, because like some of this stuff is not fully documented, and I think maybe if you have like the Windows SDK, maybe you can get to more of that information. Like WinDebug gives you a little bit of information, but this is like, yeah, that's fine. That's fine. It's a little bit, honestly, it's a little bit deeper than what I'm comfortable with. So I totally understand, right? Like it's on the fringe of like, it's like man, I want to do this thing. And then you realize that thing you want to do is, like, completely crazy. And so you do it, and you're like, maybe I shouldn't have done this because it takes up a whole bunch of time, right? But actually, let's get back to this. So I kind of went on a rant there, didn't I? So let's take these two inputs, right? And let's get the min and max, right? So let's do like a little min function, because we want to get the delta here. These are unsigned values, right? So we want to make sure that we don't do an integer underflow, right? By taking the lowest number and subtracting the highest number, right? So let's just say that and I'm going to write it in a dead simple way, right? So I know we've written a lot of... I have all this batshit insane code, but I swear I actually like code to be written dead simply. It's just that if you have a very complicated rendering engine, right? How does that guy from Insomniac Games say it? Hard problems are hard, right? So like, you can try to write your code as simply as possible, but if you have a complicated problem, you can only be so simple, right? But anyways, we're gonna write some simple code, right? So U16, right? So if we need to less than or equal to, and because I've gotten screwed over by this before. So if this is less than that, then U16 min is going to be U16 001, and then U16 max will equal U16 002, right? So if this one, sorry, hold on. So if the 1 is less than the 2, then the 1 is the min, and the 2 is the max, right? And then we're going to copy-paste this. And so you'll notice that some of what I'm writing is completely inefficient, right? Where it's like, but I'm not worried about efficiency right here. My main priority right now is to get code that that is just kind of simple to understand, right? So do we want to keep min and max in this order, or do we want to flip this statement here? What do we want to do here? Clean code, best code, yeah, right? Like, we can always worry about optimizing it later. So let's flip this, right? So we're going to have 2 on this side now, and that means that we just have to flip these, right? So, right, like, I think that'll be the easiest, right? And the next thing I like to do is I like to color code everything, and there should be some type of obvious pattern, right? There should be some type of obvious symmetry in the code so that I can look at this and see that everything's okay, right? And so I see that, oh, we got a diagonal here, we got a diagonal here, and then we can kind of see a mirror image here, right? And the other thing is we can checksum this as well. So we see the orange is 1, 2, 3, 4 oranges, and we have 1, 2, 3, 4 cyans, right? So by meticulously organizing our code, we can visually see if the code is correct or not, right? So when I'm writing my batshit crazy code, I want to meticulously organize that code so that if I forget what that code does, I can still find mistakes in the code by finding irregularities in the formatting, right? So, okay, so now we got our mins. So now the delta is pretty easy, right? So U16 delta equals the max minus the min, right? So U16 max minus U16 min, right? And then down here at the very bottom, we're just going to return the delta. But then we want to do some stuff in the middle to figure out... so let's kind of organize this a bit more. So we're going to make some nice little sections, right? So we're going to say... we're going to call this declare variables. Right, so we'll have a declare variables section, and we're going to actually have more indentation than is actually necessary, right? So if we can find a way to impose even more structure than what is usually required, I feel like we get a little bit of extra protection. Now, maybe I'm totally full of shit. Maybe this is just me being weird. However, I find it's nice to section things off like this, right? So this needs to be find delta of inputs, right? So what we're doing right here, we're just finding the delta of the inputs, right? So we can make a little section divider for that as well. Okay. And now we need to do some analysis. Analysis of inputs. I don't know if I spelled analysis correctly. I can't spell very well. So, you know, that's another reason why my variables are kind of terse, because I'm like, well, if I make everything very shorthand, I'm less likely to spell it wrong. That's kind of one of the justifications. The other justification is that the shorter the variable names are, the less possible combinations, and that just reduces the mental search space for me. But yeah, so let's do some analysis of the inputs, right? So when we're going to analyze the inputs, we really could look at just these original inputs here. And I think the first thing I want to look for is is one input just the reverse of the other input, right? So let's try that. So let's make a another U16 here, and let's call it U16 TMP for temp, or actually I'm going to do TEM for temp, just because a lot of times I like to abbreviate by taking the first 3 letters of whatever I'm abbreviating. Temp variable. Okay, so let's go through this and flip the bits, right? So we're going to say and let's make another variable here. So let's say this is going to be an int32, so I'm going to put it in a different section here, and I'm just going to call it dex, and this is going to be an index variable. Index variable for looping. And then over here, we're going to need to define a int32. Okay. And then down here, we're going to have to undef our int32 right here. So we're going to go dex equals 0, dex is less than or equal to, and it's a 16-bit integer, so we're going to do 16 minus 1. So I really have a thing for inclusive loops. So even though I have a thing for an inclusive loop, I want to also be able to look at the code and understand where the number comes from. So 16 minus 1 actually makes more sense to me than 15, right? So this doesn't make much sense to me. Less than 16 still seems confusing to me. Personally, for me, I like to keep everything inclusive. So this makes the most sense to me. You know, different people find other things more comfortable, but I find this to make the most sense, so that's how I do it. Okay, so we're going to loop through it, and we're just going to invert all of the bits, right? So we're going to take this temp variable right here, and you got to remember, right, that when you yes, I mean, you are right, that is the option that most people use. That is the sane option. You are totally correct. I do not make any, what do you call it? I never said I was sane. In fact, I'm pretty sure I said the opposite of that earlier. But yes, you are correct. That is the sane option. So what we're going to do here is we know that this variable was never initialized, right? So it has junk data in it, right? So we need to just, we need to fill it out. It is a 16-bit integer, so if we really want to be really explicit, right? If we really want to be, if we want to be overkill and do more than is necessary, we could do this, right? Like, this is absolutely not necessary, but I like to kind of write code where I can look at a line and I can derive a lot more. I can derive more by looking at this than I can from this, right? So I'm trying to write code that, so this is going to sound stupid. I want to write code where I could, like, print it off old school on an actual physical sheet of paper get a fucking highlighter and pen and start marking it up and figuring it out and finding mistakes. So I write it in a way where, right, I have a very stripped down development environment, right? So that affects the way I write code. So I try to write it in a way where I can derive as much information as possible from what I'm writing. So we're going to zero out this temporary variable, and then we're just going to flip the bits in, I'd say, the second value, right? So we're going to take this second value up here, and we're just going to flip the bits in it, right? We're going to invert all the bits. Or sorry, we're not going to flip the bits. I don't mean a XOR. I mean we're going to mirror the bits. I mean, well, it's going to make sense when I do it, right? So let's just do it. So we're going to take this, and we want the bit in the most significant bit index to end up in the least significant location, right? So we're going to say, take this value, and we want to shift it over, and we want to shift it over by, I'm going to make another variable for max index. Hold on. Do we want to do that, or is that just overkill? That might be overkill. So we want to shift it over by, let's see, we want to do, if we shift it over by 15, right? If we shift it over by 15, we've shifted it over all of the way, right? Let's make sure I'm not off by 1 here for a second. Let's make a little diagram here with a few bits. So if we have a bit here, we have a bit here, and we have a bit here, and we have a bit here. So if we have 4 bits, and we're over here, and we shift to get to over here, so let's go A to B, right? That would be 1, 2, 3 jumps, right? So even though, right, off by 1 errors are the bane of my existence, so I always like to check that I'm not making a mistake, right? So we know this is 4, right? This is 4 here, but even though it's 4, we shift by, shift by 4 minus 1 to get to the end, right? So we know that in order to shift out the most significant bit, we're going to have to shift by 16 minus 1. I'm going to do it, right? So now we want this to work in a loop, though, right? So when we want to swap this, right? So we're going to take, we're going to say swap by 16 minus 1 minus 0, right? Or, sorry, not 0, hold on. But by dex, right? So I would probably actually like to make 2 variables for this. So let's say let's say B1. Let's say B1. How about B1? Actually, bit index. Let me think. Hold on. I don't know. Maybe I shouldn't do this. So this is the shift amount right here. I don't know if that's going to be helpful, though. Is that going to be helpful? I'm not sure if a temporary variable is necessary just yet. Let's just, okay, so we're going to take this value, and we're going to loop through it, and we're going to take something in the most significant bit position, and we're going to shift it all the way to the right, right? Because for dex equals 0, we're going to shift it all the way to the right. And we need to merge this with something, right? Am I going to check for underflow? Oh, no, underflow was... So, okay, so here's my inputs. Let's call our input. So this is the first input, this is the second input. And we're going to compare them, right? And if they're different, we're going to return a non-zero value, right? So here's the delta of those two inputs, right? So we want to sort them, right? So the inputs we want to sort into a min value and a max value, right? So we're just going to take the inputs 1 and 2 and assign them to min and max respectively based on which one is the lowest and which is the highest, right? And then so right here we don't have to worry about, right here we do not have to worry about underflow or overflow. Let's just, for the sake of understanding this code, say that this U16-1 is less than U16-2, right? That's not always going to be the case, but let's say that for the sake of argument, so that way we can color code this and say that this cyan color matches up to here, right? So we're going to say that that this is the statement that gets executed, and that this variable is less than this variable. So the U16-1 gets put into the min because it's less, and the U16 number 2 gets put into here because it's the greater one, right? And then we're just going to take the delta, right? So right here we're just going to take the delta, and the delta is what we're going to return, right? So right here, we're returning the delta. So the function is going to be a comparison function where it, yeah. So, but I think the confusing part is that we're doing more than one thing, right? Like this is a comparison function, but it's also like a diagnostic tool, right? So if the numbers are different from each other, I want to know why, right? So actually, what we could do, so in the analysis right here, we could make this a little bit clearer right here, and we could say that if we could go up here and we could say that if U16 is not equal to U16 number 2, right? So in this section right here, we only want to execute this section of code if the values are different, right? So if the values are the same, we don't care. But if these two input values are different, we want to run some type of analysis on it. And the first analysis we're going to do is we want to see if maybe this value is just a mirror image of this value. Like maybe the bits have just been completely inverted, right? So what we're going to check for is, actually I'm going to delete this diagram, and we're going to make a little diagram here to explain what we're checking for the first thing, right? So 0, 1, 0, I don't know, 0, 1, 1, 1, 1, 1, 1, 1. Actually, let's do this. Let's make a pretty simple diagram. Check to see if the bit patterns are mirror images of each other, right? So this could be example. So this might not be the best example of U16 because it's only 8 bits. So maybe that, I don't know if that's too confusing. But right, so it's not really a comparison function because the values were supposed to be equal. It's more like an assert and debug, right? Yeah, so I am going to use it like, yeah, I'm using it kind of like an assert. Yeah, like I am going to, yeah, it's more like an assert function. Yeah, like maybe, Like, I'm not sure that I want this function to crash the program. That's why I didn't name it. That's why I didn't name it assert. But it might be a good time to think about what I actually want to do here. So how about we name it here? Why not? It's like, assert and analyze. So I cannot spell analyze to save my life. So we're gonna call it assert and inspect. How do we call it? Assert and inspect. And then so why not call it this? I still don't know if I actually want it to crash the program or not, but I'm okay with giving it kind of this name, if that makes that clear. And then what we could do is we could say care and message to display when assert fails, right? So we'll have like a little message. This will be like a little string here. And actually this needs to be a pointer. And we'll display this message. So we're going to compare these two values. And then if they're not equal to each other, we're going to display this message, right? So let's do that. So let's define CHR. Right? So const char. And then down here, we're going to undef it. Also, another thing is I will never type def or define something with the pointer symbol in it, because I find it's very error prone. So I will never do something like this. I'll never do something like this. Like this, I think is very error prone, right? Because you glance at it and you're like, oh, it's not a pointer. But then when you look at the define, yeah, it is a pointer. I think that's very error prone, so I'll never do that. So there is some sanity to, I swear to God, there is some sanity to some of what I do. But yeah, so this will be CHR, and it's going to be const char. It's not going to be a pointer, because that is error prone, right? Okay. So now that we have this char type, I was exactly typing that, yeah. Okay, cool. So, okay, so now that we have... Oh, were you typing that? Were you, as in you were explaining why not to do that? Or, but yeah, but you get why you wouldn't do that, right? Because it's, you learn pretty quick after you've written it in code a few times, and you get royally screwed over. But yeah, so we got this error message, and so, let's just say that at the end here, right? Let's just say at the end, that you are not totally lost for type defing pointers. Totally lost for, yeah, I don't know, like, yeah, like, just, I don't know. I would just find that, yeah, I don't know, putting a pointer in my type def, putting that in a type def, I don't know, I find that, that confuses me. So I do not do that. I will say that when people do it, I do think that, you know, if you are going to do it, you know, at least have some type of convention where you have, like, PTR or something, you know, so that at least you can tell. Like, you know, in Win32 code, it's like, LPC, STR, a long pointer to constant string. God, they have such weird stuff in Win32. But yeah, at least have a convention to tell me what it means. Okay, so down here, let's say, crash or notify if, different. So at the very end, we're gonna do our little assert thing. We're gonna crash or notify if different. So I haven't made up my mind as to what I want to do, but we're gonna say that you know, if these are not equal here, then we're going to printf that message, right? So I don't know if we want to... Let's just do printf, and then we're going to do onos, and then %s\n, and then the error message. So msg error for message, and the type of message is an error message. We might as well put msg error in here so that we kind of see what we're printing off. Maybe we can make a more informative thing later here, but we'll just stick with onos for now. I think that's fine. Okay. Also, if you notice that I kind of do 2 semicolons here, that's because if a statement is a one-liner, see this one-liner statement? One-liner statement gets 1 semicolon. A statement that spans more than 1 line gets 2 semicolons. It's just because I'm really paranoid that I'm going to accidentally do something like this. And I'm going to be like, oh, right? Like, I don't want to accidentally make mistakes, so sometimes I add redundancy to the code. And it adds just weird kind of things like that. Okay, so yeah, if these are not equal, if the inputs aren't equal, we're going to notify, we're going to printf. I don't really think we should exit. We could, though. We could exit and just say exit, and I don't know, 404. I don't really care. Oh, actually, I think the exit codes actually need to be 255 or less. So, how about 77? Okay. And I believe I don't have the correct include for that. Actually, I don't have any includes yet, do I? So let's include... We're going to include printf, include exit. Yeah, that's... actually, we need stdint as well, so include stdint. I don't know if I have something for that. Does that work? Yeah, stdint. Excellent. Okay. I also like to keep track of, you know, why I am including these things, right? So printf, exit, and then this is this right? What the heck is this? Int. Oh yeah, because the bit width. It might be a little bit easier for uint16t, uint32t, etc. Alright. Okay. So now that we have these, another thing we could do is, because I am crazy about, oh, you do that in some projects where you kind of like label what you're including them for? Yeah. It's just helpful because, right, printf and exit, they don't have any type of namespace connected to them. So it's just really annoying sometimes when you just don't know where something comes from. So let's just call this includes. I'm going to call this includes, and I'm going to make a little section divider for the top of this. And then we will paste this down here. All right, cool. And then we'll just kind of like, there we go. Okay. So yeah, the first analysis we're going to do is, well, first of all, any analysis of the inputs is only going to happen if they're different, right? Because if they're completely equal, there's really no analysis we can do. They're equal, right? There's no patterns we can find. There's no pattern relationship between the two numbers that we can find in their bits if they're completely equal, right? I mean, they're equal. That's all there is to it. There's nothing more to find, right? But if the numbers are not equal to each other, we want to kind of inspect that number and see if there's any patterns, because if there's any certain patterns could kind of clue me into what I'm doing wrong in my code, right? If I'm expecting two binary numbers to be equal, and I can find a very specific kind of pattern, it'll lead me to figuring out what I'm doing wrong with my code. Okay, so here's our temp variable, and we want to kind of smash together the temp variable with something here. So U16 temp equals, and I know a lot of people, so speaking of the same option, I know people would do like or equal, blah, 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 but I don't like or equal just because I like things to be... I don't want the fate of my code to depend on not accidentally deleting one character, if I can help it. I don't know. So I like... If there is a more verbose option, a lot of times I take it just because I'm so paranoid about accidentally deleting something and then not being able to figure out what was deleted. So I am going to write it in a more verbose style, where I'm going to say U32... So I'm going to say U16 temp equals U16 temp, and then we're going to bitwise OR it, right? We're going to smash it together with all of this stuff here. So we're going to take this variable, and we're just going to invert the bits, right? So we're going to go, so for yeah, I've heard about Rust before. Now the thing is that I'm sticking with C just because I want something that has a guarantee to be around forever, and it's also that you know, when you're trying to use other code, I think you got like a little bit less of a selection of other people's code to use when you use Rust. Now I could be wrong there, maybe I'm wrong, but for example, like, I'm not using too much third-party code. The only third-party code I'm using right now is load.png for loading PNG files. I tried to do my own PNG decoder, but after like a week of reading RFC documentation and Wikipedia, and making some failed attempts, I gave up. I'm like, man, PNG decoding is a bit beyond my mental capacity, unfortunately, right? Sometimes you have to know what your limits are, and you got to know what your limits are and kind of work within them, right? And now, when you have limits, you can kind of try to expand those limits and get smarter, but sometimes you just got certain limits, and you need to work around them, right? Also, building a team of people is also helpful, right? Like, if you don't know how to do something, find somebody else who can. But anyways, so let's think about this code for a second. So if the dex equals 0, if the dex equals 0, we're going to go into here and take the bit at the most significant bit position all the way over to the left, and we're going to shift it all the way out, right? Because this dex is 0, right? So that means we're going to shift over the maximum amount, and every time dex gets incremented, we shift over less and less and less, right? So this will shift over the correct amount. Now, don't we need a mask? Don't we need a mask for this? Because we're shifting this over. Yeah, we need a mask for this, right? So we're shifting this over. Is this the easiest way to do this? So we're shifting it all the way over, and we're always shifting it into a different slot. Okay, yeah, we're going to have to mask this. So, we're going to have to take... So I think it would be easier if we do a, well, actually, no. So, let's think about this. We're going to need to mask this, right? So we're going to need to take the number 1, right? We're going to need to take our binary 1, and we are going to need to shift it over by the same amount, right? 16 minus 1 minus dex. Okay. Because we only want to focus on that 1 bit, and we want to shift it into place, right? So we want to take this. We want to take this and this, right? Is that correct? Let me think about that. Yeah, so we want to bit mask this. So we want to shift this over into position, but we also want to bit mask it after we shift it over into position, right? So we want to shift this into the target position, and then we want to mask it, right? We want to mask it so that we have, so at the end of this, we have a 1 bit integer. Or, sorry, we have Yeah, so I'm not super good at bit shifting, so I'm going to look at your code here. You can do an A equals A, shift over 8, or... Oh, is that how you can do it? So you can just do... Oh, is that how easy it is? We don't even have to do this crazy stuff? So you're saying that the algorithm would be something like... you're saying we can do this, right? You're saying we can do... now, is it 8 or is it going to be 16 and 16? Let me think about that. Well, you know, we can just test it out, I guess. So you're saying something like this? Or that with... I know, because I know there's probably already algorithms for this, right? Yeah? If A equals base, it's that case. Okay. Okay, so let's try that out, then. So... A does equal B because it's the same exact variable, right? So you're saying if we want to swap the bits, then this algorithm will do the trick for us. Okay, so let's try that out. And actually, then we don't need the loop, right? We don't need the loop at all, right? I'm fine with that. So then we don't need to zero out. Oh, sorry. We don't need to use the temporary either, though. We want to use the actual thing we're inverting. So let's actually no. Let's take the temp and let's invert the second one, right? Let's invert the second one. All right. So we'll take the second one, we'll assign it to the temp, and then we'll invert it, right? And then we'll say if U16, right? So we inverted the second one. So this is the inversion of the second, right? So if this now equals U16 temp, then we want to just print off that the bits were let's make a note here. So U16 temp is I don't know what the verbiage for this is. It swapped? Swapped bits U16002, right? So this temp variable is the swap bits U16002, right? So we're still comparing 1 and 2, but we're comparing the bytes were swapped. Okay, cool. Double P, yes. I don't know what your last thing you're saying there means. Oh crap, yeah. I don't know if you meant that, but I'm missing that, so I'm going to put that there. Our inputs mirror images of each other, right? And then if we get to here, we'll just kind of like print off mirror images of each other, right? Okay, so now that we have kind of the basic function, we don't want to add any more diagnostics yet. We just want to kind of run this function, right? We want to run it and supply it 2 inputs, and then just see what happens, right? So we got an argument array, and we got a number of arguments. So I'm going to require that this function takes exactly 2 arguments. And I already know that if... expect exactly 2 user-supplied arguments. So, right, the first argument is the path to the executable, right? Like, argument 0 is special. So we'll just say that we're expecting exactly 2 user-supplied arguments. So I'm going to write it this way. We can make a note that 2 plus 1 because first argument is not user. Okay. Argument count comes first. Did I do that wrong? Okay. Then I will throw that in the other order. Thank you. It has been quite a while since I've actually had somebody help me with my code while I'm typing it, and that's actually helpful because like I very rarely make command line utilities. So this is something that I don't do it very often. So I am super rusty about this. So yeah, if they're not equal, have a little message here, and then otherwise, we're going to run the code, right? So up here, what is our function? Assert and inspect, and it takes 3 parameters. So we'll take those, and assert and inspect, and also we need to parse the arguments, right? So also, if it's the same exact data, then it should have the same exact name, if you can help it, right? Sometimes you can't help it, especially in a very large code base. But here, it's a very small kind of project, so we don't have to worry about it. This message error, right, we're not going to worry about it. When we're using this as a command line utility, we're going to supply this, right? We're not going to worry about that. We just want to worry about getting the 2 numbers from the user. So message error will be carrier pointer, message error equals, I don't know, default error message, right? I don't care. Or actually, it's not really a... Let's not worry about the semantics of what this message actually means. It's just a message for me that when I use this assert function, I can kind of figure out where it came from by looking at the message and finding the hard-coded message in the source code. But also, let's go over here. We need to main function. So this is our main function. So we're going to make a section for the main function as well, right? We're going to put everything into little function sections to keep the pattern of the code kind of the same, right? So let's indent this, and we'll have to, we got to define int32, we have to define U16, and we also have to define character, right? Const char. And then we'll line that up nicely, and then we'll undefine these at the end of this section here. So we'll just go like this, we'll go undef, we'll add a space, we'll get rid of that. Sometimes when things get kind of long, I'll put like a little checksum. So I'll go like over here, and then I'll say like, you know, here's a checksum for how many defines and undefines we have, right? So 0, 1, and 2. Okay. So now, we need to actually derive these, and I'm gonna cheat. I'm gonna cheat because I wrote a command line utility like this a few days ago. So I have a. I'm just gonna reference that old code. So it was in here. Let me see how I wrote that. Okay. So let's go down to the main function, and so arg. Yeah, so arg count, I see what you're talking about. Yeah, the arg number, the arg count. Sorry, I said that. Blah. Number of arguments in the argument array. And let's look at this argument array. Hold on, where am I using this? Oh, text to hex text. So I'm like taking... Oh, I see, okay. Do I have anything else where I do... Hold on. I think I have another... Let me look at some other code. I think I like this one better. So this is like a utility to print off a number as a binary string. And I think I would like to look at this one instead, because I think this made more sense to me. So yeah, the number of arguments in the argument array, right? So we kind of did... Oh, crap, did I do that wrong? It's double pointer. Yeah, because it's a list of strings, right? So it's a double... Oh, never mind, I did that right. That's weird. I'm like, oh, I probably did that wrong, but no, it's right there. Okay, never mind. So let's see. Here is our array. And this is what I was... So I was using A to I, but then I wanted hex values as well. So I used this, and it looks like we just supply zeros, and then it uses context clues to figure out what to do. Okay, cool. So this is the line I want. And before we go any further, we might as well put that in our shortcuts, right? So that's kind of a helpful little thing to remember. So parse integer from command line. Parse int from command line. Parse int from CMD, right? So we'll just type some things. And we'll say argument from command line. Right, so we're just going to rename that just so it's a little bit more obvious, because we don't have any context surrounding this, so we just want to know what the heck is going on there. And also, we also might want to make another example called strtoul now. So this is the unsigned version, right? Because I believe there's a version that doesn't have a U. So we'll make a shortcut for this as well, right? So if we ever want to know how to properly use this function, then we can type now, right? So what's going to happen is, when we're not very familiar with the code, we're going to type commands like this, right, to get to here. But as we become more experienced with this function, we're going to end up knowing exactly the function name, and we're just going to want like a hint as to how to use it. So once we're more familiar with this function and it's more ingrained in our brain, this is the shortcut we're going to end up using. But for now, being a complete noob, this is the shortcut I'm going to use. Yeah, I have to start to make a curated utils folder with stuff like that. I keep re-implementing for no reason. Oh yeah, I totally understand, right? Forgetting where stuff is like, it's this totally big problem. Yeah, I feel you there. But I do like, I do find that writing little utilities and then putting them up on GitHub actually kind of helps a little bit, right? Because a lot of times, like, I will go on GitHub and be like, I know I wrote this piece of code, I need to find it, right? And I go on GitHub, right? Because when you have an actual working piece of code, when you're going to cut and paste code, the best place to cut and paste code from is code of yours you've already written that you know works, right? So yeah, so now we got we got this for reference. Let's say, do I already have a thing for parse int? I probably have, right? So I used kanji for this, so let's do parse int and parse int. And let's go find that kanji, right? So, right, so there's a high probability that I'm never going to remember these or type these correctly. So it'd be nice to have like a little parse int shortcut that can put me on the correct path to finding this shortcut, right? So I'm going to go look for the parse int kanji I have, and I'm going to make it more specific, right? So parse int right here. So this is a pretty old shortcut. So I said I had about 30,000 shortcuts, and this is at 1,000, right? So let's do parse int kanji, and then parse int kanji, right? And then we'll take this guy right here. And then, now that we have this over here, right? So this is, right, so parse int kanji, right, is what I used it to mean. But we can see from my shortcuts that that the actual meaning of this kanji is tally, right? So let's go back up to the top. Let's go back down here, and we'll say pick parse int kanji or parse int C99, right? Technically, it's also C11. And then we can take that here, and we can do bam, and then parse int C99. Technically, it's also C11, but then we're going to have to write C99, C11, C89. That could get out of hand. right? But now when we type parse int, right, like if we forgot exactly what this is, we have a little bit better chance of finding it again, right? But let's not get out of hand here. We have kind of what we want. Let's take it and go with it, right? So I believe this will give us a, I think this gives us a 16-bit integer. Actually, no, I think it's, no, it has to be 32-bit, doesn't it? I use this with 32-bit numbers, so it must be 32-bit, or I don't know exactly what it is. I'll probably have to check the signature if I get screwed up here. Let me put this over here again. So let's look at the code here. So we want a U16, and it's U1601 equals this command, and it's going to be the argument array, right? Argument array number 1. And then we want this as the second argument. First argument, second argument, 1 and 2, right? Because 0 is that special argument. So that's nice. The numbers line up nicely, right? We got the 1 and 2. We got the 1 and 2 here, and we also have the 1 and 2 over here. That's nice. I like that. Now, I feel like there might need to be a cast. In fact, I'm going to look this up really quick because I just want to make sure I'm not doing anything stupid, because implicit type conversions are actually one of the things that gets me sometimes, that really screws me over and makes bad things happen with implicit type conversions from my experience, from how many times I've had failing test cases, and I'm wondering why the test is failing, and it's because I'm passing like an int32 to a function that takes an unsigned 8-bit, and it's like, I know there's a compiler setting for that, right? But I have some code that isn't strictly abiding by that, so I have to like fix the problems with some other code before I can make my compiler settings more strict. And load PNG also violates that compiler setting, so I have to actually manually edit load PNG if I want to fix that problem. It's just, okay, unsigned long int. So a long integer would be 64 bits, I believe. Or at least on a 64-bit system. So yeah, casting might be a good idea. Downcasting, I think, would be a good idea. So yeah, I mean, there's going to be implicit conversion, but I like to be explicit, so we're just going to do this like that. Okay, cool. So we got this, we got that. We got assert and inspect. And I'd say that's good to go. So the next thing you want to do is we just want to fix all the stupid mistakes we've made. Like, I don't know where I've made mistakes, but I'm fairly confident in my ability to screw things up. So we got our build script here. We're ready to give it a run and see what is going on here. So first of all, my build script is a copy-paste kind of a thing, right? It's just from my shortcuts. So sometimes I copy and paste, and then I don't change everything correctly. So right here, instead of pub-base, it's going to be BPA U16. I like how clean this build script is, but I hate the fact that I cannot put any commentary as to what these things are, right? Because you see how we have the line continuation characters here? Because it's all one big line. So I can't put any inline comments as to what all of these are in the bash script, and that annoys me. Like, I like how clean this is, but I wish I could have some commentary. Now, there is a way, like, I have other build scripts where I can put commentary in them, but I use a here doc to do that, and it gets really complicated really fast. So it's just a trade-off. I mean, what we could do is we could put some commentary like down here, blah blah blah, about what those different flags are, but we cannot inline the explanation about what these are, which sucks because what happens is I start to forget what they are, right? Like, I know pedantic will catch me when I do things that really shouldn't matter, but we want to be strict about our C code, right? So I can't have a semicolon at the end of a function because I have pedantic turned on, right? I know that this is for extra warnings. which I don't quite understand because I thought this is warn all and this is warn extra. So it's like, I don't know why these are two different things, right? So it'd be nice if I could have a comment in my build script to remind me what these things were for. So I know this is for strict aliasing, and this is warn if you violate strict aliasing. So strict aliasing being, you know, if you have, I believe strict aliasing actually covers two things, right? Like strict aliasing is actually strict aliasing rules. So it's actually a set of rules. So one of those rules is when you have a function and that function takes pointers. Each one of those pointers needs to point to a different memory address. Then one of the more esoteric things with strict aliasing is that the same memory address cannot be typed to more than one type of data, right? And the way you get around that is if you want to get around that and have one memory address represent more than one type of data, you can use a union, right? A union will allow you to get around the strict aliasing rules. I don't know why. I think it's just that in the C specification they said, hey, we have these strict aliasing rules, but if you really need to break them, you can use a union, and then we will let you, or something like that, right? And then we're going to compile as C11, and we're going to do 64-bit, right? So right now I'm calling this exe.exe. However, because I'm going to actually put my executable into the project, like I am actually going to commit the executable into the code base. You know, maybe that's a little bit hackish, but it's a small executable, and whatever. It's my code base. I can do what I want, right? So we're going to get rid of we commented out the remove, right? So usually when I have a build script, I build my project, and then I run the executable, and then after I'm done, I just immediately remove the executable. In most projects, I will do that. However, I want to keep the executable around because we're making a command line utility, so we want to check to make sure that, you know, it's working correctly. So let's just double click this and see how things are going here. So we've done something stupid. I'm not sure what, so we're just going to look at line 26. So a lot of times I will not even look at all this stuff. I'll just be like, what line is it? Because there's so much stuff in the error messages that it sometimes takes more time for me to read error messages than just to look at the code and be like, oh, I made a mistake there. What was the mistake, right? And so the mistake is, right, you told me that this will flip our bits, not flip our bits, but swap our bits, right? So we're going to go with this, and we may need this variable in the future, but for now we don't need it, so we could just comment it like that for now. So it's there for when we need to put it back in, right? And let's see what else we need to do. Okay, so that's not too bad. I mean, I actually expected to make more mistakes than that, but it's always nice when you make less mistakes, because then you think you're smart, you know? So let's do git bash here, and we're going to put this over to the right, and let's zoom in a bit here. Alright. Yeah, first try. Well, I mean, more like second try, but yeah, you know? It feels good when you can do that. You can be like, yeah, I'm a badass. I write all my code without IntelliSense or any type of linting, and I write it correctly. Like, that's nice. That's nice when you can do that. I'm not always that good, though. So let's give this a shot, right? So we want to do /. Oh, crap. Did I just type? So this is why I'm paranoid about accidentally deleting things, because I accidentally typed in this file here. So that's why I like redundancy in my code, just because never underestimate your ability to screw things up. Okay, so anyways, // BPA U16 .exe, and then we're going to supply two numbers. Let's supply like just 4 and 4, right? Keep it really simple. And nothing happened, but we didn't really have any type of output message if they were equal, right? We just said to do nothing, right? Now that might be that might not be how we want to do things. Like maybe that is we can silence that later. So when you're writing like a Linux flavored utility, that we're actually kind of behaving properly, because like in a Linux philosophy, they don't want to. You don't want to pollute the console with a whole bunch of blah, 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 right? Usually you only want to know about something when something goes wrong. So, I mean, that's kind of proper, but I would like to actually kind of know. I'd like to get some more feedback, right? So, we'll just say that, you know, if U16 is equal to... I'm really paranoid when I do that, though. I'm going to do something stupid. Is equal to... Can we do that? Yeah. U16... I'm going to add plus zeros here, because I think if I add a... if I do that, then if I accidentally do this, if I accidentally make an assignment here, I believe this plus 0 will catch me. So I'm just going to put a plus 0 on both of them. To help catch me from doing something completely stupid. And we'll just say, you know, printf, say they are the same, boss, \n. Okay, so let's give that a run. So ./bpa u16.sh, run the script. Okay, clear. Then let's run it with a 4 and a 4. Okay, they're the same. Okay, so let's do bpa u16.exe. Let's try 4 and 5. Default error message. Oh no's. Okay, cool. So now let's go bit twiddle this and make our like inverted. Well, actually, we don't have to do any bit twiddling, do we? Ship it, yeah, there we go. Ship it, we're ready. So we don't have to do any bit twiddling for a simple example, right? Because we're programmers, we know a little bit of hex codes, right? We know the hex codes. So let's just try a 16-bit hex code of this, and then try the inverted version, right? Which is 00 and FF, right? And let's see, so yeah, mirror images of each other. Okay, so you were correct with that formula. I really need to get that book called, I need to buy Hacker's Delight, because I believe that book has a lot of these, like, little tricks in it. But, yeah, so I'm pretty confident that works, but we should probably put one more thing in it, right? And also, we're gonna write some other analysis, because there's some other things that I might be doing, like the endianness might be off. So I'm gonna check things like that as well. Oh yeah, that book here. Let me find it for a second. It's yeah, it has bit hacks in it. It has bit hacks in it. It's not just bit hacks though. I think that there's other things in it as well. But it's like little C hacks basically. Yeah, I mean, if you have some links to share, that's cool. I'll take them. Hacker's Delight. Okay, well that sucked for a shortcut. Oh, okay, never mind. Let's just say I already have that book, because I have it in PDF version. Let me see if I can find, it on the internet really quick, though, so I can find, but I'm gonna take a look at your stuff really quick after Hacker's Delight, after I find this on, like, Amazon, so yeah, I think this is the book. Yeah, Hacker's Delight. I don't know which edition, but, this thing here. I'm gonna take a look at your thing now. Okay, bit twiddling hacks. Sean Aaron Anderson. Reversing bit sequences. Okay, so we got the naive. So I'm guessing the obvious way is the naive way, right? Okay. So this is interesting. So I'm not really, this is why I'm saying I'm not a complete, so obviously I have like really complicated ways of like how I'm putting together a structure, but that doesn't mean that I am a god at C, because I'm looking at this and I'm like, so, you know, some type of, right, this is what you want to do every single step. This is your condition, and this is the initial value, right? So initial, the checking condition to see if you should keep on doing stuff, and then the thing you're doing every single loop, right? But, you know, obviously, like, got ya, some stuff is complete gibberish, I got ya. Though it is good to, be able to, understand some stuff that is complete gibberish, right? You know, it's like, it's like if you're, like, weight training or something, right? Like, you lift super heavy weight, so that when you do normal tasks, those normal tasks are, like, really easy, because you're used to lifting super heavy weight, right? So, like, maybe you read code like this so you can understand it, but then when you write your own code, you still write it dead simple, right? But you write it dead simple, but it's even more dead simple to you than ordinary, because you're used to, like, reading kind of crazy-ass code, right? So we got reverse bits the obvious way, reverse bits in Word by lookup table. Okay, so here's what I'm going to do. I'm going to take this, and we're going to go to my shortcut scripts. And then we're just going to go RBS. Oh. Oh, what day is it? Oh, that's just my auto commit scripts. Okay. So I'll just put that in there. And I believe my script does not like hashtags encoded, so we'll put that. That might actually cause a problem. Oh, what I might want to do is I might want to put this in its own file. So I'm going to take this. I'm going to make a note that this link is here, right? So this is going to be in a comment. And then I'm going to put your link into a file. And then I'm going to save this somewhere. So I guess URLs. And it's like an edu URL. Edu. Do you have an edu? No, we don't have edu. Let's new folder. We'll make an edu folder here, and then we'll call it godlink._. We'll take that full file path to clipboard. Then we'll put it right here. And this is where it will remain for all of time and all of eternity, right? So, and also we can do that. You can have like a permalink, right? So godlink always goes to here, right? So uppercase, right? Uppercase in snake case. Uppercase snake case. Screaming snake case is for constants. So I kind of use that convention with my shortcuts, where if I have a shortcut where it always points to the same thing no matter what, then I'll use like all uppercase like that, right? Okay, so there we go. So there, now it's in there for all of eternity. So I will check that out at my leisure. Okay, so let's put that back on the other screen now. And let's think about the endianness. So let's close this. And let's close this. Nope. and build script. Don't care about the build script. Okay, yeah, here's where we were. So we had this, and here's the first thing we did, right? And do we have enough? I feel like we're gonna lose some indentation space really quick if we start indenting this even more. And I don't know if I want to do that. So let's let's call this swapped bits check. Right, so we'll just make like a section header for here. And then we'll say we're gonna make another section in here. This is just because we're running out of indentation space. We've been like so I want enough room here. So I'm going to change my style a little bit so that I can know, just because I don't want to indent this anymore. I don't want to indent this and put it into another subsection just because it's gonna get really cramped really fast. So endian byte endianness check, right? So we'll do a byte endianness check next. And for this, we just want to compare each byte, right? So rather than each bit, we want to compare each byte and see if they are let's just do this the naive way, right? So I just want to see if the actual bytes. So it's a 16 bit value, right? And there's 8 bits per byte, so it's just 2 bytes. So we just need to cross-check the bytes and see if they're equal to each other, right? So if U16 001, and we want to shift it over by an entire byte, right? So we want to shift it over 8, and after we've shifted it over, it's only 16 bits, so we really don't need to mask it. However, I'm a very paranoid person, so I'm going to mask it anyways, even though we don't really need to. And then, we want to say, you know, if this is equal to that, right? So if this equals U16 002, and we're not going to shift that one over, right? We're not going to shift this one over. Right, so if that, so we're going to cross-check those bytes, but then we want to look at the other ones as well, right? So, and then for this, we're just going to swap our shifts, right? So we'll shift this over 0, and we'll shift this over 8, and you'll probably think I'm crazy, because it's like, why are you shifting 0? And I just think it's important to keep a pattern in the code, so the code feels more regular in terms of formatting when I shift over by 0, right? Even though it's a pointless operation, it feels, to me, if I don't do that, it makes it less obvious what's going on to me. So I will do kind of a lot of weird things just so that I can see the patterns in the code. Okay, so we're going to look at the first byte of here and the second byte here, right? And then alternatively, the second byte here and the first byte here. And if those bytes, right, we're going to mask them off, okay? So if this is equal and that's equal, well, then we know that the endianness matches, or there's a possible mistake with the endianness, right? So we'll say print f, and we'll say we'll just call it like inverted endianness, I guess. And it looks like we didn't put a new line on here, so let's put a new line there. Okay, so now we want something where, so we want something to invoke this as well, right? So to get inverted endianness, the example we already used would trigger, should trigger this. It should also trigger this, right? So we do want a case that will only trigger the inverted endianness, but let's just get this running first, and then let's do that, right? So, okay, so let's git bash here. Okay, let's scroll in here. Okay, so /bpa U16 .exe. And we're going to do 0xFF00 and then 0x00FF, right? We're going to expect both messages, right? Because not only are the bits inverted, but the endianness of the bytes is also inverted, right? So we're going to get two messages, we're thinking, right? So mirror images of each other and inverted endianness, right? Okay, cool. So now let's try one where it's only the endianness of the bytes, but they're not mirror images of each other. So let's try something like that. So what would that be? Can we do something in hex that will do that? So how about F0 and D0 photo. Okay, and then 0x D0 F0, right? So here we've just flipped the endianness of those bytes, but the actual bit pattern I'm not expecting to be a mirror image of each other. You know, maybe I'm going to be surprised, but let's kind of see what happens here. So is that true? Because we got both messages. Is that true? Let's open up a calculator, because you never know. Maybe that's just the case. So let's look at this. And so if we look at the bitwise of, well, let's look at the hex. So F, how the heck do we get this? Hold on, let me take this. So copy. Okay, so we got 111 and then 1101. Okay, so let me write this down somewhere. Maybe I should have put it over here. And this is not my editor that I want to use. Okay. So let's just, I don't know where I want to write this. I guess I'll just write it at the bottom of the file right now. Okay. So F0D0 equals 1111, a whole bunch of zeros, 1101, and then zeros like that. Okay. And then if we do the opposite, so let's clear this. I don't know how to clear it. Okay, so now the other thing is if we do 0xD0F0. Okay, let's try this one. And I don't understand why the context menu for this calculator only has copy, and you have to do Control V for paste. Okay, so let's look at the bits of that. So the bits of this, we got 1101, we got 000, we got 111, and then we got a whole bunch of zeros. So right here, we definitely got a mirror image. And then we got 1101. So that doesn't, hold on. So, I'm not making any sense here. So this doesn't look like a mirror image, right? Because this looks like, yeah, this is not a mirror image, because this is, because we got zeros on both sides, so this is not a mirror image. Now that, okay. So let's look at that code again. So let's go look up let's go look on the internet, and, swap bits U16, right? Oh, is that... We don't want to convert the Indianness. Indianness, that's not what we want to do. We want to swap the bits. C, reverse bits and unsigned integer. Oh, is it called reverse? Is that what it's called? Here's the typical solution to oh, Jesus Christ. Shouldn't be that hard. That does not seem... Oh, okay, I see why. Okay, so I kind of see what's going on here. I don't completely see what's... Yeah, I meant mirror bit by bit, right? Because I'm doing a lot of bit packing. So some of the mistakes I could be making could actually be at the bit level, right? Now, there's other mistakes that I could be making that could be at the endianness level, so I also want to check for that. But I just want to check for different kinds of patterns of mistakes that I could be making. So I realized that here they're doing everything, and I was wondering why this looks so complicated, but now that I see, well, there's no loop here. So yeah, this one, okay, so let's go back to the code there. Let's just write it, because I don't want to think about it. So was this one a, so I'm gonna assume from the code you gave me earlier that it was a byte swap, right? I think. Like, this is probably a byte swap, right? Like, because we shift over 8 bits in a byte, right? And then we shift this over 8, right? 8 and 8 is 16. So I'm assuming this is a byte swap, right? So I can kind of see why you gave me that, because I wrote this example like this, which kind of... Yeah, totally. I totally get why you would have thought that, because the example I used kind of an example where yeah, I used an example where I could just easily know what was in the binary. Yeah, like maybe I should have done something yeah. Yeah, like the example was probably was not the best example. Yeah, let's make another example here. Let's do another example here to be a little bit clearer. So let's do like, and then, okay, we don't want the bytes to be... Actually, no, we should do something like, we could do... And if we did this... Okay. So these are not, right, so these are not a byte swap anymore, right? Okay, yeah, these are not a byte swap, yeah. So this might be a better... Yeah, okay, yeah. Got ya, yeah. So speaking of that, so a lot of people, like if you read the book Clean Code, and a lot of people are like, don't write comments because, oh, then the comments won't match the code. But I will tell you that half of the time when I write code, it's the code that's wrong, and it's the comment that is correct. So my opinion on code not matching the comment is that if the comment doesn't match the code, then your code is wrong, right? Your code is only correct when the comments and the code agree with each other. Otherwise, your code is incorrect. So let's use this example as well. Example... Yeah, so let's use this example right here, so that way we can be like, you know, we have another example where this example is simple enough to where this actually could be a byte swap. This one I'm only wrong one time, yeah. Or actually, if you don't comment, then actually you're always right, right? Because the computer always does exactly what you tell it to do. So if you don't write any comments, then your code is never wrong. You know? So yeah. Yeah. I don't know, like sometimes I get like sometimes I have like one viewer and I'm like, yep, that's probably just my bot. That's probably just my bot like soliciting. But holy crap, 3 in a row? What the heck? 1, 2, 3. Like I usually get like, and it's always the same message, so I don't know, like somebody must have made like some type of script or something that everyone's using. Are these all the same length? Yeah, like, I don't know, I'd say 45. I'm slowly getting more viewers day by day. But I think it'll be, I'm just gonna, I think I'll start to get a lot more viewers as this engine progresses, and I get things that are kind of, like, much more visually interesting, right? So I'm gonna start to do, once I start to get some really interesting tech, we're gonna do, like, tech demo days. And then I want to try to get my artist to do like a artist channel with the engine where he just draws stuff with the engine tech. But he also has some, I don't know, we all have problems, unfortunately. We're all getting old. We're not as bright-eyed and young as we used to be. Anyways, okay, yeah. So let's actually kind of flip these bits or swap these bits around. So let's write that index loop again. So for dex equals 0, and then dex is less than or equal to the unsane option of less than or equal to 16 minus 1, and then dex plus plus. Yeah, I mean, yeah, I don't feel responsible for anything. Like, I think I'll definitely get more people as I go by. But yeah, the idea is that eventually, like, I want this, the work I'm doing to be like an engine that people can use, right? So, like, I want to make sure that, people, you know, they can talk to me and I can, like, interact with them. So eventually I want it to get to the point where someone's actually using my engine and somebody can come on my stream and then I can like tell them we can like troubleshoot, right? I think that'd be pretty cool. So we'll figure that out as we kind of go, right? Okay, so dex, we're gonna go through these indices, and we're going to take the U16 value, the number 1, and then we're going to shift it over, blah, 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 something, something. Ehor in gaming subreddits, maybe. I've been doing worse than that. Sometimes I'll be like, what have I done lately? Somebody on, certain sites will be like, certain sites, I won't say what kind of sites, but, there's some context clues from the thing you type. Some people on certain sites might be like, hey, who is that girl? And I'll message them in their inbox and be like, this is that person you were looking for. Now here's my programming stream. You probably don't like programming, but I helped you out, so maybe check it out. So I'm quite literally doing that. Not like all the time, but like every once in a while. Okay. So I figure like it's like a guerrilla strategy that no one else is doing. I'm like, it's so insane. Nobody else is probably doing this. I want to do it. So let's see. U16. We're gonna shift this over by. Okay. Well, let's start with the index. If we shift it over by. If we shift it over by dex, what happens here? Let me think about this. We want to start by shifting it all the way over, right? So we want to shift it over by 16 minus 1 minus dex, right? So we're going to shift it over progressively less. And then we want to mask it with... we want to mask it with a 1. And that 1 needs to be shifted over by the exact same amount. Okay, so we're going to shift it over, right? So the first time it gets shifted over all the way to the right. And then we mask it, right? So we only have that 1 bit in that position. The next time it gets shifted over almost all the way to the right, but a little bit less because the dex is increased. And then we mask it in the same exact position. Okay, that makes sense. You know, since we have this temp variable already, we might as well just use it. You know, I think maybe it'll just make our life easier anyways. So U16, it will just say 0x0000. So there's our temp variable. And then we need U16 temp. And we're going to bitwise OR it with, let's do OR, and then indent this. I don't know what's the sane way to indent this. Sure, like this. Sure, why not? So we're gonna bitwise OR it, right? OR it. OR to smash together. Alright, so we're gonna use a bitwise OR to smash it together. Smash in those new bits. We're going to take the first value and we're going to try to invert it. And so that means we want to check to see if the temp... So let's actually take the second value, right? Because this comparison here means we want to take the... We want to take the second value. We want to take the second value. We want to invert the bits in it and see if it equals the first value, right? So we see the second value here. We see it lit up here as well. So U16 temp is going to be the second value with the bits flipped around. Or reversed, I think. Is reversed? Yeah, I really need a better vocabulary for this stuff, right? So if we reverse the bits in here, put them into temp, then if this is equal to each other, it means we have a mirror image. So I think my bit shifting here is correct. I don't know if it is. I'm really good at screwing up bit shifting. I actually spent like 3 hours looking for a bug in some bit packing code, and it was because I did this. I did something like this, right? Where I put ands, and then for my ors, I put this. And C will let you do something like that. If you want to be stupid, C will let you do that. So be very careful when you, right? So yeah. So let's. Also, I've done things where I've put the shifting amount on the wrong side. So, like I swapped this and this. If you swap them and put them on the other side of this, right? It'll still run. But you won't get the values you want. But anyways, so hopefully if we keep on doing bit shifting enough, we won't do anything completely stupid like that. Alright, yeah, so I think we're ready to give that a roll and see if we can get the mirror images of each other thing going. So, also dex needs to be redeclared, right? Remember how we kind of commented out here? Well, now we can just put it back. We're going to do int32 for that. And now let's kind of put this over on this side. Boy, we have too much stuff open. Let's close this. We'll probably need that later, so maybe we'll keep that one open. Okay, let's rebuild this. Come on, up, up, up. There we go. Okay, cool. So that worked all right. So let's do /BPA U16.exe. And we want those test values where the bits are inverted, the bytes are inverted, sorry. The endianness has been flipped, but they're not mirror images, right? So these are not mirror images of each other, but we flip the endianness, right? So we're going to try with these values here. So 0x F0D0 and 0x, yeah, bit operations are something I'm still getting used to. I have a Sudoku solver mainly implemented with bit operations to practice. Oh yeah, that would make sense, because you could use a, an array of, well, a Sudoku is Sudoku 8 by 8 or is it 16 by 16, right? But you could use an array of, however many bit fields you need to get like a bit field, right? Or actually, 9 by 9 is more common. Okay, yeah. It's been a while since I did Sudoku or whatever. Yeah, I did one Sudoku puzzle in my life, and then I was like, screw this, and I wrote an algorithm to solve it, and I'm like, well, now I'm done with Sudoku for the Sudoku. Like, I should know this because I should know how to pronounce Japanese properly. But I still like going from pronouncing something in proper Japanese when you're saying the rest of the sentence in English seems very off to me. Like, it seems... Anyways. Sudoku. Anyways. So, let's do D0, F0. Okay, so those are inverted endianness. Let's give that a shot. Inverted endianness, but we don't have the other message. Okay, so now let's try something with, well, let's just make a note here. So, inverted endianness, right? And now let's try something with just inverted bits. So let's just go over here, and we need something where, really, we could just do something like this. So we could do 0x 00F, right? And then we could do the other thing, right? So we could put the F at the beginning, right? And now that would not be inverted endianness. It would actually be the bits being flipped, right? I'm going to have to double check my logic here. So this right here. Yeah, that would be correct. Because if we highlight this, right, the other one, this one does not also highlight, right? Now these are this could be considered flipping the endianness of these because, right? But this is not the same as this. So this one should detect the bits have been inverted, right? So inverted bits or flip bits or whatever. I forgot what you call it. So yeah, let's give that a shot. So let's do... We don't have to rebuild it, so we could just go up and do our 0x0000F and 0... capital. 0xF000. Okay, let's see. So I'm gonna guess that my logic for however I am doing my algorithm, I'm gonna guess my logic is just wrong. I've never done this before, so I'm gonna guess that I just don't know what the heck I'm doing here. Let's look at this again here. We shift it over, and we mask it, and then we merge it with this thing that's already 0. I mean, that seems to be what I would expect. What am I screwing up? What am I doing wrong here? Hold on. And it's a mask. Let's make sure, let's make sure that I'm bit shifting that. No, I'm pretty sure my bit shift is correct. Yeah, because I mean all these, because that's correct there. Yeah, I don't know what's up with that. Here's the temp variable, and it's the swap of this. Okay, so what we're gonna do is we're just gonna hackishly kind of debug this, and we just want to, let's just print f what we get out of here, because I'm curious of what is coming out of here, right? Oh wait, hold on. So this should be the swapped second. Okay, so I'm just gonna go over here and I'm just gonna print f hex 4 places. 4 places? Yeah, 4 places. Print hex 4 places. What? I swear I had this. I think you don't want shift U16 002. You think that? Well, if we don't shift it over, we have to move the bits around somehow. And we have to mask it. Huh. Only one with shift that way. Oh, okay. I mean, yeah, I mean, we could definitely, we could solve this problem by using left. There is definitely more than one way to solve this problem, though, right? Like, we could solve this by right shifting, but we could also solve it by left shifting as well, right? So we could, like, that is a thing. Oh, hold on. Hold on, I think you're onto something. Hold on. Wait, no. Huh. Wait. Okay, so... Okay, so here's what we're gonna do. We're gonna draw it out. So let's just draw this out, right? So I was gonna print f. You know what? Screw that. We're not gonna print f nothing. We're just gonna draw this out, right? So let's just think about it for a second, right? So let's say we have let's do let's do 6, let's do like, so let's take this, right? Let's take this, these, values, and we want to invert them, right? Yeah, like, yeah, I definitely think you could solve this by doing right shifts or left shifts. I think you could do it either way, definitely. But yeah, let's take this, and let's just look at this code and see where we're making a mistake here, right? So we're saying that we're going to take this, and okay, so if we take this, and okay, let's zoom in here for a second. Okay, so the first thing we're going to do is we're going to shift over by 15 minus 0, right? So we're going to take this, and we're going to shift over by, or actually, we're not going to shift over by, should we just do it with everything? No, let's do it by, let's kind of do the same formula, but let's do it half, right? So instead of shifting over by 16 minus 1, we're going to shift over by 8 minus 1, right? So we're going to shift over 7, right? So 1, actually no, hold on. So 1, 2, 3. Yeah, maybe I should just do 4 bits, right? Should I just do it with 4 bits? Yeah, sure, why don't... Yeah, let's do it with 4 bits, sure, why not? 1, 2... So, let's do... Oh, and I already did this wrong anyways, right? Because I need the 0 anyways. So, 1, 2, 3, and 4. Yeah, let's do it with 4 bits, sure. So let's do 4 bits. And so we're gonna shift over by 4 minus 1, right? Okay, 1, 0, 0, and okay. Yep, so I see, yep, so we mask it with that 1, and then we shift it over 3 to the left. The least significant bit is inverted. Okay, then we take the 1, 0, 1, and okay, so we have that there. And then we shift it over 2, second least significant bit inverted. Uh-huh. Alright, yeah, let's roll with it. Let's roll with it, alright. Okay. So we got your number here, and we're shifting this way. So what I was thinking, yeah, let's just do that. So we got this, and we start with the maximum amount, and then we keep on going down, and we keep on using a mask in the same exact position, right? Yeah, so you're thinking, is it really that simple? Is it just that simple as, I'm thinking that, let's roll with that. Yeah, okay, yeah, sure, let's roll with that, see what happens. Because, I mean, your little examples there make sense to me, so, I mean, okay. So let's do /bpau16.sh, and the inverted bit example we wanted was, alright, this thing here, I think, yeah? What did I screw up here? Expect exactly 2 user-applied arguments, and that's not to argue. What did I do wrong here? Hold on. Oh, hold on. That is the, I see what I did there. I am invoking the build script. Okay. Oh, what the? Ah, crap. Hold on. /. We have to, so it's only shift 1. We have to account the second bit is already 1 position to the left. Yeah. Hold on, I'm gonna think about that for a little bit more after I run this and just see what happens. Okay, yeah, so let's think about it. So it's only shift 1. So, yeah, I'm a little bit confused here. I actually need to draw this out again. But I will do kind of like the left shift value decrements by 2. Okay, so this left shift decrements by 2? Hold on. So 3, 2, 1, 0. I just have to draw this out. I think that's the only way I'm going to understand. Alright. So let's take this. And let's just take this code, right? Because we think that's going to work. And so it's actually easier the other way, but let's roll with this for a second. Let's move this over here, give it some space. So we're going to take this value, and we're shifting it over. We're using a 4-bit value, right? So we're going to take 4 minus 1, and that's 3, right? We're going to shift it over 3. There's a minus 0, so we're going to shift it over 3. Okay, so 1, 2, and 3, right? Okay. And then we can, for the 1 is going to be in the same, the 1 also gets shifted over, right? That 1. Hey, how's it going? So the first question is, have you been here before? Because then I'll give you a little tutorial of the demos and stuff. If you haven't been here before, then if you've been here before, we're just gonna keep on doing our thing. But if you have not been here before, I will give you a quick rundown of what I'm up to. Otherwise, we're just gonna keep on trying to solve this bit shifting, because apparently, simple math is very hard when it involves only 1 and zeros for some reason. So I actually could check my followers list and see if you're on there. That's what I could do. Let's see. Let's go look at my followers. Be like, only 45 of you. I should be able to keep track of everyone. Nope, you're definitely not on there. Yeah, so I mean, if you want a rundown of what's going on, I can give you one. But for now, you can just take a look at my demos page, and that will go over all these little technical demos that I'm kind of merging into a final engine design, and I'm working on a fractal auto-tiling engine. So that's the demo stuff. You can take a look at that. Right now, we're just trying to solve some bit shifting logic. We're trying to make a little function that takes 2 integers, and if the integers are not identical to each other, it just tells us what kind of pattern it finds in the bits, right? So if I do some bit packing wrong, then I can use this assert statement to kind of figure out what I may have done wrong. Okay, yeah, so we have this. We're going to shift it over like this, right? That's our first shift. And the binary for the 1, right? The binary for the 1 would have got shifted over by the same amount, right? So it would have been like, right, we have the binary 1 right here. You know, the 1 would be right here, right? And that 1 would get shifted over in the same position, right? Because everything is going to get shifted over the same amount. And then we mask this with that, right? So, because we only want to look at this bit right here, right? And so we have this and here, and this is our 1 that's getting shifted over. So that seems to make sense. So let's take this again, right? So I'm gonna hope that this actually shows me something. So now instead of shifting it over by 4 minus 1, we're gonna shift it over by less than 3. So we're gonna shift it over by 2, right? So we're gonna take this, shift it over by 1, and then we're gonna shift it over by 2, and then 1 and 2. Okay, so now we're right here. Oh, wait. Okay, so I think I'm seeing it. I think I'm seeing the problem. But let's just, I'm going to go through everything, right? I'm going to continue the pattern for a second, and then I'm going to, we shifted over 3, we shifted over 2, we shifted over 1. Okay, and we were saying, oh, we'll take the bit here, and we'll mask it, right? And then we're saying, oh, we'll take the bit at this star, and we'll mask it. Oh, we'll take the bit at this star. Oh, it's always the same bit. So I don't know what I'm doing. That's what I have discovered. But yeah, by this little diagram, I see where you're saying that there's only like 1 shift, because when we shift both of the things at the same time, so how do I da 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 da. I almost feel like we want to mask it first, and then we want to shift it. Would that work? If we... Okay, let's do something, I'm gonna try something else that's gonna be... Okay, so we know... So I'm gonna take this code and just reference... I'm just gonna paste it somewhere and be like, this is me not knowing what I'm doing. I'm gonna paste it somewhere for reference later and be like, this is wrong. So I'm thinking that the easiest way to think about this might be to shift the bit first into the least significant place and then do whatever I need to do with it, right? Like, I think that just for conceptualizing this, so here's what I'm thinking. I'm thinking you shift the bit over to where it needs to be, and then after, so does that make sense? Let me think about it. 0. Okay, you know what? I'm going to do this. So I'm going to look at the first bit, then the second bit, then the third bit. I'm going to look at that first bit, and we're always going to be looking at the least significant bit position. And we're going to mask it with a 1, right? So, I almost screwed myself over again. We're going to mask it with a 1. So we're always going to look at the least significant bit position. So we're going to look at, so we could say we're looking at the first bit, the second bit, the third bit, right? This seems to make sense, right? So, so when we shift over by 0 and we mask it, we're looking at the first bit. When we shift to the right 1, we're looking at the second bit, the third bit, etc., right? So we look at those individual bits in that order. And then the first bit, we just want to take it, this bit here, and we want to shift it over by the maximum amount, right? So we want to take this, and then we want to just shift it over. We want to shift it over by the inverse, right? So if dex is 0, we want to shift it over the maximum amount. So we want to shift it over by this minus dex, right? So I think that's correct. Least significant first. Do I mean little endian? Well, I mean, endianness has to do with bytes, not bits. But I mean, I guess I do mean that. Yeah, I mean, we are ignoring endianness here. Now we have another really naive kind of check here. Like, we are looking for endianness as well, and we're doing, it's only a 2-byte value. So to check for inverted endianness, this is my check for inverted endianness right here, right? And then, but I'm also checking for just inverted bits, because I'm just looking for different kinds of patterns between the two binary values, because I'm doing bit packing in my main library, and right now one of my unit tests is failing, and I'm thinking that it's because I'm doing something wrong with my bit packing. And if I could analyze the patterns in the bits between the two numbers, I might be able to figure out where I'm going wrong with my bit packing. But yeah, this one is not actually, we're not actually looking at endianness here in the sense of bytes. But we're just completely swapping the bits here. So what we're trying to do, we have a little diagram here. So this second example is what we want to look at. So we're saying that if we have this bit pattern here, and mind you that the example is only 8 bits, but these are 16-bit values we're using. But for brevity, I'm just using 8-bit values here, right? So if we have a bit value here, and this is the other bit value, then we have an inverted bits, right? This example kind of sucked because the endianness here was, because you could think of this as inverted endianness. Or actually, no, you can't really think of that because this is actually not a byte, right? This is a nibble. But regardless, this almost looks like inverted endianness when you take a glance at it. So this was kind of a bad example here. So we made another example in the diagram. But yeah, I think that maybe if we give this a shot, right? So we zero this out, and then we look at the first bit, right? Because we shift it all the way over to the right, and then we mask it with a 1, and then we just shove it over to the left, however over to the left it needs to be, right? So I think so if dex is 0, then this gets we look at the first bit, and then that first bit gets thrown all the way to the right, right? Oh, sorry, the left. So I'm very bad with left and right. So we look at the bit all the way to the right when dex is 0, and then ROL and ROR. It's more like ROL and ROR. I'm not familiar with those abbreviations. So ROL. See, that's the thing. I can definitely benefit from people who have better handle of terminology than I do. Because sometimes rotate... Oh, yeah. I think that, yeah. Oh, hold on, yeah. So, yeah, is that actually a rotation? Yeah. Roll left and roll right, yeah. Huh. Alright, I'm just gonna run this and see what happens. But yeah, am I rotating? And am I rotating but not inverting? Oh, well, we're gonna find out, aren't we? Okay, so let's run our build script. Okay, and /bpa u16.exe, and let's take something. All right, so that, I think I got that right, because it says, it says mirror images of each other, and I'm gonna read your comment right after this. So then, if we do something with endianness inversion, right? So if we do, well, if we do this, they're mirror images and endianness inversion, right? So if we do like this, yeah. So now it says mirror images of each other and inverted endianness, whereas this is just mirror images of each other. So we need one more thing where the endianness is inverted, but they're not mirror images, right? So we had a little example, so we could do like, let's do that last example. So if we do 0x f0d0 and then 0x d0f0, we got inverted endianness, but we got inverted endianness as the only message. Then we have mirror images of each other as the only message, and then we have both. So it looks like we got the code right for that. So 6502 ASM instructions. How do you say? I know mnemonics. Mnemonics, is that how you pronounce that? The M is silent. Mnemonics. So I don't know too much assembly. Like What is Creel has a really good channel for assembly, and I've watched some of his stuff. Assembly is a little bit too extreme for me. I've only written a very small amount of assembly, just enough to get the. So my project uses load library and get proc address, but I don't include windows.h. I just get the address of the peb file, and then I walk the data structure. But I only used one line of assembly to get the base address of the peb file, and from there I wrote like little helper functions that could let me kind of like navigate the data structure by just doing relative offsets from the base addresses of different pieces of data without having to use any structs. But what is Creel? Let me find him for a second. What is... Maybe his name isn't What is Creel. Hold on, I'm going to find him in my shortcuts really quick. Hold on. So let me go over here for a second. Because, I mean, if assembly is your kind of thing, then I think you're going to like this guy if you don't already know who he is. I'm just going to make a to-do here. Okay. So I think What is Creel is not what his name is. Creel YouTube. Let's try that. So Creel YouTube. So yeah, I got ya. Here, let me. So I think I found it, and I think you'll like this person. I think you will like this person. So let me just make sure. Yeah, you will like this person. Like if assembly is your kind of thing, then you'll like this person. They do a lot of assembly. They got a nice little assembly series. They actually redid it. Like they did this series once like 3 years ago, and then it wasn't very well produced. So they did it again, and it's pretty awesome. But yeah, I'd like to know a little bit more about that kind of stuff, but I'm hoping that, the lower level details will kind of come as I get, as my engine just progresses and I naturally kind of need to know the lower level details. I'm hoping that'll just be the way. Like, I'm trying not to get into the, I'm trying not to learn out of inferiority complex, if that makes sense. Where, like, I don't want to just, like, consume knowledge because I feel insecure that I don't know something. I want to make sure that I'm consuming knowledge on, like, a need-to-know basis. So as the engine that I'm working on develops, and I need to know more advanced things, then I just naturally kind of fall into it. Like, I was looking at the RFCs for the PNG specification, and I tried my hand at writing a PNG decoder, but I got pretty far, but man, some of the I've never done something like that before, and I just got I got stuck. So I ended up just being like, you know what? Instead of using JavaScript to make this engine, let's just use C, and then we don't have to worry about all these weird, stupid restrictions that JavaScript gives us. And we can just use load PNG, and then we don't even have to do all this crazy stuff. But yeah, so I use PNG as one of my favorite things because I like to just create binary data structures and then pack all of that data into pixels and then just shove it into a PNG file, and then boom, there's my file format. What's my file format? It's just a random PNG file. Right, so like all the things that I use for like data, I just pack it into a PNG file and say, oh, that's good, we're done. And the cool thing about that is if you have a very specific, if your data is organized in kind of a very visual way, then you can actually diagnose, your save file data or your memory. Sorry, I'm not explaining this very well. I can diagnose a problem with my system by doing a dump of my texture memory to a PNG file, and then I can look at that PNG file and I can visually see if everything looks all right. And I'm actually going to show you that right now. And so let's go to this diagram here. So this diagram, let's not explain it too much, but this diagram has to do with how I'm partitioning data. And this is a 512 by 512 chunk of pixels, right? So right here we get 512 right here. And then I'm kind of doing this very, I'm encoding a tree-like structure in a contiguous chunk of memory, right? So, so there are these different tile sizes in my tile map, and each tile size is twice as big as the other tile size. Okay, so I won't get too much into explaining that, but just keep in mind at this visual here, because now I'm going to open up the project folder and show you a picture. So let's go into our project folder. Okay, so in my mods folder, I have a thing called paint5d.png. Let's open that up. Okay, so you might notice that this picture here looks awfully similar to that schematic diagram. Oh, what the, Okay, so, you know, Windows high contrast setting, sometimes, man. So yeah, you see this structure here in this PNG file, and it looks pretty much like this, right? And that is obvious. That's not a coincidence, right? So what I did here was this is a debug pattern, and this represents an art asset where each subtile. So this is an art asset composed of 4 tiles. So this is the data for the first tile, the data for the second tile, the data for the third tile, and the data for the fourth tile. And they are corner tiles of an auto tile set. So I have auto tile sets that are composed of 4 subtiles total. Okay, so let's go into Paint, MS Paint for a second, or Paint.net for a second to show you what this data would render. So I mean, it's going to be kind of hackish here, but let's just try to get an idea of what's going on here. So let's get a little brush here. So what I'm doing is, for these large squares right here, what those large squares mean is it means I'm drawing something like this, and I'm drawing it with I'm drawing it with 3 different colors on 3 different layers, right? So if you look at the diagram here, so you see these 3 squares, that's because there's tile data for 3 different layers, right? So each one of these squares is a different layer, and the biggest squares here are the pixels that are encoding the smallest tiles, right? Because the smaller the tile is, the more tiles you need to cover the entire canvas. So these first 3 allocations with the color here is going to render something like this. Now on these next smallest allocations are going to render something where each tile is twice as big, right? So it's going to render something like where there's a big tile here, a big tile here, a big tile here, a big tile here, and all the way around the border with some big tiles, right? And then when we look at this, then we have another allocation that's even smaller, and those tiles are twice as big as the previous tiles. So it's going to render something like this, where instead of 4x4, instead of 2x2, we got like 4x4 all the way around the edge, right, like this. Now I can actually show you something that is actually already implementing this. I have a little proof of concept, so let me show you that really quick. So let's go to, I have a little thing, I think the address is called for Andrew URL. So let's go over there and show you, so let's say FA01 URL. Let's try this one, see if that's what we want. Yeah, this is what we want. Okay, so that data is actually, so this is a rendition of a data structure similar to this, where we're packing a whole bunch of tile values into this kind of MIP map kind of structure here. And this is what the end rendition will look like. Now, it's a little bit cluttered to where you can kind of see a hint that there's these bigger tiles, but there's so many small tiles that it really distracts against everything that's there. So we can say only show tiles of a certain size, and it really sucks that it didn't make a thing to just clear the screen. But let's just go, we're only going to show everything on the active layer and show same tile sizes. Oh boy, that's more than I was expecting. Okay, let's say show active layer, tile size 1. No, that's not exactly what I was expecting. It's been a while since I've used this. Is the toggle? Oh, isolate active tiles. That's what I want to use. Okay, so right here, right, we have this tile size right here, and we can put down these tile sizes. We can set different tile values, right? So different tile values are just showing up as different colors, right? And then, you know, your 0 tile is just like an eraser, right? So if you want to erase some tiles. And then if we want to go a size up, so the tile size is 1. If we go to tile size 2, all the tiles get twice as big, right? So twice as big. If we go up to tile size 3, sorry, oh, I have to click this. Okay, if we go up to tile size 3, the tile sizes are twice as big again. If we go up to tile size 4, the tile sizes are even bigger. All the way to 5, even bigger, right? To 6, even bigger, right? To 7, even bigger than that. And then once you get to 8, you get one gigantic tile that is the entire size of the tile map. And so there's really not much to see there. It's just it's because it's just so big, right? You can't really see much. So now if we turn on show all, right, it's very cluttered, right? Now we could try to kind of like go look at the tile size 0, right, the smallest tiles, and we could kind of uncover some of the other tiles by kind of like erasing here. Unfortunately, I did not make an eraser to mass erase everything, because I think that would make this demo a little bit better. Yeah, no problem. I'll see you around. Enjoy your cigarette. But yeah, you see how we're making this. We have this engine where we're going to encode all these different tile sizes, and they're all going to neatly stack into each other, right? And that's not everything I'm doing. That's just one aspect of the engine I'm working on, right? This is one of the prototypes. So if we look at my my main demos page, so let's go there for a second. So this is the old game I made. It's like Bomberman, except the bombs are directional. So there's a horizontal bomb, a vertical bomb, a four-way bomb, and then a larger four-way bomb that is an instant kill. So most of the bombs in the game are proximity mines, so you can actually touch them and they won't kill you, but once you touch them, they'll start to blink, and then after a certain delay, they'll go off and they'll explode, right? And then the geometry of the game obviously can be destroyed, right? And some geometry has physics attributes to it. So another thing besides having layers is that we don't just want to do old school graphics. We want some type of auto tiling where we can take like really fancy shader code and just make it auto tile, right? So this is just a proof of concept to make sure that we can auto tile with something besides sprite graphics, right? So this is using Wang tiles. So when you're talking about the algorithm for auto tiling, there's many different auto tiling algorithms. I use the algorithm called Wang tiles, which means that every single auto tile set uses 16 subtiles, and the algorithm uses a 4-bit bit mask, and the bit mask are bit flags saying which tiles is the tile touching, which neighbor tiles are being touched. So when we have this tile in the middle, there's 4 bits here, 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 and here, right? Am I touching something to the left? Am I touching something above, to the bottom, to the left, or to the right, right? And so when we're looking at a certain tile, we observe its neighbors, and we compute a bit mask, right? And that bit mask, because it's 4 bits, will resolve to the numbers 0 to 15, which means that we can use a lookup table to get one of 16 different unique tiles to render, right? So the tile in the middle is the tile 15, right? Because it has a neighbor on all sides, so therefore all the bits are set to 1, and therefore it's tile number 15 gets looked up, right? Now, because this is not rendered with sprites, it's not really looking up a subtile, but it's the same basic algorithm. It's just being applied to shader code rather than sprite graphics. And so the cool thing is if we can get something like this with like fancy graphics like this, then we can zoom in and not lose any resolution, right? So we could zoom in and make every single tile a lot larger, and we still get nice, awesome detail, right? So the idea is to make an engine where we have kind of a more procedural way to make our tiles, but then also have a lot of layering as well. So here's another engine, a little engine I worked on. And so this is a sprite-based tile map with multiple layers, and what you're seeing here is this is rendered as foggy morning, this is sunset, and this is starry night, right? So it's the exact same tile map with just different rendering settings. So if we can take this kind of tech, combine it with this kind of tech, put it in a game that functions like this, we can get some really cool stuff, but it's going to be quite a while. And also here's the lighting engine I worked on for the old game. So, and then some other proof of concepts. So anyways, but that, I put that in the URL in the chat, so I mean you can look at that if you want to look at that. So I guess where are we? We were working on a little utility to help us with unit tests, and it looks like we got... so we checked for inverted endianness, and then we also checked for inverted or flipped bits, or I think you said rotated bits. So let's, I don't think I need this little diagram here. That was just me trying to figure out what the heck I was doing wrong, and now I see what I was doing wrong. So swapped bits check versus endianness here, right? So let's just do... So this was mirror... Okay. So what was next? So what other patterns do I want to check for? There is another pattern I want to check for. So right now, I am doing some logic where all of my tile values are 2-bit values. And so I'm packing 2-bit values into a 16-bit integer. And I am concerned that when I'm packing these values, that in some of my test code, I'm accidentally packing everything in the wrong order, right? And so I need another check where I can kind of check for that as well. So instead of looking for a mirror image of the bits, I want to look for a mirror image of clusters of 2 bits, because I'm thinking that I'm making that kind of mistake. So I'm going to try to write some code for that now in this little utility, right? So this little utility I'm writing is kind of a break. It's like, you know, I need to take a break from this code. Let's just write a little utility because I think it could help us in the future. So we've done our analysis of inputs, right? So if the inputs, so we have 2 U16s here, number 1 and number 2, right here. So number 1 and number 2. And if they are not equal to each other, we're going to show this error message. And additionally, if they're not equal to each other, we're going to open up this analysis section, right? So if they're not equal to each other, we're going to go into this section, and we're going to try different analysis on those 2 values and see what kind of patterns or relationships we can find between those 2 values. So we've already done this, and that seems to be working. We did this. So let's try to... let's put it in here. Let's just make another section and say, pairs of 2 packed in wrong order. Okay. Pairs of 2 bits packed in wrong order, right? And let's just figure out the logic for that, I guess. So what we're saying here is that if we have something like 0111, actually let's do it like this. And then, so if we have something like this, right, then we found that the bits were just packed in the wrong order, right? So if this is our U16 number 1, and obviously this isn't 16 bits, right? But we just want something as a little schematic, a little example. So, I don't know, maybe that's confusing, I don't know. We might want to make a note, 8-bit values, for... Hey! Welcome back. So, the next thing we're gonna do, so, since that code works, the next thing we want to do... I solved the motherfucker. Are you talking about the bit shifting stuff from earlier? Or are you talking about something else? Did you solve? Yeah, we already got that solved. Yeah, right. That already worked, right? Because we ran it, and it worked, right? So this algorithm right here, this works. This right here, this works. Yeah, this will flip it around. This right here will I already tested it. It flips it around. Oh, actually, if you were gone, like, yeah, I lose track of stuff. But here, let's give that a run again, just in case you missed that. Because I actually did all the test cases, but in case you missed that, let's just give it another run, right? So bpau16.exe. Let's. Okay, cool. Okay, got ya. But yeah, so we want something where only the, and I have my examples down here, so inverted endianness and mirror images of each other, right? So we just want to do our 0x, 000f, and then our 0x and f, and then 1, 2, 3, like that, right? And yeah, so you see mirror images of each other. So anyways, and then we had another... I thought I had an example where they are both mirror images, and, oh yeah, well, that's easy. That's, so our example where they're both mirror images and the endianness is flipped, right, would be just 0x, right? So now we get both messages, right? And let me just take this example, because I kind of forgot about that. So let me, I'm going to take a look at that really quick. After I type this out. So this right here, I'm just going to write some zeros. And then put some ones here. And I'll take a look at your REPL. Or is it called REPL? I think that's what it's called. I might not be pronouncing that right. So this one is both of them, right? So this case here is both of them. I just want to keep a nice little key here for reference, so I don't have to. So when I'm plugging in values into the console, I don't have to think about it, right? I can just be like, bam, try it out. Okay, yeah, let me try that. Open a new tab. Come on, you're gonna make me sign him? Okay, hold on. I'm gonna copy this and see if... Paste, yeah, Pastebin. I like Pastebin. Yeah, go with Pastebin. Yeah. Yeah. You put that in Pastebin, I'll take a look at it. So what's next? So anyways, the next thing I want to do is, when we were looking at my test code oh so long ago, like 6 hours ago, or yeah, 6 hours ago, yeah, probably 6 hours ago, I was bit packing everything in pairs of 2 bits. So we want to be able to detect when when we're bit packing in the wrong order, right? We're like taking these clusters of 2 bits and we're just shuffling them in there in the wrong order, right? So once again, our example here is only going to be using 8 bits rather than 16 just for brevity. Right, because, I mean, I'm pointing to this and saying U16, but then we only have, 8 bits here. That could be kind of confusing. So how are we going to do that? I mean, it probably should be some type of derivative of this, I would hope. So I'm actually going to take a, I'm going to take a guess. I'm going to take a guess and hope that I can take this code and, bit packed pairs of 2 bits in raw. Pairs of 2 bits in bit pairs in wrong order. That sounds good. Okay. So I'm thinking that we can take this and we might be able to modify it to work for clusters of 2. So I'm thinking all we got to do is if we take if we do like 16 divided by 2. So 16 divided by 2 minus 1, obviously batshit crazy, right? But that's the way I'm going to do it. And we're going to shift over by dex times 2, right? Right, because we're looking at clusters of 2 bits together, so every time we do a shift for this, we want to do 2. And then instead of a mask of 1, we want to use a mask of 3, right? Because we want a binary mask that is 2 bits this time. And then instead of this being 16 minus 1, we're going to put our 16 divided by 2 minus 1, I believe. And then instead of minusing dex, right, we got a dex times 2, right? So we're going to do dex times 2. And if I'm not completely insane, I think that should actually work. So let's think about that. Or maybe let's not think about it and just give it a run. Right? But that intuitively seems to make sense to me. So at first we're not going to shift anything over, right? Dex is going to be 0, and we're going to mask out the 2 bits all the way to the right. And then we're going to shift them over the maximum amount, right? So we're going to take 16 divided by 2 gives us an 8. Minus 1 gives us a 7. Ooh, hold on. Is that right? That's not be right. That might not be right. Oh, hold on. No, that's not right. Never mind. This does not need to be. This does not need to be. Because this is the maximum shift amount, right? And at first, we're going to shift everything over. Oh, hold on. But we are. Hold on. Because we're shifting over two bits, we can't shift over 15. We actually have to shift over. We actually have to minus 1, because we can't. We don't have enough room to shift over all the way that much, right? Maybe I'm not making sense here. Okay, maybe I don't need this multiplication here. Now this multiplication here makes sense, right? Because we've already looked at 2 bits, so we have to shift over and multiply by 2, right? So this dex here makes sense, right? Because 16 divided by 2, that gives us 8, that gives us 7. Okay, so that makes sense. Dex makes sense right here. So this is definitely correct. This I have questions about. The first time we shift, we want to shift over by... we don't want to shift over by 15, we want to shift over by 14. Now, do we want to do that... Okay, oh, your pastebin is there. Okay, I'm going to take a look at that. How do we know... how to... The range is different, right? There's less room to move. There's only... Actually, no. Hold on. I changed my mind. I changed my mind again. Hold on. I'm going to look at your pastebin after this. So, so I think we need to take this. So it's shifting over by the maximum amount in pairs of 2. And dex is in terms of this half range here as well. So we don't need dex times 2. We need this here. And then after we've done that, after we've done this inversion, right, where we're going through this half range, right, where we're not looking for shifting 0 to 15, we're looking for shifting 0 to 7. After we've inverted this, then we apply the multiplication by 2. So then we apply the multiplication by 2. So that's where I'm going wrong here. So let me let's just, I don't know, just because I don't know, because I'm OCD, so I'm just gonna do that. Way too many parentheses. Yeah, I think we went overboard on the parentheses here, but I think that might be correct. But before we figure out if that's correct or not, let's take a look at that pastebin. So, open a new tab. Okay. Okay, so, okay. Limits.h. Main, U16 type V. Okay, original value. Okay. Inverted value. Okay. V and R. Okay. So V for original value, R for inverted value, I guess. That's just what I'm going to use. Okay, so n bits, size of... Oh, okay, so you're making a... are you making a generic solution here? Because you're using size of... well, that would give you the number of... so here's the size in bytes, right? Size in bytes times char bit. Where's char bit coming from? Just to be pedantic, yeah, okay. So times char bit. Okay, so the number of bits in a byte, right? Okay, I got ya. So number of bits right here. Okay, I got it. Makes sense. And I like how you did this here, because yeah, I would look at this, I'd be like, where is this coming from? And I would have no clue. I'd end up on Stack Overflow. It would not be a good day for me. Okay, so we're going to go through every single bit using the sane method. Different bit count than 8. Yeah. I could, yeah, some weird architectures, yeah. I get ya. And I totally get that. That's why I kind of like, when I write code, sometimes I write it for very specific cases. Hence why, like, hence why this code is called, you know, well, I guess it's kind of a weird name, but see the U16. The U16 in the name is because, you know, I'm writing the code specifically for 16 bits. But okay, so yeah, we're gonna go through every single bit, and we're gonna shift over the original value by I, and then we're gonna mask it. Okay, yeah, so that's exactly what I was doing in my code, right? So we're going to shift it all the way to the least significant position, and then we're going to isolate it with a mask. Gets first, second, third, etc. least significant bit. Okay, got it. Okay, and then we're going to do a or equal with R, and R is the like flipped version, right? Inverted value. Yep. Okay. And we're going to take bit, and we're going to shift it all the way over. We're going to take the number of bits. We're going to minus 1, right? Because remember how I had like the 16 minus 1? You got the same thing here with the 16 minus 1, and then you have the minus I. So you're less parenthesis happy than I am. So that would be this thing right here. So I have this thing here. I mixed inverted and reversed. That's okay because I don't know my vocabulary, so that's fine. Because I don't know what I'm. Yeah, that's how you don't count. Yeah, that's okay because you know what? I honestly don't know the difference between inverted and reversed. I mean, I know that like you know, flipping the bits, like I guess, yeah, like I get the terminology confused all the time. So yeah, don't even worry about it because hell, I don't know. But yeah, so you know here, right? Not using so many parentheses as I am because parentheses really didn't matter where I put them. I just overused parentheses. Yeah, so yeah, I totally get what's going on here. And all right, and so %x, that's for hexadecimal, right? Or am I wrong there? Hexadecimal, right? Because I use 0x, right, when I'm printing out hexadecimal, which I don't remember what the 0 was for. But, okay, yeah, cool. And so, we can just, I'm just gonna call it bit mirroring. Yeah, I'm just gonna call it bit mirroring, because I don't know what, because I don't, so I'll put this over here. And we can do bit mirroring over here. Bit swapping. So since I don't know proper terminology, we'll just call it you know, swapping. And then I'll just say, you know, we'll just pick and RBS. I'm going to assume that your name is some type of analogy. I keep on looking at it and thinking it's like some type of word that stands for some type of database, and I don't know why I think that. Like relational something or other something system. I'm like, that's kind of what I look at. Like, you know how there's like a relational database, right? Because SQL is a relational database. So I don't, but anyways, RBS swapping, or and what's the library kind of name thing that I'm doing here? So this thing, I'm going to take this full file path to clipboard, and then we'll take this, And this is BPA U16 swapping, right? So BPA U16 swapping. And we'll edit the file. Right, so now we have a way to get to this, right? So in a few years, if I'm like, hey, I remember this one stream I did where we did some bit swapping, maybe I'll get to it. Except that I don't have anything that says bit swapping, so bit swapping. So then we can take this and we can kind of put it in here. And then we'll just call this one, we'll put a date. We'll say 2021-01-22. We'll call this A. And then over here, we'll call this B, right? So that way we can know that they're these, even though they look almost identical, they're actually different shortcuts, right? And what next? That one time you did some bit swapping on Twitch. And I don't expect to ever remember this, but sometimes I find it amusing. Sometimes I find it amusing to make like a really long shortcut and see if I can ever get it in the future. And sometimes I actually do. Chat did something, huh? Chat did something. What did chat do? Because I don't see anything in chat. Let's see. Sound's still working. So, that one movie with wizard mice. Nope, I didn't quite get that. I'm gonna take that, though. Control-Z. The secret of him. Circa 1980, whatever. Okay. Anyways, so it's a meme. Generally, people in chat can't help the streamer. The rare cases someone can't help in anything, people spam that as a joke. Oh, alright, got ya. Chat did. Yeah, there's a lot of, like, Twitch culture that I don't know. The only thing I really know about Twitch culture is that, and that gets political, but that, like, Twitch likes to, like, ban people's faces that are used as, like, Twitch icons once they finally fall from grace and say something slightly out of line politically. Or if you say something ambiguous, it sounds like you're in trouble. I don't know. At least from what I saw about, what was it, PogChamp or whatever? Like, I saw the comment and I'm like, oh, that's kind of ambiguous. Like, I really can't tell where this person stands politically by what they said, but now they're in trouble. You know, it's like if you state a fact. It's like if you state a fact, but, like, you say it at the wrong moment. Yeah, it's like if you state a fact where I could say, like, you know, I could state a fact, but because I stated it during the wrong political climate, I'm in trouble, right? Like, I could state something 100% factual, and I could just get in trouble. But, yeah, anyways, yeah, ridiculous. And that's kind of why I want to just stay away from politics and stick to programming. And it's like, I honestly, like, I don't really... I know, like, our society is in a moral panic. I don't really care too much, honestly. I mean, look, as long as you're not gonna kill me, You know, I'm okay if you're a serial killer. Just as long as you're not gonna kill me personally or anyone I know, we can be okay. We can talk about code. Um, that's how I operate. And maybe I'm just weird because my brother's kind of weird like that too. Like he wrote like random serial killers in prison, um, just for fun, I guess. Um, but yeah, I mean, like I don't know. I'm very compartmentalized, right? And I mean, maybe a lot of programmers are compartmentalized, right? Um, like, like when we talk about political correctness and diversity and all that weird stuff, well, there's this thing called in-group bias, right? And if we're doing programming, then the in-group bias is, do you like programming, right? That's my in-group bias. And if you like programming, then that's good enough for me. But I've already said too much, and I will be canceled, you know, in 5 years when my engine actually gets popular. Somebody digs into this long stream, finds that exact thing I said at, you know, 6 hours and 41 minutes, and then I'm just screwed, right? Anyways. Should be like, those artists that just, don't say anything, and they're all, like, mysterious. But maybe they just don't say anything. So you are done so. And it's not only on Twitch, pal. Yeah, that's right. It's everywhere. It's everywhere. It's all over. The longer you spend on Facebook, the probability of committing social suicide goes up. I do this really bad thing on Facebook where I like everything. You know how, like, Facebook, you know, the whole echo chamber with Facebook where you're only fed things you like, right? So I will like everything, even if I disagree with it, which means I see, in my feed, I see things from the extreme left and the extreme right. And I have certain people who actually keep track of what I'm liking. And I have been threatened to be like, what do you call it? I don't know, publicly shamed or something like that. Something like that. And I don't want to get too political, but it's only one side of the political spectrum that has been coming after me for liking the wrong thing on Facebook, right? Because I like everything, especially that's political on Facebook, which is probably a horrible thing to do. And I like things that I disagree with. So I am getting, like, memes from everywhere. And my conclusion of political memes is they're all complete shit. Yeah, see, I actually like, I actually like AOC. But yeah, I mean, so when I look at a politician and I think, well, how am I going to determine if I like a politician? And people use different metrics, right? Like, some people will look at a politician and be like, well, how smart or competent they are. I usually judge people by how genuine and how lacking in maliciousness they are. So, like, my grandfather would be like, I hate that Bernie Sanders, he's an idiot. But I'm like, you know what? I'd rather have a well-meaning idiot than someone malicious who's smart. But yeah, there's definitely, like, a lot of shady stuff with, like, like, conservative people definitely get the shaft with right, because tech companies lean left, so conservatives tend to get, like, censored and have bad shit happen to them. And, like, I've been keeping up with it. Like, I'm like left of center politically. God, now I'm already talking politics. I'm fucked. Just give up now. But yeah, like, yeah. Yeah, like, it's probably also controversial to say, like, as far as I'm concerned, there's no correlation between political alignment and intelligence. Like, a lot of people like to default to that and be like, oh, those people are just stupid or whatever. But, I've never seen any correlation between that. In fact, I don't even see much of I haven't even seen, in my personal life, I haven't even seen much, I'm an atheist, but I haven't really seen any correlation between religious affiliation and intelligence from what I've seen. Right, a lot of stuff is compartmentalized, right, where Like, the way you emotionally feel about things doesn't really affect the way you logically process, right? Like the way you emotionally feel about something does not affect how good you are at a certain, like, math problem. I don't know. But yeah, so that's why, yeah, so I take shots from all sides politically. But I don't know, I guess I'm a libertarian. But, like, I'm a left-leaning libertarian. Anyways, well, I'm screwed now. Anyways, this is the stuff I'm supposed to say in private chat, right? Like, is that how that's supposed to go? Or, on some encrypted chat? Yeah, like, I thought Trump was pretty a mean person. Like, I definitely think that there are problems with people, like, I think we went over this with, like, outsourcing all your stuff to China. Like, outsourcing production. If you outsource all your production capacity to other countries, then you're not gonna think about trying to go to war with yeah, a lot of times. Yeah, so I'm gonna say this one thing because nobody's listening to me on this thing. So you know the, like, inject bleach thing? Like, oh, what if there's a way to sterilize yourself from the inside out, right? And then people are like, oh my god, he said to inject bleach. But it's like, no, that's actually a good idea. Like, okay, so soap. How does soap work, right? So if you there's this substance, right? And, if certain cells touch this substance, they just explode, right? So would you want to touch a substance that when cells touch it, they explode? Well, it depends on what the substance is. Is that substance acid or is it soap, right? Because soap will explode cells and so will acid, but the difference between acid and soap is that soap only explodes the cell walls of bacteria, but it will leave a mammal cell unaffected, right? So you could potentially have the same thing that could be injected, right? So you can't inject soap. That does not work. But there definitely could be a substance that you could inject into your bloodstream that would leave your mammal cells intact, right? So it wouldn't try to do apoptosis on your red blood cells, but when it comes into contact with the protein manifolds of a virus, it could cause it to burst, right? Like that's not complete gibberish, right? Now there is a saying, what is it called? The difference between wit and stupidity is like your social class, right? So like if like a respected scientist says, oh, what if you could sanitize yourself from the inside out, people will like be like, oh my god, what a genius. But then if somebody who has a reputation for being stupid says the exact same thing, then they're like, oh my god, you're an idiot, right? And like when I was a kid, I did special ed and advanced classes at the same time, and I experienced shit like that a lot. And I'll say, like, if you're super smart or you're stupid, either way, you're gonna experience problems, right? Because anytime you deviate from the norm, you're gonna end up with problems, right? And you know, that's kind of like saying a fact that could also get you in trouble, but that's just the reality. If you deviate from the norm, you incur trouble, right? Even with something as trivial as being left-handed versus right-handed, right? Like the probability that you're going to get injured if you're left-handed is higher than if you're right-handed, right? Because any deviation from the norm just leads to trouble. I'm not saying that being a deviant is bad. I mean, I think deviation is fine, but there's still reality, right? But yeah, like, but yeah, I definitely, like, I looked up everything that kind of happened, and there are a lot of things that definitely did happen, that that, like, there's plenty of reasons to not like him that don't need to be made up. So it's like, I don't understand why they lied about so many things when there's so many other reasons you could not like him for that, like, actually happened, right? So me, I don't think that, yeah, I don't think that, what do you call it? Yeah, I mean, people talk about, like, having an open mind and all that shit, and then, go on to, like, shit on people who have, like, the opposite political opinion, right? So, it's like, I don't know. I mean, so the thing is, like, you have to think about, like, what battles are worth winning and whatnot, and I think that winning a battle in politics, like, trying to win a political argument doesn't really have any utility. I think the utility comes in, like, so where I want to focus my energy is, like, I want to prove that my insane idea for this rendering engine is correct, right? And so I want to forget about winning some argument about politics or whatever, because I don't profit from that, right? In fact, any argument with politics is probably going to be to your detriment. You know, regardless of how well you argue, any kind of argument that gets political is going to be to your detriment. And like, and also, as somebody who's a capitalist, I am a capitalist, I do believe in worker-owned co-ops, and I think that we can definitely get some, like, socialism mixed in with capitalism and have, like, a nice compromise there, and I think a worker-owned co-op is a good way to do that. But as a pro-capitalist person, I'm worried about, well, what's profitable for me? And what's... talking politics too much, right? Oh yeah, totally. So talking politics eliminates half of my customer base, right? If I side with blue, then I eliminate my red customer base. If I side with red, then I eliminate my blue customer base, right? So if I as a corporation take a political stance, I'm eliminating half of my customer base. And you know, I don't see a need to do that. And then when we get to, like, canceling people, we gotta think, like, okay, you can think someone's bad, but... okay. So, if you're, like, prejudiced, or you're hateful, or whatever, let's say you're homophobic and you're racist. Well, is that worthy of the death penalty, right? Like, okay, you're a bad person because you're homophobic and racist, but is that worthy of the death penalty? And I'm gonna say no. I'm gonna say that if my XYZ friends don't like something, I must be wrong, and if I don't dislike that same thing. Yeah, so I actually have a good lecture on that. So I'm gonna find that for you. The purpose of opinions. So I don't know, when you cancel somebody, like when you cancel somebody and you take somebody's ability to feed themselves, that's kind of like an attempted death sentence, I think. And so it's like, I don't know, you gotta take, trying to make someone lose their job, I think people need to take that a little bit more seriously than they do. I don't know. So, I'm gonna find something for you on the purpose of opinions. Purpose of opinions. Really? No way. Okay, that doesn't look right. Hold on. So I'm gonna put this on the other screen really quick. That does not look like the thing that it should be. Oh, maybe it is.
Social learning therefore leads groups to synchronize their opinions. And the opinions become get another role. They become an important part of signaling which group you belong to. So opinions start to signal group loyalty in societies. And people in such a world, they should optimize not for getting the best possible opinion in terms of truth. They should optimize for having the best possible opinion with respect to agreement with their peers. If you have the same opinion as your peers, you can signal them you're part of the in-group. They're going to like you. If you don't do this, chances are they're not going to like you. There's rarely any benefit in life to be in disagreement with your boss, right?
Yeah. So that's a pretty good talk there. So I was just surprised that was the actual shortcut for that. So I think it looks like I put them in the order of probably what I thought was the most interesting. 2021. So that's Joska Bach. And he's a pretty smart person. The purpose of opinions. I'm gonna make here an entry here. Just does that give me? So I'm just gonna make this so you would think that if I named all these shortcuts with that prefix, right, if I use this prefix for everything, you think that typing that prefix would, you know, give me this prompt, but I guess it doesn't. So I'm gonna make that give me a prompt. And OFOSys. I have no clue what that abbreviation stands for, but actually I could probably find what that stands for. A B. Let's go find that. Let's see if we can find what the hell that abbreviation stood for. There's probably a clue somewhere in here. Goal of opinions, reason for opinion, purpose of opinions, the reason for opinions, the purpose of opinions, OFOSys, sync, OFOSys, I have no clue why I use that abbreviation. Opinion of your environment? Opinion of... no. I have no clue what that abbreviation was for. No clue. That's why I need to, like, no fucking clue. No, should have documented this. Okay. And while I'm here, I might as well figure this out. So hex 4 places. I should have a printf for this. Printf hex 4. Printf hexadecimal 4 places. Printf hexadecimal to 4 places. Yeah, like that's gonna work. Okay. So I know that it's like a 0x, so I'm just going to look for it in my shortcuts and just paste it down here. So it should be like a 0x and something or other. Am I searching? Oh, I'm searching backwards. Let me try that again. Let me go all the way to the top. Find next. Okay, not what I want. Not what I want. Not what I... this is not going to be as nice as I... let me try something else. How about 4 places? 4 place. How about 4 place? Yeah, we got that, but here we go. It's right here. I'm gonna steal this. I'm gonna steal this and put it up here for a reference for the future. Okay. So now, I think we got kind of carried away, and we were like, got political, and then something. I looked at your code. But I wanted to make sure that this new kind of algorithm here worked, right? Not this one. This one right here. Like, this is a guess that this will work. So this is a bit mask of 2 bits. This is shifting... We're going to shift over to the right in pairs of 2. Right? So it's the same algorithm as before. And then we're going to shift everything back over to the left in pairs of 2 as well. So I have no clue if this is going to work. And if this works, the temporary variable... did we assign the temporary variable to anything? No, we're just kind of like doing this with this and then comparing this. And bit pairs in inverted order. So we're going to try to find something where was trying to solve it too. Got ya. Yeah, so I'm going to take a look at this and see if this works, because we haven't ran it yet. But the first thing we're going to need is we're going to need to come up with some type of binary value that we have the bit pairs have kind of been inverted. So let's try like something like this, right? Like I think if we do this though, everything would be flipped. So let's do okay, so let's say this is gonna be a little bit harder. So we're gonna have to type everything out here and say, okay, so C59B, and that's gonna be 1100011000111011. Okay, so we take this. And then we need to do something else over here. We want to flip this around. And we want to pack all of these in the inverted order. So I'm just gonna do this in the naivest way possible. I'm gonna just take these, and I'm gonna just say, okay, we're gonna just take this and paste it here. I'm gonna take these 2, and I'm gonna paste it here. I just want to make absolutely sure that I don't do this wrong, so I'm gonna do it kind of... What the hell? Okay, so I've already screwed up. Hold on. Okay, so let's take this. Can we copy this? Copy it. And then paste it. And then space it out. Space it out. Space it out. Okay, so now let's take this. C59B. C59B, right? So let's take this, copy this as well. Might as well copy this and paste this to make absolutely sure. Okay, cool. So let's take this, and we're going to go from here, and we're just going to feed it in the opposite order, right? So we're going to say, if we take these 2-bit values and we pack them into the 16-bit value in the wrong order, right? Like we inverted our formula, right? And it's something common that I would make a mistake with, where I just iterated through the data in the wrong direction. I want to be able to detect that, so... We're gonna do that. Okay, so now we got our 2 values. I don't know what this is, though. So can I copy this, or is it gonna say that? Is it just gonna complain because I have spaces? Let's see. Let's go over here. Let's clear it. Let's go over to the bit packing. And let's try to paste. Control V, maybe. Oh, I guess it let me do that. Okay, cool. And so that's E653. So copy that. And paste that there. And then I'm also going to copy from here and paste it down here. And just make absolutely sure that that matches, right? So I'm going to put it over here. Make absolutely sure we have values that are going to do what we need them to do. Okay, yeah. So that looks good to me. So we got these two test values. We're going to try these. And the error message we're expecting for, I think I got it only tested with, okay, oh, so that would work as well. Let me plug that in for a second. Can I just hit delete? No. Okay, so, clear. Okay, so, I'm gonna take your example there. So you got 00AB, and then you got EA00. Okay, and if I take that and I paste that, and look at the bits. Okay, so we got this, and then we got bam, 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 and then boom, 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 boom. And then this one, Control V, and this one right here, dot, 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 and then boom, 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 and then, okay, so let's look at that. Hold on, did I read that wrong? A, B, and EA. A, B, and EA, oh wait, hold on, I'm just not thinking correctly. Okay, so this is these two bits here. And then a 1 and a 0, and this is also a 1 and a 0. And then here's a 1 and a 0, here's a 1 and a 0. And here's a 1 and a 0, and here's a 1 and a 0. Okay, so yeah, we can check with both of these, right? We can give both of these a shot, right? 0x. And let me go figure out what message I said for that, right? So pairs of two packed in the wrong order, right? So so this right here, these two examples are going to make this happen. And let's give that a roll, see what happens, right? So let me clear this, let me rebuild. Okay. And let's enter, exit, clear. Okay, so /BPA U16 .exe, and we're gonna supply. Let's try with your example first. So we got 0x00AB and 0xEA00. Let's give that a shot. See what happens. Bit pairs in inverted order. So, okay, that, I think my code worked for that. That example also works. I'll give that a shot after I try my example. And so let's try 0xC59B and 0xE6, E653. Okay, so C59B, E653, give that a shot. And we see bit pairs in inverted order, and now I'm kind of worried that maybe it just always says that because I'm stupid or something. So let's just try, like, one of the old ones. Well, actually, well, this also technically is bit pairs in the inverted order, isn't it? Oh wait, well, hold on. Mirror images of each other, bit pairs in inverted order, and inverted endingness. Okay, that makes sense. Yeah, I'm always paranoid. Like, if things are working too smoothly, I'm like, I'm not that smart. If things are working too smoothly, something, this is fishy, right? That's kind of how I think of it. Okay, so you're saying these two values as well? Let's, yeah. Yeah, exactly. It comes from a lot of hours of, right? Like, you do not want to be developing on a broken foundation, right? So if you think you're on solid ground, but you're not, bad times, man. So let's open up the calculator. And let's try this out and see what happens here. So we're in the hex. Let's paste that hex value, and let's take a look at that. So, up. Let me do that again, because I don't know what I'm doing. Okay, so, and then in the binary, let's just copy this. And I'm gonna move this on over. I'm gonna separate this up here. Let's move in here a second. Okay, now I'm going to take this, and I'm gonna manually kind of flip it around and see if I get the value you have there. Okay, so this is what we're expecting. So let's take that and let's paste it. Control V. Okay, so 1C84, indeed, you are correct. Okay, and then one more paranoid little check is where I'm going to take the actual value, paste it, and then I'm going to token highlight it and make sure that both this and this highlight, and indeed they do. Okay, cool. So I think, you know, three tries is enough to where, you know, I'm happy. And the next thing I might want to do is, well, what's the next thing? I mean, we got endianness. Endianness is clusters of 8. We could try nibbles, right? Since we already had pairs of 2, endianness is just pairs of 8 bits. We might as well try pairs of 4 bits, right? We've done everything else. We might as well cover everything, right? And then after that, I think I have enough checks to where I think this utility is good enough for my main code base, and I'll just kind of paste it into the code I'm working on, into like a function somewhere, and give it some use to see if it actually if it detects something, right? And it might actually clue me into some mistakes I'm making in my code. So let's give this a run. So let's just go up and delete this and go 0x1234 and 0x1c84, right? So let's take that. Bit pairs in inverted order, and nothing else showed up. So that's good. Okay, so yeah, I'm pretty satisfied with that. I think that we could go through some of the other examples and just see what they get. Well, we've already tried this. Is there one where we can do... This is inverted endianness. I don't know, let's just try things and see what happens, but I'm pretty satisfied right now. 0xd0f0. Inverted endianness. Okay, cool. Mirrors of each other. So if we do this and we do... mirror images of each other and the bit pairs are inverted. Now, can we get something that's just mirror images, but not? We don't have an example where it's just mirror images without if something is a mirror image, does that also mean that the clusters of 2 are packed in the wrong order? No, we should be able to get something that triggers this without... So we have this one that's triggering both of these. Can we get something that triggers just mirror images of each other but doesn't give me this? Finding a pattern that is at same time the inverse bit pair and endianness. I mean, that's an interesting exercise. I'm more concerned about isolating. But I mean, if you want to go try to find one, will I try to isolate? Right now, I'm just going to try to isolate something where I just have one that's a mirror, that only gives me mirror image, right? Because I'm getting mirror images and I'm getting this one too. I want to just get one error for this, just to isolate it. But yeah, I mean, that's an interesting thought, though. Let's see. So if I wanted something... Alright, you think about that. I'm just gonna twiddle some bits over here. Alright, 0x, something's whatever's. Alright. Do. Oh, that'll work. Yeah. And this will be flipped around. Okay, yeah, here we go. Okay. Oh, yeah, or actually, wouldn't that be... I mean, if we want to get pedantic with grammar, I think that would be, probably... I think that would be the that would be the proper grammar. You said your native language was, what, Portuguese or something? I'm not the best English speaker, though, so, and that was not what I wanted to do. Okay, cool, yeah. So let me tell you a story. Speaking of different languages, not related to my mom's bakery in Guatemala. Hold on, let me move this around. I'm going to tell you a story, but first let me just move this over here and figure out how to clear this. Bit shift. This is binary. Okay. Yeah, I got ya. No, I've done that before. I've done like 3 to 4 corrections in a row before, like when I'm like really scatterbrained. So, once upon a time when I was you found the holy pattern? All right, I'm interested. When I was a little kid, when I was in 4th grade, one of my aunts was dating someone from, God, I don't know where he was from. He was, like, from Brazil or some type of, like, Spanish kind of place, right? Like, Brazil or something. I don't know exactly where. Actually, maybe he was Portuguese. He might have been Portuguese. Hold on. Okay, it doesn't matter. Right, but some type of Spanish-ish kind of place. When he, Brazil speaks Portuguese? Okay. Yeah, so, he came over for, like, Thanksgiving or something, with my aunt, and my grandma was like, hey, you should show... Oh, his name was Willie. I don't know if that was his real name or if that was a nickname, like an English-ish nickname. But, my grandma was like, hey, you should show Willie your video games. And so, I brought him down to the basement, and I did not show him video games. I showed him the blow darts I made out of my grandma's sewing needles. So, at the time, as a kid, I found that KFC straws and McDonald's straws fit inside of each other perfectly. Like, KFC straws, at the time, I don't know if it's the same now, but KFC straws are slightly, just slightly, smaller than McDonald's straws. So you can you can fit them inside of each other perfectly concentrically, right? So the diameter of a KFC straw is the thickness. Take the diameter of a McDonald's straw and subtract the thickness times 2 of the plastic, and then you get the diameter of a KFC straw, right? They fit inside of each other very nicely. So you take the so I took the KFC straws and a craft glue gun and my grandma's sewing needles and some I think some feathers or something, feathers or some type of like material, right, to give it drag on the end. And I hot glued the needles into it, and then I gave it like a little wings on the end, and I made blow darts. And when I brought Willie down into the basement, we set up balloons in the basement, and we used the blow darts to pop the balloons. And the story of my life has been that every time I come across somebody who is not a American, they get introduced to me, and then they get a totally wrong idea about what being American is like all about, right? Because like, I'm also so I really like gothic industrial music and heavy metal, and I've spent much of my youth visiting industrial clubs. And one of the skills I have, because I also, when I was a kid, I did a lot of gymnastics, so I know like a lot of acrobatics, right? So one of these skills I picked up as somebody who frequents industrial clubs is I can out-pole dance most strippers. No joke. And I actually got the nickname for a while of, like, Sexy Jesus Stripper. But anyways, so, you know, fast forward in time, I got a German roommate, and I showed his parents my pole dancing tricks. So, like, you know, I mean, I think that, like, he was a little bit more educated, so he, like, knew what Americans were actually like, so he kind of knew I was weird. 'Cause, like, one time I was talking to him, and he's like, oh, yeah, I learned English by watching South Park, and I'm like, oh, that's hilarious. No, there's no striptease, just acrobatic stuff. They seem to be amused. But yeah, so like, yeah, so I do a whole bunch of weird stuff. But I don't know, I think that, I don't know. And also the thing is if you want to be honest, like, as a heterosexual, I care more about what girls think than I care about what boys think, right? Like, in terms of, like, what people think about me. And I will tell you that being acrobatic is a plus. So if you're straight and you want to get laid, being acrobatic is a good thing. So just throwing that out there, that's a pro tip. So that's, I don't know if that's, like, not appropriate for this stream, because, like, right, it's like, is that technically not, like, is that technically mature audiences? I don't know. No one else is watching this, so it's not like I'm gonna get flagged. But yeah, so I do crazy stuff. I know a lot of, well, I probably don't know too many crazy people. I know a few crazy people, though, probably. But yeah. I mean, well, yeah, I mean, there is that can happen, yeah. But, like, think about this, though. Like, how many times have you, well, okay, well, maybe you haven't, but, a lot of times when somebody is like, a lot of times when somebody, like a girl says, like thinks somebody is gay, like regardless of what they might think about what their initial assumption is, like a lot of times you hear, oh my god, that guy's so hot, too bad he's gay, right? You hear that a lot, right? So you gotta think about, you don't want to even worry about that impression, right? Because like a lot of times it's like one of those things where like girls kind of be like, they make this assumption that if you're attractive that you're either taken or gay, right? So like I don't even worry about that, right? Yeah, like right? Like it doesn't matter what their initial assumption is, right? Because like if you have a girl come up to you and ask you if you're gay or not, that usually means they're interested. So like yeah, I don't even worry about that. But yeah, I mean, it's like, I know like a lot of Latin culture, right, is like pretty macho, or at least from what my mom tells me. It's like machismo or whatever the hell. I don't know, man. I think when it comes to masculinity, the only masculinity you have to worry about is knowing that you're a man, right? Like, fuck whatever everybody else thinks. It's like, if you think you're a man, then you're a man. End of discussion. That's kind of like how I think of it. Okay, so anyways, we were like trying some stuff here with like inverting some binary values, and then I got distracted. But let's get the calculator open here, because I see that I got this little binary value here. And you said you found the like super magic number that could do everything, right? You were like, you found that number? Or you thought you found that number? Anyways, I'm gonna just try this out. I'm gonna copy this, I'm gonna paste this binary. So here's the decimal, or the hex. Copy that. Put that over there. Take this. Paste it over here. And that's just an A. It's just an A. Okay, and this is going to be 0x. Is that correct? Do I know what I'm doing? I don't know. I'm going to try, I guess. It was a brain fart. I was comparing the... Alright. Okay, so let's try this. So, BPA U16-.exe, and we're going to try this hex value and then this hex value. And we're expecting they're going to be mirror images of each other, and I'm hoping that I'm not going to get any other error showing up. So yeah, mirror images of each other. Awesome. So I think the last thing we're going to put in here is we're going to put in clusters of... if we ever decide to pack things by nibble, right? So we've already kind of packed things... Well, hold on. So this would be endianness, right? If we pack things in clusters of 8, but we haven't done any clusters of 4. So I'm going to take the algorithms that we're looking at, and I'm going to guess that... Right, we took this original formula right here, and we modified it for clusters of 2 bits. We can probably further modify all of this to make it clusters of 4 bits. So I'm going to try that. So clusters of 4 bits, and that would be nibbles or nibbles. Right? And indent that. Okay. So yeah, I'm gonna try to get this working, and then after that, I'm gonna say ship it. I'm gonna say it's done, and I'll post it up on You know that thing on the internet? What do they call it? Oh yeah, that thing I use every day that I don't know what it's called right now. Not Stack Overflow, that other thing. Oh, the GitHub, yes. Okay. So if we want clusters of 4, like everywhere we see 2, we can probably just replace everywhere where there's a 2 with a 4, and then we're probably done, right? We can just go 4, 4, 4, and 4, and we're really close, but we almost royally screwed up because we have a mask here. This is a 2-bit mask. We need a 4-bit mask, and that would be, a 4-bit mask would be the number 16, right? So the mask, yeah, the mask right here is a 4-bit mask, right? So let's open the calculator, do a little sanity check here, right? So if we are in decimal and we do 16, oh, it's not 16, it's 15, right? So if we go out to, so this is why I wanted a sanity check. It's 15. Okay. So that would have not worked out very well for me. And I'm going to say nibbles in inverted order. So right here I'm going to just say the nibbles are inverted order. And this comment really doesn't make sense anymore. I probably pasted that a few times, so let me... our inputs mirror images of each other. Not true there. And that one's true. Okay, cool. So this cluster of 4 bits, we're going to say the nibbles are inverted orders, right? So... Alright, yeah. So I think I'll give that a shot. So we got to compile it again. BPAU16 .sh. Clear that. And we actually kind of need an example where the nibbles are in inverted order before we can actually try that out, right? So down here, let's make another example. Oh, also, let me take note of the error message. Nibbles in inverted order, right? Or whatever the heck I said it was. So let's take this. And nibbles in inverted order. And we're gonna say, I don't know. We're gonna open up that calculator and try something. So binary. Actually, no, we're not gonna open up the calculator. We're just gonna do this by hand first because that's probably gonna be the simplest way. So we're gonna say nibbles are the clusters of 4, right? So it's kind of like an endianness inversion. But not, because we're not looking at bytes, we're looking at nibbles, right? So let's do something like this. And then... So I like how this has, like, it's mirrored. So I'm going to try to do the same thing, but like that. So I like how these two are kind of mirrored in on each other, and these two are mirrored in on each other. I don't know, I'm just a sucker for symmetry. And then also it makes it really easy to flip this around, doesn't it? Because now, to flip this around, since these are mirror images and they're shifted over here, ooh, or am I making a mistake here if I do that? I think I'm making a mistake if I do that. I'm going to just do this. I'm just going to do this one at a time here, because I'm afraid that I may be wrong about that. So I'm going to take this, and we're going to take all these. What the hell? WTF? These are the same, these are the same. Interesting. Okay, that's interesting. So this here, if I take these, if I take this, really? So if I take this last one and I paste it here, I take this one, I paste it here, I take this one and I paste it here, I take this one and I paste it here. I get the same exact damn number. So it's with this number, so this is interesting. So the number is equal to itself. However, when we look at this, I'm pretty sure that we've swapped the yeah, okay, yeah, that makes sense. Yeah, we've swapped the nibbles, but by doing so, we have a number that's equal to itself. So we don't see so right now the utility is only going to tell us when it's not equal to each other. So maybe we want to rethink that decision, because sometimes there's patterns in it when it's equal to itself. So when it's equal, so how do we do that, right? So we said like so we decided to like do this analysis of the inputs, but only if they're not equal to each other. I'm not sure if that's the best idea there. Like, I think maybe we should remove this guard here and always analyze it, or something. I don't know. I don't know how I feel about that. Because this one is... Yeah, I'm not sure how I feel about that, but let's just take this here and give it a shot. So let's put this in the calculator here. So binary, paste it, take that hex value, and okay. So we know this one's probably not going to say anything because they're equal to each other. So 0xb ddb and 0... Well, of course they're not going to do anything. They're the same. So they're the same, but they're also kind of the inverted versions of each other, right? Because they're completely symmetrical. Now, not all numbers are inverted numbers of each other, right? So basically, we have a palindrome, right? Is that the only case that kind of causes this problem here? Yeah. I think only a palindrome... I don't know. Is this a palindrome? No, this isn't a palindrome, though, right? It's not... Well, it's a palindrome in hex, right? But if we look at the bit value, it's not a palindrome. Okay, so that's interesting. So we might want to think about how we do how this code works. If they're... so what we're going to do here is I'm going to say, I'm just going to say that we're going to, like, make a little macro here. And we're going to just, define it up here, and we're gonna make it a 1. And then at the end of this section, we're gonna undef this. That makes things really ugly, but okay, so now if we run this, nibbles are in inverted order and they're the same, right? So I think that in some cases we might actually want to be able to compare even when they are the same, because there are some times when you find some interesting patterns with things that are the same, right? So this is my example that I did for nibbles in the inverted order, and I unwittingly made 2 values that were exactly the same when I tried to do something kind of random. So I guess we'll try again here, and try not to make the same mistake again. So let's just do like the nibbles were in inverted order, so how about all 1s, and then 1, 1, 0, 1, or how about this, and then 1, 1, 0, 1, and 1... Okay, yeah, so let's try that. So each one of these are different, right? No, let's... Okay, now each one of these is different, and so we're less likely to screw this up now. So let's take that and paste it over here. Copy that, paste that. Copy that, paste that. Copy that, paste that. Copy that, paste that. Okay, so let's just try this, man. Let's calc. Okay, so hex, or binary, we're going to paste it. We're going to take this hex value, we'll copy it, we'll paste it over here. Or we'll not. Okay, then we'll take this other binary value, and we'll paste it over here. We'll take this, we'll copy it, and we'll paste it over here. And then 0x. And we'll try this out in the utility now. So if we do 0x f9 db and 0x d or bd9f bd9f f9 db. Okay, nibbles in inverted order. Awesome. Okay, cool. So that looks pretty good to me. I think that we got like a nice little utility here. Now, I don't know if I want to compare when same. Maybe, I don't know. I'll just keep that here as a macro. I am not convinced that I want it as a parameter to this function. So yeah, I'd say that's good. We'll just put this in an examples to run on command line. So these are examples that we ran on the command line, so let's kind of like just put this in a nice little section over here. And then we will, well, we already have a console open, so let's go git status. Oh, it's not a git repo. Git init dot, okay. Clear git status. Okay. Git add dot git commit dash am. I'll just say usage bp dot slash bpa U16 dot exe. And then we'll do we'll do an example. So what's the easiest example we could do? FF00 and 00FF. I kind of like that one as a simple example. 0xFF 00, 0x 00FF. Okay, and then we'll just go to GitHub and we'll kind of like put that up there. So, right, we got something for GitHub. So on GitHub, let's go to GitHub. So I have 2 Git accounts. So the way we're going to do this is we are in, I want to put this in Kanji Coder. So I'm going to actually log out of my heavy metal cookies. I'm going to put this on another screen in case I accidentally show my password. I'm going to sign in. Heavy metal cookies. Oh, no, Kanji Coder. Kanji Coder. And then we're going to do... And then... Let's try that. Is that good? Alright, cool. And... Alright, so I'm going to post this down here. And we're going to say we're going to create a new repo. And we got public, we got the repo name. I know we keep on typing this, but I'm paranoid that I'm not going to type it right, so I'm going to put this over on this side. Okay, so I'm going to call it BPA U16. Okay, I'm searching the entire search space, but I'm not a believer. Search space of what? Are you trying to still find the magical value that just triggers every single message? I guess you could brute force it, right? You could brute force it, right? Like you could do a brute, right? Because it's only it's 16 bits, so that's only like what, 65,000 values, right? Roughly 65,000 values for a 16-bit integer. You could just, yeah, you could just brute force that, yeah. Oh, wait. To the power 2? Is it an n by n? It's an n by n loop with every single value. Because you got 2... Oh, yeah, because you got 2... Oh, yeah, because you got 2 values. Okay, yeah. Okay, yeah. Okay. So I was off by a few orders of magnitude there. But yes, I forgot that power of 2. That's okay, yeah. I mean, I think you could still I think you could still manage it. But a little bit more time than I thought. Okay, public BPA U16, BPA U16. Also, is that 7 letters? I'm very paranoid about this. BPA, 3 letters, 4, 5, 6. Oh god, no, that's not 7 letters. Wait. 1, 2, 3, 4, 5, 6. God damn it. Okay, so I'm OCD about this. I'm gonna change this namespace. All right. So let's see. Hold on. Let me scroll up here. What the heck am I going to call this? So I like to keep all of my namespaces to exactly 3 or 7 letters. And this is 6 letters. This is wrong. So I need to fix this. You know what? I'm gonna call it. How about that? So 1, 2, 3, 4, 5, 6, 7. Bitpack assert U16. Find next. That's what I'm gonna use. I'm gonna replace this, replace that, replace that, replace that, replace that. Okay, and now we have 1, 2, 3, 4, 5, 6, 7. 7 letters. I am going to delete the executable after I already committed it. Actually, hold on. You know what? Screw that. I can just delete this. I can just delete the Git folder. Doesn't matter. And I can rename this. So, Basu16. And rename this. Basu16. Then we can go into the build file, and we're gotta change that, right? Because it's like this thing. All these things are wrong now. So Basu16. Sure, that's what we're calling it. Everything is gonna be off by 1. Fix up our indentation. Okay, yeah. So. We'll give that a run. We'll just double click the script. Well, inner loops found nothing. Something something. Your contribution to science will not go unnoticed. Something something something. Okay. So git bash here. I thought Zoom was... Did I all of a sudden know... I thought... Why is my console not... Git bash here. I swear to God, Alt key... Hold on, suspend hotkeys, maybe. Did I just forget how to zoom in the terminal? I swear to God it was Alt mouse wheel, so why is it not... Whatever. Okay. So, I can't seem to zoom into this console, which kind of makes it kind of difficult for showing people what I'm typing. But let's just make sure this runs. So, we're going to do... so I see somebody else kind of stepped in. I'm just going to throw in my demo... I'm just going to throw in my demos while somebody's here. Oh, it's because the caps lock, maybe? I'm going to throw in my demos page, because I don't know who is kind of showing up. So I always like to just throw in my demos into the chat when I see that we have more than one viewer, and just be like, hey, I'm working on this stuff. Give my elevator pitch. I'm working on a fractal auto-tiling engine. Well, not right now, but working on a utility to help with that development. Okay, so we're going to do BASSU16. And then let's just use one of the examples. Keep this in the editor. Oh, that's right. No, because we renamed it. And 0xFF00, 0x00FF. Okay. So mirror images of each other. Yeah, that's mirror images. The bit pairs in inverted order. Yeah, I could see that as well. The nibbles in inverted order and inverted endianness. So it just triggers everything. Let's try to open this up again and find another example that doesn't trigger everything. So nibbles in inverted order. Let's try it with the F9 DB 0xBD9F. Nibbles in an inverted order. Okay, cool. I'm satisfied. Let's ship it. So git init dot git commit -am, and then I'm just gonna do a usage message. So usage, and then BASSU16.exe. And we'll do like 0xf9 db 0xbd9f. And, ooh, hold on. So if I'm doing this in a Linux terminal, /, and git add dot, I forgot to do that. Let's commit with the same message, because I don't, yeah. Okay, so let's go back to GitHub for a second, because we're gonna put this on GitHub. And I was like, yeah, that name isn't exactly 7 letters, and therefore I'm like, nope. And I changed that, so this is the name we're gonna use for this project, and also, well, one thing at a time. So paste this. Okay. And bitpack assert certs U16. Alright, so let's explain kind of what that name is for. Utility to check for mistakes when bitpacking 16-bit integers. Sounds good to me. Public. And yeah, so let's create this repo here. And then let's take this and copy that, and let's, I'm going to put that in my notes. So it is BASSU16 git URL. Okay. And I'm gonna be lazy here. I'm gonna sign out. Oh god, no, I don't want to sign. God damn it. Actually, I need to. So I have. Oh, so we have another person who popped in. So, here's my technical demos. I'm working on a fractal auto tiling engine. Check out the demos. That's all the stuff that I'm gonna use to create this engine with. Right now, I'm working on a utility to check for errors when I'm bitpacking values. So it's like a little assert statement that checks if two 16-bit integers are identical to each other. And if they are different, it looks for certain patterns to see if maybe I bitpacked things in an inverted order, or I made a mistake with the endianness, and a few other little pattern recognition things. So anyways, I'm logging into GitHub right now, so I need to keep that off screen just in case I accidentally show my password. So all right. Okay, so let's go back here, and we're gonna put this. We're gonna take this new repo, and we just want to make sure that my other account has access to it. We're gonna like invite ourselves to it. So if we look at manage access here, we're just gonna invite ourselves. So we're gonna invite ourselves because I don't want to have to go through the problems of reconfiguring Git because I have more than one GitHub account. The way we're gonna do it is we're just gonna invite ourselves. So bam, add heavy metal cookies to this repo. So Kanji Coder is the public profile I use for this stream, and everything on Kanji Coder is public. Like any repo on Kanji Coder is public, so you can take a look at it. But then my personal repo is heavy metal cookies, and that's kind of like what I'm logged into when I'm in a terminal. Like in this terminal, I am actually heavy metal cookies, so I don't have permission to push up to Kanji Coder stuff unless I actually give myself access here, which is kind of hackish, but that's the way I've been doing it. So, so let's sign in as heavy metal cookies. So I'm gonna put this off screen here for a second. Okay, let's give this a shot. Okay, cool. So now that I'm logged in, I need to go to my email and accept my invite. I don't know what kind of things are going to end up in my inbox, so I probably need to keep that off screen as well. So what I can do is once I'm at the email, I can kind of show you what it looks like in case you've never done this before. So Kanji Coder invited you to this thing. We said this stands for binary, or actually no, bitpack assert U16, right? So let's accept the invitation. And I had to log back into Heavy Metal Cookies. So this invitation is not going to work unless I'm actually logged into my Heavy Metal account. So these invitations just are, I don't know how they work, but they're pretty crappy. Where this invitation button does not work properly unless you are logged into the account that is associated with this email, right? So anyways, I made sure that I logged in, so I will accept the invitation. Okay, and now that I've accepted that invitation, I just did that so that I would have access rights to pushing up to that repo. So now if I do git remote add, and I'm going to create a remote called GitHub. I'd like to make my remote called git_hub, so it's very obvious that it's my remote name and not some type of keyword. We'll paste that there. Then we can do a git remote-v to see our remotes. It's definitely there. And then we do a git push GitHub master. All right. And git status. And it's shipped. So let's go over here and let's go to the Kanji Coder profile and take a look at the new thing and see if it's up there. So the thing we just wrote was this thing. So let's take a look at it. So here's the C11 file, here's the build script, and here's the executable. The executable is Windows 10 64-bit, so I mean, maybe I should write that somewhere. Or I will leave it as an exercise to the reader to figure out what this executable runs on. So yeah, cool. So now we got a little command line utility to help us figure stuff out. So what next? I mean, so this stream has to stay under 10 hours, because if it goes to if it goes past 10 hours, I can't upload it to YouTube, and I'm keeping like a log of everything I'm working on YouTube, like a linear log. So if you look at my stream and you look in the, like right down here, like I can't point to it because it's really outside of my monitor, but right there beneath there, you see that blue text down there? I'm trying to point to it the best I can. It says the day is Thursday, THU with a period, and the IID is 0101, which is not binary. That actually stands for 101, and that's the video number. So every time I record another video, I put the integer ID of the video. And the intention for that is that sometimes when I'm working on the main code base, I'll put the little timestamp of the video and what video I was recording at the time I was writing the code. So if there's ever an explanation that needs more explanation that can be done in text, I'll keep a video timestamp in the code comments so that you can go to the video archives and glean more information about what's going on, right? I don't expect anyone to ever watch any of these streams like all the way through, but I thought that a good way to make the streams kind of useful after they're recorded is that as I'm working on the source code, I can put these timestamps into the source code to the video documentation for whatever I was working on at the moment. So that's kind of what I was doing. So the next thing I want to do is just take this utility I've written and put it into my test code. But I do think that, I don't know if I'm going to bed or not. But I think I do want to start another stream at least, but I think I might want to take a little break. And the next thing I'm going to do is, it's going to be boring, right? It's going to be more of that just really ridiculous, complex, like, unit test code that's just like I barely know what's going on, right? So like it's gonna be the hard to follow unit test kind of code. It's not gonna be that interesting. But I did have fun like writing this little utility. So I do think that like maybe every once in a while writing like little utilities to take a break is kind of fun, because since we wrote the whole code base in one stream, right, no one's lost, right? Like because you started watching from the beginning, and so there was nothing to what do you call it, right, when somebody's working on a huge code base, it's easy to it's easy to get lost when you're in a big code base you've never seen before. But at least by seeing this, I made it from the ground up, so there's nothing to really get lost with. You're welcome. So I think I am gonna clean this up a bit. This is kind of, I don't like how like everything is within my column limit except for this right here. So hold on. Because first I'm gonna change this to 1st first. And I'm going to remove the word supplied and just say expect exactly 2 user arguments. That way I can just keep everything in the column limit like that. I'm going to go over here, I'm going to do a git bash, and I'm going to commit those changes, and then I'm going to stop the stream. So git status, git add dot, git commit dash am, and never exceed the column limit. Git status, git push, GitHub, and master. Yeah, so I don't know if I'll be back. I'm not going to make any promises as to whether I'll be back soon or not. Depends on how motivated I feel. I did my 100 push-ups for yesterday. It is now 6 a.m., so it's actually another day, so it's time to do more push-ups. So actually, let me look at that before I stop the stream. Push-ups. That was 130. That was Thursday. I don't know if this checksum is quite correct anymore, so that's 300, 30, 60, 90. That would be 390. I'm off by 100, and I know I did not update this last time, so I'm pretty sure this is wrong, right? Having redundancy is kind of helpful. 390, so 1, 2, 3, 390. Okay, that makes sense. We'll reset this push-up counter to 0. Oh yeah, I do that on Mondays. So if you ever catch me on Monday, I don't get that crazy, but I do a 14 to 16 hour stream on Mondays, because Monday is the one day I drink coffee. And so coffee will really mess you up if you don't drink it all the time. If you drink coffee only once a week, it's basically a Schedule 1 substance if you only consume it like once a week. So yeah, get sleep. But we are done with this. We're out of here. But yeah, it was good meeting you. I had fun. This always kind of keeps me entertained, because sometimes I'm just grinding away at this code all by myself all the time, and so it kind of makes me go crazy. So I will see you around, and I'm out of here.